Good morning, happy Sunday. If you look at any modern high paying data engineering role today, there is one non negotiable skill that sets top tier engineers apart from the rest. That is Apache Spark. But let's be honest, most tutorials out there only scratch the surface. They give you the basic syntax, show you a standard data frame operation, and leave you to struggle when the real world production pipelines fail. I wanted to change that. Welcome to the ultimate end to end Apache Spark Masterclass. We are talking 9 plus hours of pure production grade engineering knowledge. Zero fluff, zero surface level explanations, just everything you need to master about distributed computing from the ground up. If you want to become Databricks certified associate developer for Apache Spark, or you want to crack any high paying jobs, or you are someone who's looking to learn about latest updates, this one short masterclass is exactly for you. To build this, I did not just throw together a few slides. I mapped out the entire ecosystem. Look at this syllabus. This syllabus is the most in detailed syllabus for Apache Spark ever available on the YouTube. We are starting right from problem statement, then manage Spark, then architecture, then components of Spark, then PySpark, Delta Live Table, Spark declarative pipelines, and even inside that, we are having a lot of subtopics. You can literally see that this is the most detailed one course ever available on the entire YouTube, and you can see the depth of this course. All the things, if you are going for a certification, if you are going for a job interview, if you are having some doubts in the Apache Spark, or if you are even building the latest Spark declarative pipelines, everything is there, and everything is there in a very, very detailed way. You can literally see the problem statement itself is having evolution, the problem with big data before the 1997. Then I had also discussed about the monolithic approaches, and then we had just mentioned the Spark introduction and the high level architecture, because we are having a most detailed architecture as the third topic. You can see we had covered the memory, out of memory, and we had covered all the five scenarios which come when we are working with Spark. Unity catalog is also there. Then you can see the narrow transformation and wide transformations, lazy evaluation, catalyst optimizer. Then you can see the PySpark detail. In normal courses, you can only see that they are doing some couple of PySpark transformations that they are wrapping up. But here we are not doing that. We are literally going for most widely used PySpark functions, from handling malformed records to joins to write outputs to UDFs to window functions, and a lot of things. You can literally read this out. Then we have a Spark SQL session where we have mentioned that if you are not a Pythonic person, you can still use Databricks, and how I had explained literally everything. Then all the kind of Apache Spark relevant joins, then deployment modes, then adaptive query execution 2.0, which is the latest one as part of Spark 4.0, and then a lot of other things you can read here. Then we focused on structured streaming, where we discuss about checkpoints, triggers, window operations. Then we had also discussed about the optimization techniques. And also we had discussed on the Spark Connect, which is the latest thing in the market, which is promoting the loosely couplement. Then obviously Pandas also is there in this tutorial. And then Delta Live Tables also is there. And then last but not least, and the most latest one, which is Spark Declarative Pipelines. That is also there, and we had literally covered Spark Declarative Pipeline using SQL as well as Python, because I know my community that some of you are not Pythonic person and some of you are very Pythonic person. So for Python people, you will get the Python code. For SQL persons, you will get the SQL code. So you can literally see the depth of this course. This course is gonna change your life. This 9-hour session is gonna make you stand away from all the 99% of the candidates which will be applying for the positions. By the time you finish these 9 hours, you won't just be writing the Spark code. You will be understanding the exactly what is happening under the hood of your cluster. It took me 4 months of continuous research, structured planning, and refining to compress years of engineering experiences into a single seamless tutorial masterclass. And believe me, guys, this course will be that course which even architects will be recommending to their team. I have put my heart and soul into creating this, ensuring it's the most comprehensive guide available till July 2026. A course of this depth easily costs hundred of dollars on premium platforms, but I believe top tier education should be accessible. This entire 9-hour masterclass is 100% free right here on this channel. Now, because this is an intensive deep dive course, you will have questions and you will also want to test your limits, right? You are not doing this alone. If you get stuck on any concept or face any kind of error or just need any clarity on any specific architecture, I am here to back you up. Drop your questions in the YouTube comments and I will answer all of your questions. Join my dedicated Telegram community and you can even book a free slot with me on topmate.io for direct guidance. Every single one of these support channels is completely free. My goal is to make sure you actually finish this course and master the tech. Also, all the materials, all the codes, all the diagrams are publicly available on my GitHub. You can literally go and download and access that right away. With that said, don't forget to hit the subscribe button, like the video and share with your friends to help them also to become a pro, because you are going to come back to this repo of the knowledge and I am sure on that. Without wasting further times, let's get started with the Apache Spark 4.0. Let's start with problem statement before Spark or even Hadoop. Let's go back to 1995 era and take the example of google.com. This is how google.com used to look like at that time, and you can see it's saying 25 million pages, and that's a lot. Anyway, at that time, there were a lot of pages getting created each and every day, and then these pages were getting processed by Google databases, and everything was running fine until this shifted to terabytes of data. Due to that, volume of data started going 100 times or even more, followed by velocity, where same amount of data started coming every minute instead of days. And then variety of data also increased coming, like photos, videos, MP3 files, and whatnot. And the systems started failing. And these are the initial 3 V's, which gave birth to a term which we call big data. Okay, so big data refers to the massive complex data sets that grow exponentially over time and exceeds the capacity of traditional database management systems to store, process, or analyze the data. It can be structured, unstructured, or semi-structured data. After some time, two more V's followed, that are veracity and value. And this whole 5 V's came the bottleneck for the companies, and this gave birth to big data. Now you will say, Jaswinder, we understood about big data, but what if a server is small? They might have increased the RAM, ROM, processor, memory, isn't it? I agree. This is exactly what they was doing earlier. Okay, let's talk about that. Okay, suppose again there is a Google search engine which is storing the data inside my server. Okay, everything is running fine. Whenever there is a big data requirement, they were simply increasing the RAM, processor, and memory. Everything was fine. There is no problem till now. What happened suddenly one day, due to some XYZ reason, the server gone down. Now what Google will do? At that time, they was hosting more than 25 million pages and the server is just down. This means no one can literally access anything, right? This is the another problem. This architecture is known as monolithic architecture. In this architecture, what they was doing is they were just increasing the server RAM, processor, memory, and they was letting the server hit. But eventually, at some stage, there is always a chance of failure. So when the failure comes or something happens in the server, immediately the impact was clearly visible on google.com. In order to overcome the monolithic architecture limitations, companies moved to distributed architecture system. So in distributed architecture system, instead of using a single server, they was using multiple servers. So the process was distributed across multiple nodes. So in this case, if the Google is hitting the servers, in this case multiple servers, there is no problem. Even though if a single node goes down, no problem at all. We have other 4 servers up and running. And this architecture is known as distributed architecture, and this is very important to understand, guys. This is where the journey of Hadoop will begin. Okay, earlier we understood the journey of big data. Now we had understood the solutions which was proposed initially, like monolithic architecture and distributed architecture. And this distributed architecture will become the base for Hadoop. Okay, and then only you can understand Spark. Cool. Now we know big data problem as well as monolithic architecture and distributed architecture. This whole bottleneck of big data problem gave birth to Apache Hadoop, which works on distributed architecture. Apache Hadoop is an open source software framework used for storing and processing massive volume of data in a distributed computing environment. Instead of relying on a single powerful computer, Hadoop clusters a network of inexpensive commodity machines to process datasets in parallel. It consists of 3 core components. First is Hadoop HDFS, second is Hadoop MapReduce, and on top of that, management layer which is known as Hadoop Yarn. So Hadoop HDFS is Hadoop distributed file system, which is very similar to the distributed architecture which we just had covered. And then Hadoop Yarn is our management layer, which is also known as yet another resource negotiator. And then we have Hadoop MapReduce. This is known as the processing layer. If we talk about today, among the Hadoop HDFS and Hadoop MapReduce is no longer getting used. From Hadoop, we still use HDFS because HDFS is distributed architecture framework. So this is again the backbone for the Spark, which we will be covering in few more minutes. But Hadoop is something which became very popular at that time. If you still ask a 10-year or 12-year of experience person, he will still praise a lot about Hadoop because it actually fasted the process of consuming and processing the big data. So Hadoop HDFS is still in use, but Hadoop MapReduce is now the thing of past. Now we know what is Hadoop HDFS. It's nothing, just a distributed architecture where we have a distributed file system framework. And Hadoop Yarn is a management layer. It's just the resource monitor which provides the resources and manages all the things. And the Hadoop MapReduce is the processing layer. Now I just told you that this is no longer used, but why? Why this is not longer used? For that, let's take one more step back and let's try to understand what exactly was the mapper and reducers, which is named as a MapReduce. Okay, we need to understand this first thing. Okay. So if we talk about MapReduce, this is the processing layer and this is also known as mappers and reducers. Mappers and reducers are nothing. These both are a kind of tasks within the Hadoop ecosystem. Okay. So let's say you have a 10 TB of data. Okay. And first thing, you will distribute the data using HDFS, Hadoop Distributed File System. And from this single 10 TB file, the file is divided into, let's say, 8 files. Okay, this is just an hypothetical example to help you understand what exactly is MapReduce. Cool. So now the file is distributed among the small chunks of files, and these files will be allocated to the mappers, which are nothing, just the task. So I had said the first file is, let's say, mapper 1, then mapper 2, mapper 3, mapper 4, and so on till mapper 8. These files are now the mapper task. So what mapper will do is, let's say these file contain this information. In first file we have welcome to, in second file we have the ultimate, in third file we have tutorial, and so on. In all the files, let's say we have some information. So what exactly mapper will do? Mapper will read this file and convert this file data into key value pair. Okay, like this one. So it will read that, okay, in first file welcome is coming one time, so it will assign the welcome as a value 1. Then again it will say, okay, 2 is coming one time, so it will assign 2 as 1. Similar way it will assign all the keys some values based on the number of repetition in the specific files. So once this is done, this information is getting stored in the local storage of the each and every machine. This is my first machine, this is my second machine, and so on. I am having 8 machines. So 8 mappers are actually storing all these information inside my local storage. This will become the bottleneck. I will tell you how. But right now, just understand that Hadoop used to store the information inside your local storage. Once the mapper tasks are done, it will go for shuffling of the task. And once the shuffling is done, it will go to the reducer, which will pull all these key value pairs and try to create a optimized task, and on top of that it will create the final output. So reducers will pull all the key value pairs from your local storage. So as you had seen completely, that map reduce is pretty much focused on your local storage, which is why the Hadoop became a bottleneck after some years. And then we moved to Spark, which was in-memory computation. Don't worry, we will cover that out. But now you understood what exactly was Hadoop and what exactly was the limitations with the map reduce, and that map reduce limitations of storing the data within the local storage became the reason that Spark was introduced into the market. So finally, it's the time to hit on Apache Spark. Apache Spark was introduced into the market, as you had already know. So now you know that the limitation in MapReduce was local storage, and Apache Spark is the alternative for MapReduce, right? So I had literally written it down here. Please do remember that this is most important point to note, that Apache Spark is the alternative of Hadoop MapReduce. It's not the alternative for Hadoop itself. Okay, we still use HDFS. Hadoop is still there. It's just the alternative of Hadoop MapReduce. If we go with the definition, Apache Spark is an open source, multi-language, unified analytics engine designed for large-scale distributed data processing. It processes big data workloads across clusters of computers by using in-memory computing. This is something which makes Spark Spark. Okay. Hadoop MapReduce was local storage, and Apache Spark is in-memory computing, which makes the Spark up to 100 times faster than the traditional disk-based system like Hadoop MapReduce. Now I guess you are very, very clear that what exactly is the Apache Spark, right? You know that it is in-memory computing and MapReduce was disk-based system. Makes sense? As you already know what exactly is the Spark, let's try to understand the Spark architecture. When I was learning Apache Spark, learning architecture was very tough for me. I was not able to understand. Then I even read the Spark books, and still it was very challenging for me to understand. And after a few weeks, I used to forget about this complete architecture. So for this tutorial, I am not going to directly dive into that Spark architecture, because I know that you guys will also forget the Spark architecture. So what I am going to do is I am going to create a story for us. This story will gonna help us to understand Apache Spark architecture. And once I am done with my story, then we will move to the real architecture. Cool. So let's first listen the story created by me. Okay. So what is happening? There is a code request coming into the picture. You are in your company. Okay. You are seeing everything there. And the code request came to your project manager. Okay. The project manager, as you know, it's a non-technical person. He don't understand the code. He just allocate the resources. He just allocate the employees and create a team who will work on this new project code. Cool. So what happened? This project came to project manager, and this project manager called the tech lead. Hey, tech lead, come here, come here. This is the new project. Okay, this is a new project, and tell me what exactly you need for this new project. This tech lead will analyze this complete project requirements, and then he will reply back to project manager that, hey, project manager, this project I can deliver to you if you give me 2 employees. So project manager will say, okay, no problem. Project manager will create 2 employees for this team. So now this tech lead requested for 2 employees, and project manager gave him both the employees. He reached out to employee A and employee B. Hey, Jaswinder, will you work for this project? Hey, Ayush, will you work for this project? Both of them said, yeah, yes. So then project manager said to tech lead, done. I had asked the 2 employees to contribute with you in this project. Project manager is happy now. Okay, he is very happy, and now he asked tech lead to communicate with both of the employees. So now tech lead will be communicating with both of the employees. Okay, in this way, project manager created a team who will work on the project task, and it will eventually come back to project manager once everything is done. Right? So this is a complete story which I want to frame for you guys. Here, project manager, you can say in Spark language, you can say he is the cluster manager. Okay. Tech lead in Spark language, you can say it's a driver, because obviously tech lead is driving the project. Okay. Cluster manager is allocating the resources to the tech lead, right? And then employees we will call as workers. This as a whole, you can say, is actually the Spark architecture. It is really the Spark architecture. All you need to do is just you need to see the Spark architecture documentation image, which I will show you. But this is literally the architecture. That's it, guys. Really, that's it. Okay. So now I will go to my next slide, which is Apache Spark architecture. And I will just show you the image provided by Spark documentation of Apache Spark architecture. And here is the image. Are you able to relate? Cluster manager is your project manager. Driver program is your tech lead. Cluster manager called tech lead, and then tech lead called cluster manager again, and then cluster manager created 2 workers. And then after cluster manager created two workers, he said done. And then driver program, which is your tech lead, started directly communicating with both of the workers. This is now very easy to remember. And I don't think that you gonna forget this one now, because we literally seen this by real world example now. Right? So Jaswinder, okay, this is very clear to us what is cluster manager role, what is driver program, what is worker nodes. What are these things? Executor, cache, task, and then there is also Spark context. What is this? No problem. Wait. So I will explain you one by one. First, I am really hoping that you are very clear with this. Okay, if you are really clear with this, comment down in the description box that it's clear. Cool. So now let's come to executor. Executor is nothing. It's just a responsible layer for executing the individual task. Obviously, project will be having some task. So all the task will be executed by this executor one by one, and it will store the results once the task execution is completed. This is all about executor. If you really want me to read the definition, I had even written the definition here. Executor is a distributed Java virtual machine worker process responsible for executing individual tasks and storing data for Spark applications. And then what is task? I guess it's self-explanatory. Task is the smallest individual unit of work which executor needs to do. That's it. Okay. The fancy definition here is a task in Apache Spark is the smallest individual unit of execution that can be scheduled and run on a single CPU core of a worker node. Cool? Makes sense? Last one is cache. It is something which is used to store the intermediate results. That's all I can say about cache, guys. So again, I will just read the definition. Cache is an optimization technique that stores the intermediate results in memory or disk of workers to prevent recomputation during subsequent operations. Make sense? Perfect, perfect. So now, Jaswinder, we know what is executor. Executor is responsible for executing all of my tasks. A task is the individual unit of execution, and the cache is exactly where my intermediate results are going to be stored. We are clear on these three terms. Now, what is this Spark context? Basically, Spark context is something which is used to interact with all these Spark core functionalities like Spark clusters, and it is also something which was responsible for loading data. Why I use the word was is because Spark context now is the thing of past. Nowadays, Spark context is not going to be used in market. We have a new terminology which is known as Spark session. We will cover that. Okay, but first, let's read the fancy definition of Spark context. Spark context is the original entry point of Spark functionality. It's responsible for connecting to the Spark cluster, loading data, interacting with Spark's core functionalities. So now, Jaswinder, you told that Spark context is no longer required and we use Spark session. How the Spark session is different from Spark context? And what exactly is this? What is Spark session even? Cool, wait. So Spark session made from three different contexts which was provided by Apache Spark. Those are Spark context, streaming context, and SQL context. Okay. So these three contexts was there earlier in the Spark. Now they had encapsulated these three into a single one, which is called as Spark session. The Spark session definition is the Spark session is the entry point with Spark. It provides a unified entry point. The important word here is unified. What is unified? It is taking all the functionality of a Spark context, it is taking all the functionality of streaming context, and it is also taking all the functionality of SQL context, and it became a unified platform in itself. That's why this is known as a unified entry point to interact with Spark functionality and to create the data frames and the data sets. We will cover about data frames and data sets, but as of now, you should know that this is my unified entry point as of Apache 4.0 to interact with Spark functionalities. That's all about Apache Spark architecture. Now, I don't think that you're gonna forget about Spark architecture because we literally understood this by a real world example. Do visit this one more time if you feel like you are not clear, because it happens that sometimes things are not clear, but I am sure that you are very much clear what I meant by Spark architecture. Let's now begin with creating the Databricks free trial account. For that, I will say Databricks trial account, and I will click on the Databricks trial account link. And here I will mention my email. I will click on continue with email. And then there will be a verification code shared by Databricks in my email box. I will just type it here. And then Databricks will give me two options, either to set up that trial version, which is the database community version, or either to set up with your own cloud. If I do the setup trial with the Express setup, it will only give me a limited access to all the things without accessing any kind of cloud provider, which I don't want. And I will go to set up with my cloud provider. So I will click on setup with your cloud. And once I click that, it will ask about all my details, and I will mention my all details here. And then it will say, what do you want to build and run with Databricks? I will select running and certification, and then I will click on continue. And then it will ask me to pick the provider on top of which I want to create the Databricks account. With this account, I will get $400 credit, and it is a 14 days Databricks trial account. And once the trial version is expired, I will be charged based on the credit consumed. So I will click on this AWS and I will click on continue. And then it will display an option continue to AWS Marketplace. I will click on this option and it will redirect me to my marketplace. And guys, you need to ensure that you also have an AWS account in order to do all the steps which I am doing. Else you need to go with the community edition. Okay. So now I am into my AWS and it is seeing Databricks data intelligence platform. And I just need to select here, try for free. And once I am into my subscribe to Databricks data intelligence platform, I will just go down and I will just click on the subscribe option. And it will say your request is in progress. This will take some time. Do not refresh. So it is actually setting up your accounts on the Databricks website. And perfect. I had successfully purchased the Databricks data intelligence platform. Now I will click on set up your account. And it will redirect me to enable my AWS Marketplace deployment integration. I will say enable and continue. And then I will click view subscription. And here I will click on setup product. And then I will click on setup your account. And then here I will select my region and I will also select my location as India. And then I will click on continue. And once this is done, it will say your AWS subscription has been successfully linked up. So now you will just click on your continue to Databricks. And it will set up the account for you. It might take few minutes. Now I will go back to my AWS and as you can see, my Databricks account is already linked. Now I will click on next and I will just go down here and I will just click on this checkbox and I will just say next. And then it will ask me to review all the permissions. So this is my default S3 bucket, which AWS will be creating. This is the role. So once everything is established, this is something which AWS do automatically for you. Then you will just click on launch product. It started launching all the required services which is required for this Databricks. It might take a couple of minutes. So we will wait for a couple of minutes. Then it will say the resources are successfully created and then it will give you the option of open Databricks. Once you click on the Databricks, it will redirect you to the Databricks admin page. And this is the Databricks admin page. And here it is provisioning my resources. And then I will click on my workspace. And here I got my Databricks URL and all the required information. I will just click on this one and I will move to my Databricks developer. We'll create a compute. We will name this as, let's say, compute underscore warehouse. And then I will say it's my personal compute. I will unselect the machine learning. Then I will select my Databricks runtime environment. Let's say I select 7.3 FPS. And after how much minutes of inactivity I want to terminate, let's say I want to terminate my instance after 10 minutes of inactivity. And then I will select my node. And as of now, I will just go with the default node. And then I will click on create. And it will start creating the compute. As of now, you can see it is creating the compute warehouse. This is how you can set up the Databricks environment on top of AWS. That's all, guys. Now, as we are pretty much clear on Spark architecture, let's discuss about what is Databricks. Databricks is a unified platform which was built on top of Spark. Okay, so in Spark, you need to manage everything, but in Databricks, you don't need to manage anything. Databricks is the managed service which was built by Spark people only on top of Spark so that you don't need to worry about anything related to management. Everything will be managed by Databricks for you and all you need to do is just you need to develop the projects, develop the innovations you are having. So the Databricks framework is a unified platform, which we also call Databricks Intelligence Engine. So you can do all the things. That's why we call it a unified platform. You can literally do business intelligence, data warehousing, data science, ETL, orchestration. You can have a Unity catalog there. It's like a unified data place where you do literally everything. So that's why Databricks Intelligence Engine is a unified platform. Okay, so if I go with the definition, Databricks is a unified cloud-based platform for data engineering, data analytics, and AI. Founded by the creators of Apache Spark, it provides a managed, scalable environment that connects your data in one place, eliminating fragmented data silos across the organization. So you literally have everything at a one place, and this Databricks intelligence platform use Unity catalog to manage everything in a single place. Don't worry. I know your question is what is Unity catalog? We will cover the Unity catalog in very detail because Unity catalog is the backbone of the Databricks. As of now, you just understand that it is a unified platform where you can literally do anything. Either you are a data engineer or data analyst or AI engineer or ML engineer, you can literally come together in a single platform and get your work done. So Databricks breaks down the traditional silos so your entire data team can use a single platform. If you are a data engineer, you can clean and transform a massive stream of data using the Delta Lake. If you are a data scientist, you can train your AI models, track your experiments using ML flow, and leverage the generative AI stuff. And if you are a data analyst, you can literally run your fast serverless queries, and you can also build the dashboards, and you can also generate the business intelligence information, and you can even do predictions. If we talk about key features of Databricks, there are a lot of features on Databricks. I personally love Databricks because of the features which Databricks provides, which actually differentiate Databricks with all the other competitors. It's really AI driven, it's really very fast, and it's also cost optimized. So the first feature I had written down is the Lakehouse platform. What this means is Lakehouse means it is combining all the features of data lake, plus it also combines all the feature of data warehouse under a single umbrella, and that umbrella is known as Databricks Lakehouse platform. It consists of data management and governance layer, which is the Delta Lake. It also have open data lake. It also have a data warehouse features. You can literally load structured, semi-structured, unstructured, or streaming data within the Databricks. It combines the cost effectiveness and flexibility of a data lake with the structure and reliability of a data warehouse. Next is Databricks Notebooks. This is the unified platform where team can write a code in Python, Scala, SQL, R, and they can share the notebooks within the workspaces, within the other developers, and they can literally come together to create a final one-stop solution. And this is possible using Databricks workspaces. We will come into that as well. Next is Delta Lake. Delta Lake is the optimized open source storage framework that serves as a default engine and standard table format across the Databricks platform. It extends the standard Parquet files by pairing them with the transactional log files, and it creates an enterprise grade lakehouse architecture. I will literally show you how they are creating the Delta Lake files behind the scenes. You will see the Parquet files are getting created. Then you will see a Delta log folder, and inside the folder you will see ORC files and JSON files. I will show you everything. You should know at least that what is Delta Lake. I will show everything, don't worry. But this is the definition of the Delta Lake. It extends the standard Parquet files by pairing them with the file-based transaction log, creating an enterprise-grade lakehouse architecture that delivers the data warehouse performance on top of cheap cloud object storage. Everything in Delta Lake is done on top of the cloud providers, whether it's S3, GCS, or ADLS. The other important feature of Databricks is ACID properties, which ensures the data integrity and consistency throughout the process. And then last but the most important one, which is Unity Catalog, which is the unified solution built by Databricks to help all the teams to come at a single place, to provide them a better governance, to provide them a single shared workspace environment, and whatnot. I am going to cover the Unity catalog in very detail. Just bear with me for a few minutes. This is the backbone of Databricks, and we should spend a good amount of time in understanding the Unity catalog. These are the kind of major key features of Databricks which makes the Databricks really a Databricks intelligence platform. Now let's discuss about the very important topic and the backbone of Databricks, which is Unity Catalog. And we will start first with the problem statement. One thing which I ensure in all of my videos is I always try to start with why and the problem statement, because that makes the concept more easy and more relatable, that why exactly we are doing this and what is the intent behind it. Okay, so here also I will first start with the problem statement, that why exactly Databricks required to introduce the Unity catalog. Before the Unity catalog era, I am talking about before 2021, around I guess May 2021. Before that, Databricks was having a isolated system where for every user you need to create a separate Databricks workspace. If you see this one, they had created a separate workspace for user 1 and separate workspace for user 2. And similar way, if you have, let's say, 10 users, you will be having 10 different Databricks workspaces. Okay, 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 that makes sense, Jaswinder. But what is the problem in this? The problem here is the single workspace was having its own dedicated metastore, which was known as Hive metastore. So literally, if I am doing something in my workspace, other developer, they cannot see what exactly I am doing in my very own workspace. So the complete system was literally in the silos. And if you have to restrict something, you have to restrict within the same workspace. And the same way, if you suppose you build something out here and the developer needs that thing here, they literally need to manually go and copy paste the things inside his workspace, and then only he or she can work on the next development part. So this was the very big challenge before 2021, and it was a really pain to manage the workspaces. I literally had faced this challenge when I was doing these things without Unity catalog, and it was really hell. I was building few notebooks, and one of my fellow colleague was also building few notebooks. So we was trying to sync up between each other, but eventually when we tried to sync up, we literally missed a lot of code, so which eventually leads to a lot of chaos, and we literally required to stretch late nights to get the code fixed. So there was a lot of challenges without Unity catalogs. Okay, so the first, I had written down the four major problems. The first major problem is isolated siloed workspaces. As I just told you, that each Databricks workspace was totally operated as an isolated silo. It was then connected to a local metastore. And let's say the developer created tables and schemas here in my workspace A. Let's say this is workspace A, and let's say this is workspace B. They were completely isolated to workspace B. This user don't know what he is doing. He is totally unaware about the workspace A. Then if workspace B requires something from workspace A, they literally have to copy paste everything from workspace A to workspace B. And they literally required to copy paste the table definitions, the metadata, the access control list, and whatnot to keep these distinct environments into the sync. And there was a high chance to get a miss of something, which eventually leads to more work. The second biggest problem which was there was compute bound security. If you see here, my workspace A is having its own clusters. My workspace B is having its own clusters. And similarly, other workspaces will also be having dedicated cluster systems. So there was no native way to restrict the access at an individual level. Either it's a row level or a column level. So there was the big pain of managing the very in-depth level of security. You just get a very rough or coarse fine-grained level of security. The third problem without Unity Catalog was there was literally a lack of native data lineage. So what used to happen is there was no data lineage which was automatically exist natively within the Databricks before 2021 or 2022 in order to track how a data asset was transformed from, let's say, raw files to final dashboard layers. We literally required to build the custom tracing tools, or we literally required a document where you can refer and backtrack that how this dashboards was built from the gold layer, and the gold layer was built on which tables, and which table from raw layer was used to build the staging layer, and how the raw layer is getting populated. Everything you need to document, or you need to rely on the external platforms to to get this data lineage. So backtracking was the very big challenge. It literally take hours of time to just backtrack a single bug in the production. Fourth one is the fragmented user and group management. This is something which is relevant to the problem one. So, but just I written it out so that it should look different, because it was required to configure and manage users and groups inside each and every individual workspace, which was a really headache for every time you need to do the same step, and it was literally repetition work. So that's why I had written down in the problem 4. So these are the major challenges. I'm not saying there are few other problems as well, but these are the very major problems which was there in the Databricks when Databricks was having no Unity catalog in the picture. Let's now understand the Unity catalog. So when the Databricks introduced the Unity catalog, they had separated the metastore and the user management from the workspaces, and the workspaces was only having the cluster, and everything was directly linked with the journal metastore where there was everything stored. So let's say you had a ADLS Gen 2 storage on top of the metastore. So if the workspace 1 is saving something on that storage, workspace 2 was also saving on the same storage. This provide a single layer where any amount of workspaces can access the containers within a single place. So if I go with the definition, Unity Catalog was introduced in 2021 is Databricks unified governance solution for data, AI, and analytics, which provides a single centralized layer to manage access control, data lineage, auditing, and discovery across all your cloud workspaces and regions. Literally, guys, like, because you are having everything in a single place, it is very easy to have a user management on top of that, and it is very easy to track the data lineage because of a single point of centralized data repo. You can literally backtrack any tables, any dashboards, and it will fast pace your analysis. Make sense? Now we literally know what is Unity Catalog and what was the problem which Unity Catalog is solving in Databricks. So it's the best time to also go ahead and understand the Unity Catalog features as well. So there are a lot of features like discovery, access control, lineage, monitoring, auditing, data sharing. I guess you already know because I explained you before Unity Catalog scenario, and you now know that these are the features and these are the problems which Unity Catalog had solved, and that's the only reason it became the backbone and very popular in the market. So everything here is under the hood of the Unity Catalog, whether it's your tables or files or models or your notebooks or dashboards or any kind of external auditing or monitoring or access controls, or you can even do data discovery. Everything is under the hood of Unity Catalog. Cool. Now, as we are already discussing about Unity Catalog, let's also understand the Unity Catalog architecture. So this is the image provided by Databricks documentation about the Unity Catalog architecture, where on top we are having a metastore, which is also known as Unity Metastore. A Unity Metastore is like a top level container for data governance and all the metadata management. And it acts as a centralized repository that registers the metadata about your data and also about AI assets such as tables, views, volumes, machine learning models, and external storage locations. So this is everything about the Metastore. It is the level 0 of my Unity catalog. Then come the level 1, which is the catalog. It is the container which is the foundation for the Databricks Unity catalog. It is used to securely organize and manage the access to all of your data, all of your AI models, your tables, your functions, your models, your views, everything under the same hood across your entire organization. Okay, Databricks uses a three-level namespace to locate the data assets, which we call catalog.schema.object. And if you have to locate the table, you have to say catalog.schema name.table name. And this is how it locates the data assets. This is very important to understand. Please take notes of the Unity catalog architecture. And as we are already discussing about Unity catalog architecture, I quickly also want to discuss about Databricks architecture. And by Databricks architecture, I am not meant about the traditional Databricks architecture because there are a lot of new additional features added. So I am going to discuss about modern Databricks architecture. So here, this image is also provided by Databricks documentation. Here, they had divided the architecture into 4 segments. First, they had called users and access. Second, they had called the management layer. Third is the compute layer, and fourth is the storage layer. And they had highlighted the things into 3 borders. First is the dotted border, which indicates the user or service access. Second is my orange border, which is my Databricks account itself. And third is my royal blue border, which is my cloud environment, either AWS S3 or ADLS Gen 2 or GCS. So everything it had retrofitted within this same architecture. So first layer is the user and access, where you have all the user created, where you have all the data sharing, all the IDEs, all the applications like dashboards, everything. So this is kind of the serving front end layer. So after that, they had put the authentication layer, obviously to ensure that the valid requests are only flowing inside a Databricks account. It is a part of Databricks environment. So inside that, we have a control plane like the traditional Databricks architecture, where we have Mosaic AI, web app, orchestrations, workflows, resource management, IAM. So everything is inside the management layer. And then we have a 2 kind of computes. First is the classic compute, which is provided by my external providers. And you can literally click on the create compute and create the compute on top of your external providers as well. Second one is the serverless compute, which is provided by Databricks. And based on your request, based on your traffic, it increases and decreases the compute size. And third is the API services. These are the external API services which we will be covering in the future tutorial. And inside the compute layer, they also have the very own Unity catalog, which we just had discussed. And these Unity catalogs, you can connect with either your cloud provider storage like S3, ADLS, GCS, and you can also attach Unity catalog with the Databricks self-managed storage inside the Databricks. So this is the modern Databricks architecture. The most important part here is control plane, compute, Unity catalog, and how we can integrate the external cloud storage within the Databricks environment. Let's now create a catalog. For that, I will just first go to the catalog, and then here I can see option called create. I will click on this create option and I will select create a catalog. And now I will give a catalog name, let's say bronze layer, and rest everything I will leave as it is, and I will just click on create. But before clicking on create, there is one option called external location. So you can create a new external location, or you can even mention the existing external location. In my case, I am having the existing external location as workspace. I can select that and it will immediately show me my S3 path on top of which this catalog will be created. Here I will select my workspace, my S3 bucket, and then I will click on create option. And see guys, it had successfully created the catalog and it is requesting me to provide the recommended permission. For that, I will go to configure catalog and below I will click on next and I can see my bronze layer catalog is created with the default as well as the information schema. Now I want to discuss about storage location hierarchy. So as I just created the catalog, what do you think where this catalog got created? This catalog was created on catalog level, which is level 1. So you can also create the catalog on schema level. So if you create a catalog on schema level and you also have a catalog on catalog level, and let's say you had created a table inside the schema level storage, the respective table will be created on schema level managed storage location. It won't be created on catalog level managed storage location, even though you have catalog level managed storage location. The precedence will always be given to the schema level, then will be given to catalog level, and then will be given on the metastore level. So this is how storage level hierarchy works in the Unity catalog. Let's now discuss about managed versus external tables. Managed table are something which are created within the Databricks managed storage, while external tables are something which we are creating on top of the external storage. Databricks managed tables are valid until they are explicitly dropped, but external tables are valid even after they are dropped. Let's visualize what I mean. For example, this is the managed table. So the table is created on top of my managed data lake. Now I ran a drop query. I want to drop this table. So what will happen is this will drop the table, but this will also drop my managed data lake. This means if I try to retrieve the data, I cannot retrieve the data back. It's literally gone. But in case of external table, if I am writing a drop script on top of external table, it will only drop the table, but it will never drop my external data lake. If I query with the external location path, like select star from external location, I will still be able to see all my data. So the major difference, I guess you now understood. In managed table, when you drop the table, you are literally dropping the table, including the data. But when you are dropping the external table, you are just dropping the table template. You are not dropping the table underlying data until unless you go to that provider bucket and you delete the data from there. Make sense? Let's now also discuss about volume. This is also very an important part of the Unity catalog. So volumes are Unity catalog objects that govern access to non-tabular data. They provide a logical layer over cloud object storage so you can organize, store, and manage files within the central governance. So volumes are useful to manage and to govern the files. As we have tables, as we have views, we also add volumes, right? So volumes are useful in to govern the files. So Unity catalog supports two kind of volumes. First is managed volumes and second are external volumes. Managed volume, you already know the whole life cycle of the volume will be managed by Databricks, and the external volumes are something which is managed by the cloud storage location provider. Let's create a volume as well, and then we will wrap up the Unity catalog and we'll start with the next chapter. I am back to my Databricks. So first thing, I will click on this catalog and then I will go to my catalog which I had created, which is bronze layer, and then I will click on my schema, which is demo schema. And here, if I click on create, I will get an option create a volume. So I will click on this option. And here I will mention my volume name, let's say external volume, and then I will select here external, and then I need to mention the external location is, let's say, workspace, and then I will select my catalog as well as my schema, let's say in this case demo, and I will click on create. So see guys, it had successfully created the external volume, and now I need to upload files to this volume. For that I will click on upload to this volume, and I will just click on browse, and I will select a file, and I had successfully placed the fact sales file. Now I will just click on upload, and it will upload the file to my external volume. So this had placed the file, and here I can clearly see my fact sales file. So this is how we create the external volume. I know the spelling I put is wrong, but I guess you understood the point that. So this is how you create the external volume. Same way you can create the internal volume. For that, again, you will go to demo, you will click on create, click on volume, and then this time if you go and select the manage volume, you will be able to have a manage volume created. Make sense? Perfect. So with that said, I want to wrap the Unity catalog. Let's now understand the very important topic, which is the internal implementation of driver and the worker nodes, how these nodes internally work and get the task done. So first, let's discuss about driver node. So let's say you have this execution plan code, and you want this code to be executed, and you want the output. So first thing, this execution plan code will have to go to the driver node, which is nothing. It's just the JVM. So driver node consists of a JVM, and inside this JVM we have a function called JVM main. So when the code comes to that JVM main, it converts your code into the Java code. Under the hood, everything happens using Java. So you are submitting your PySpark code, let's say. So that code will go to the driver node, and the JVM will convert that PySpark code into the Java compatible code. And once that code is converted into the Java compatible code, Spark session will come into the picture. This Spark session is the entry point of any Spark application. It holds the configuration environment and allows you to create data frames, data sets, and RDDs. We will cover them, don't worry, but as of now, you should understand that this is the entry point where your things will get started. So once we are with the Spark session, it creates a plan and submit the plan to the DAG scheduler. DAG scheduler is a high-level scheduler. It takes the logical execution plan generated by your code, and it breaks down into the DAG, which is directed acyclic graph of stages, of multiple stages. It looks at the transformations, and it even determines where the shuffle boundaries needs to be happen. So it just split the job into stages based on either narrow or wide transformations, which obviously we will cover in next few minutes. But you should know that this is the very high level scheduler which splits the jobs into stages. Once DAG scheduler completes his work, it will submit the DAGs of transformations to the task scheduler. DAG scheduler was the high level scheduler. Task scheduler is the low level scheduler. It receives all the stages from the DAG scheduler, and then it is responsible for sending the actual task to the executors in the clusters. Okay, it even monitors the execution and automatically resubmits the task if they fail due to transient network issues or any kind of worker drops. So once the task scheduler had created the schedules or task, it will go to the scheduler backend. It won't directly go to the worker nodes. It goes to scheduler backend. So the scheduler backend is the bridge between the Spark and your cluster manager. It requests the resources from the cluster manager on behalf of the driver, that hey cluster manager, these are the tasks, these are the things which I need to execute, and on behalf of my driver node I need these many of worker nodes to be created. And then cluster manager says okay, no problem, and he will create the worker nodes, and he will reply back to the task scheduler that your work is done. This is the driver node internal implementation. So everything under the hood is working inside the JVM, and your code is getting converted into Java code, and then it is getting submitted to that scheduler, then task scheduler, and then scheduler backend is requesting the resources by becoming the intermediator. And once this is done, now we will move to the worker node. So the worker node will first listen to the driver node, And inside the worker node, again, we have nothing more than JVM. The JVM here have two kind of memories. First is storage memory and second is execution memory. And this is the core of the worker node. So the storage memory is dedicated to catching data like RDDs and data frames via the local block managers. And the execution memory is used for temporary storage during very heavy computation like joins, aggregation, and shuffles, and then it goes to the execution process. This is the primary workhorse in the worker node. It runs the multiple tasks load concurrently, as you can see. So this is how worker node works, and once the worker node does his work, it goes back to the driver manager and submits the things. This is how driver node and worker node works internally. Because of Spark, it is very important for us to understand the internal implementation, because this is mentioned in the certification PDF that we should know the internal implementation of driver and worker nodes. And I guess that's fair ask, because if you literally know what is happening under the hood, it will be very clear with you when you are actually working with your Databricks. You will see, okay, this is happening now and this is happening now. Make sense? Let's discuss about another interesting topic, which is memory management and deployment modes. So if we talk about memory management, we have two type of memory management. First is driver memory management and second is executor memory management. And you had already seen how driver and executor works and what is the role of cluster manager. Let's deep dive into driver memory management and see in depth of that how this is internally working till in the very depth. Okay, we will not just stop with what is the driver management and what is the executor management. Definitely not. We have to deep dive into the what is the root of this thing. Okay, so let me first read the definition. Spark driver memory management focuses on provisioning enough resources to orchestrate tasks, maintain metadata, and aggregate final query results without crashing the application. Unlike executors, which use complex unified memory structures for heavy processing and caching, the driver utilizes standard JVM resource structures supplemented by a specific container configuration. This is a definition, but to be very honest, to me, it looks very vague, and it does not make me understand the in-depth of the driver memory management, right? And I guess the same applied to you as well. So let's understand with the scenario. Let's say you are a developer and you ask the Spark that, hey Spark, I need a driver node with memory of 2 GB. Okay, so what Spark will do, it will spin two things. First, it will create JVM heap memory, and second, it will create off heap memory overhead. Okay, so this 2 GB will purely go to JVM heap memory, and this JVM heap memory is configured by spark.driver.memory, and this off heap memory overhead is configured via spark.driver.memory overhead. Okay, so now what will happen is the Spark will give the complete entire 2 GB to JVM heap memory. Okay, okay. Then what about off heap memory overhead, Jaswinder? Spark will assign additional memory on top of this 2 GB memory to off heap. What? Jaswinder, we requested for 2 GB. How is it possible that Spark will assign additional memory? Actually, whenever you request for driver node to be created for 2 GB, actually it creates little bit more than 2 GB. So the little bit part is getting assigned to off heap memory overhead. And how this little bit part is determined, Jaswinder, how it is calculated? It is calculated in a with a very simple calculation, which is max of either 384 MB or 10% of the driver memory. So if we talk about the 10% of 2 GB, it's almost 220 MB, right? So if we talk about max in this case, max is 384 MB. So this is how Spark assigns the additional memory to off heap memory overhead. And this is a very important and critical part of the Spark, and this is non-negotiable. Spark will always assign memory to the off heap memory overhead. Okay. So if we talk about JVM heap memory, it runs your all the execution codes and it maintains the Spark context and it tracks all the data structures, and the off heap memory overhead, it is
just there to handle all the non-JVM processes, any kind of network buffers or any kind of container overheads. Okay, so this is how driver memory internally is implemented. So now if I reread the definition, now it will make more sense, right? Spark driver memory management focuses on provisioning enough resources to orchestrate tasks, maintain metadata, and aggregate final query results without crashing the application. And this is known as JVM heap memory. Here in first line, they are talking about JVM heap memory. Unlike executors, which use complex unified memory structure for heavy processing and caching, the driver utilizes standard JVM resource structured, supplemented by the specific container configurations. And these container configurations are nothing, just off-heat memory overhead. This is how driver memory management is internally implemented. And this is the most in-depth anyone had explained till now. Okay. And trust me, guys, it really took me a lot of effort to gather all this information into a single place because I really love you guys. So now, as we are clear about how the Spark is assigning the memory to JVM and the off heap memory, let's understand the driver memory management out of memory error. What? What, Jaswinder? Out of memory? How the memory will be out? We can understand to some extent that out of memory can happen with the worker nodes, but how the out of memory error can come in driver memory? Let me explain you. So it happens, guys. It don't usually often happens, but there are few cases where we will see the driver out of memory error. Okay, let's discuss that part. Let's again say you are a developer and you submit the code to your driver node, and that code is of 10 GB. Okay, and as you know, the driver node is having JVM heap memory which have size of 2 GB. So now what will happen? The driver node got the 10 GB, and that 10 GB is distributed into multiple partitions into the multiple worker nodes. Make sense? This is clear, right? So now you requested df.show. So when you request df.show to driver, it will just take a one partition and it will give you the result. Okay. So the complete file was 10 GB. So as of now, you mentioned df.show and it took one partition, and one partition size is 128 MB. So it delivered the result to you. Now what will happen? You wrote another command. You said df.collect or df.take. Now what will happen? The request will go to JVM. JVM will reach out to all the nodes, all the worker nodes, and the complete partitions will be fetched out from all the worker nodes, right? So now the worker nodes complete partition is of almost nearly of 10 GB, but my JVM heap memory is of 2 GB, isn't it? Like, I guess you got it. So now the memory is only of 2 GB, but the data which it is trying to receive is of 10 GB. This is not possible, right? That's why it will say no. No, Jaswinder, I cannot serve you the result. I am throwing you the error of out of memory because you only assigned me 2 GB and you want the output of 10 GB. How I can do that? I can do that. It will simply return me out of memory error. So this is the scenario where even driver nodes can give the out of memory error. Cool. Let's now understand the executor memory management, and let's again take the example that you are there and you requested the Apache Spark that, hey Spark, I need the executor memory of 10 GB and I need total number of, let's say, 5 executors. Okay, now what Spark will do? Spark will create the JVM heap memory in the same way it created the JVM heap memory for the driver node. Then Spark will create the off heap overhead memory. Okay. Okay, Jaswinder. Same, both of these things was also created in the driver. What's the difference? The difference is Spark will also create the PySpark memory. Oh, okay. The executor memory is 10 GB. So complete 10 GB will go to JVM heap memory, right? So this had flown to JVM heap memory. And you already know that of heap memory is additional maximum of 10% or 384 MB. This will be created. And then we have PySpark memory. So JVM heap memory will be used for all kind of executions. And you already know that it is configured via spark.driver.memory. Similarly, off heap memory in the executor is again used for non-JVM task, and it is configured via spark.driver.memory overhead. Now let's talk about what is PySpark memory. So PySpark memory is the memory that is consumed by the Python processes in order to evaluate your UDFs or PySpark codes internally. Make sense? Perfect. So now we need to deep dive into this one executor. So let's say this is the executor, and obviously in the executor we have JVM and off heap overhead, and JVM memory is 10 GB and off heap overhead for that executor will be roughly 1 GB, right? So now let's deep dive into JVM heap memory. So we will now go more in depth. Okay. So JVM heap memory is 10 GB and it consists of further three memories, which are reserved memory, unified spark memory, and user memory. Okay. Now we will divide this 10 GB between these three memories. Okay. So reserve memory, as the keyword is reserve, this is reserved by Spark and it is hard coded to 300 MB. Okay. And it is used by the Spark engine itself. So out of this 10 GB, 300 MB is reserved totally for the Spark and it is non-configurable. You cannot configure this and you cannot tweak this 300 MB. Okay. You are now left with 9.7 GB. Now, out of this 9.7 GB, 60% of the memory will be allocated to the unified Spark memory via spark.memory.fraction. Okay. Now, what is the 60% of 9.7 GB, which is 5.8 GB? So, this means out of 10 GB, 5.8 GB will be allocated to the unified Spark memory. Are you seeing the things? How the memory distribution is happening? So the purpose of unified Spark memory is to use this memory for core operations like execution and storaging, and we will see this in more detail. But you should understand that 60% of the memory is allocated to the unified Spark memory. Now, the last one is user memory. User memory is 40% of the left 9.7, which is 3.8. So if we sum up 5.8 and 3.8, roughly we will get 9.7. Isn't it? The rough will be 9.7 GB. So this is how JVM heap memory is allocated. And the purpose of user memory is that it stores UDFs, internal metadata, Spark, lineage transformations, variables, and all the objects which are created within your UDFs. So now we will dive one step more deeper into the unified Spark memory because that is the memory where actual execution will be happening. So before moving to the unified Spark memory, you are clear that initially the memory was 10 GB, but now as we are moving into unified memory, our memory is only of 5.8 GB, right? So now we need to focus on this 5.8 GB allocation. Let's go to unified Spark memory. Now unified Spark memory, which is of 5.8 GB, is also divided into two memories. Oh my God, Jaswinder, that much detailed. Yes, guys, this is exclusively for you guys. So the unified Spark memory is further divided into storage memory and execution memory. Okay. And by default, both of the memories are allocated 50-50%. So this means out of 5.8 GB, 2.9 GB will be allocated to storage memory and 2.9 GB will be allocated to the execution memory. And this is configurable, guys. You can configure this using spark.memory.storage fraction, and you can increase the execution memory as well, and you can increase the storage memory as well. Okay, based on your needs. And we will cover that by using 5 scenarios. But first, let's understand where the storage memory will be used. So storage memory, I guess it's self-explanatory and you already should have guessed it. It will be used in caching, and the execution memory will be used in the actual execution of the task. Make sense? So now if I say that you have a 10 GB allocated to your JVM heap memory, you now actually knows that out of that 10 GB, you can only use 2.9 GB, or let's say max to max 3.5 GB. If you take storage memory as well till some extent, or even you take all the storage memory, then also you can use max to max 4 GB. So this means if you have a 10 GB data, you cannot process the 10 GB data by saying, hey, my GVM heap memory is 10 GB. This means I am good. No, you are not good. This is actually why Spark understanding is very important, and this is the reason why Spark developers are very highly paid, because they understand the in-depth of the Spark engine. They understand how much memory they should be allocating and how these things will impacting the projects. Okay, learning Databricks is very easy. You can learn Databricks in 2 days, but learning under the hood how the Spark stuff is working is the game changer, is the factor which will decide whether you will be clearing the interview or whether you will be getting a high paying job or not. Okay, so now we have gone the most in depth of the JVM heap memory, which is the execution memory and the storage memory. And now you clearly know that if the JVM heap memory is 10 GB, the max to max I can process a file is of 4 GB. Okay, cool. That's perfect. Now, let's understand the scenarios for the storage memory and execution memory, because this is where you will be running and storing your things. So you should know the scenarios covering the storage memory and execution memory. I have covered all the scenarios, and total there are 5 scenarios. So let's discuss those scenarios. The first scenario 1 is, let's say you got the file of, let's say, 2.9 GB. Okay, so in case of 5.8 GB, which is allocated to execution and storage memory by 50% allocation, the file is 2.9 GB, so it will allocate the complete execution memory, right? So now what happened, there is additional requirement came. Luckily you have your storage memory empty, so there is no problem. We can literally shift this one this side. We can allocate the storage memory to the execution memory. This is the first scenario where if the execution memory allocation increases, you can literally increase the execution memory by shifting towards the storage memory. Now there is a second scenario. Second scenario is you have a file of, let's say, 3.8 GB. All the execution memory and all the storage memory is allocated. All we have now is the execution task as well as some storage memory task. Now we have more data to process. Now what will happen? I want you guys to think here. What will happen? If you say, Jaswinder, this time we should evict these things, we should just let these execution tasks go away, then you are wrong. If I just let these tasks go away, I am actually breaking the execution order. Let me erase it as well. I am actually breaking the execution order, which is very, very unethical. And you even cannot do that, to be honest. You are not allowed to do that. So what will happen? You want to process these as well. So the JVM will not allow you to evict this data. Okay. You cannot evict any kind of execution, but JVM will say, hey, okay, you want to process it. Let me see what storage memory allocation is. So it will see, okay, we have 3 storage memory allocations. So it will allow you to evict this data based on the least recently used caching. Let's say this is the least recently used caching. It will say, okay, I will evict this data. Let me grab the eraser. I don't want to spoil my images. So it will allow you to evict this data, and now you have evicted the data. Now you have other partitions, so it will again go for least recently used and it will evict that as well. Similarly, it will evict that as well, and now you have the space to allocate these execution tasks. So now these execution tasks will be allocated within the storage memory and it will be working as expected. This is the scenario 2. Make sense? Perfect. Now there is a scenario 3. Scenario 3 is that you have a couple of tasks and it already are sitting in the execution memory. Now your storage memory is full. And now you need more tasks to be getting cached. Okay. What do you think this time will happen? And I already told you that you can lift and shift between the execution memory and storage memory. So this thing will happen here. As there is a space in the execution memory, it will be used by storage memory and it will use the storage to cache the data. Okay. This is a scenario 3. Now let's understand scenario 4. In scenario 4, again like the scenario 2, complete execution memory and storage memory is full. But now there are a couple of tasks which you need to do. You will say, Jaswinder, isn't it this scenario is already covered? Yes, this scenario is already covered. But now I want to introduce one more complexity in this scenario. Now the scenario is that this is now in use block. Earlier, these blocks was just sitting in the storage memory and these blocks was not used by something which is already running parallelly. So let's say this block is used by this block. So it is running in parallel, right? So these blocks are now in use block. If I eliminate this block, other dependent task will fail, isn't it? Do you want that? No, right? We don't want that. We don't want to break the execution task because those tasks are the most priority for the JVM heap memory. So what you will do with this one? What will happen in this case is now only this will evict few execution tasks and it will transfer these tasks to the disk. Actually, the evict is the wrong word. I will say it will transfer the task to the disk, which is known as disk spilling. So once it had spilled the data to the disk, now this space is available. So now these tasks will be coming to the storage memory for their execution. Oh, so when the storage memory blocks are in use, we cannot evict them. Yes, yes, that's 100% true. Okay, Jaswinder, this is really cool. Okay, yeah, yes. Let's now understand the scenario fifth. Now, the whole execution memory and storage memory is occupied by the task because you know the maximum you can execute is, let's say, 4 GB, and a whole 4 GB is now utilized by execution memory and it even utilized all the some storage memory as well. Now there are few more execution tasks to be done. Now what you will do? I guess you should answer this question because we had literally covered this right away. Now what will happen is that it will again spill to the disk and it will allow these new tasks to be getting space in the execution memory. Okay, this is very, very important, guys. You should know these 5 scenarios. Okay, so now this way, all these scenarios are covered, the worst case scenarios, the best case scenario, and the scenario 1, which is the usual scenario. So now you know that if my execution and storage memory size is 5.8 GB, the maximum I can execute a task is of, let's say, 4.5 GB max to max. This is the really max to max thing. And if you are trying to process more than 4.5 GB, task or the specific partitions will be getting spilled to your disk, and it will be sitting in your disk, and it will be waiting until the time other executions are not completed, and then it will go back to the execution memory. Make sense? This is the most in-depth level I had explained you how the executor works. Okay, and there is literally nothing much more in that. So please do revise this at least 2 times, and please take notes. This is the most important thing for you guys as a Spark developer. This is non-negotiable. Okay, so now you understand all the things of JVM heap memory, the internal implementation of JVM heap memory, where we had divided the JVM heap memory into reserve memory, Spark unified memory, and user memory. Then we had covered the Spark unified memory, which was further divided into execution memory and storage memory. Then we had understood all the 5 possible scenarios as well. Now let's discuss about the spilling of disk, which will eventually lead sometimes to out of memory. So I had named that topic as executor out of memory error. Now let's understand how this will happen. So let's say you have a 10 GB file, and this file is having 95% of data with ID 1 and name Jaswinder. It only have 5% of data with name Keshav. Now what will happen? Because 95% of data is only the same ID, 95% data will be allocated to a single partition, isn't it? Yes. So the 5% data will create a second partition, which is partition 2. So now we will have two partitions, partition 1 and partition 2. Partition 1 will be having 95% of data, and partition 2 will be having, please don't mind my handwriting, I know it's very bad. Partition 2 will be having 5% of data. So by 95% of data, it means the partition size will be 9.5 GB. But, Tiswinder, our Spark unified memory is only of 5.8 GB, isn't it? Yes, guys. So this is my Spark unified memory, which is of 5.8 GB. And now I am trying to execute 9.5 GB of single partition. Swinder, can't we do multiple partition for this 9.5 GB? No, guys. Either partition will happen a single, either partition won't happen at all. You cannot do partition for the another partition. That is not allowed. So what will happen in this case? This partition, 9.5 GB partition, will come here, and it will see that the Spark unified memory is of 5.8 GB, which means that it cannot process this single partition. So now what Spark unified memory will do, it will spill the file to the disk, right? So now this window, the data is sitting in the disk. Okay. Now what will happen? After some time, disk will again try to give this file to my Spark unified memory. But again, the file size is 9.5 GB. Spark cannot process it. Spark will again give the file to disk. So it will go to a loop. You can see, right? It is going to a loop, repetitive loop, again and again and again and again, but nothing outcome is coming out. This is where Spark will see that no, things are not working well, and it will give you the out of memory error. It will throw you the out of memory error. So this is how executor out of memory error works. Okay. This is all about the driver memory management and executor memory management. And there is literally nothing left. If you know these things, and if you are explaining this to any interviewer, he or she will definitely going to select you guys. because this is something which 98% of the other candidates won't be knowing, but you will be among that 2% who will be knowing these things. Okay, because your pro explained you that. Let's now discuss about one really cool topic, that is narrow and wide transformations. You might have heard about these terms a lot, and these are really very important when it comes to distributed architectures. So if I talk about the differences, I won't be going through the fancy definitions. You can literally go to Google and read that out. I will just simplify what exactly are narrow transformations and what exactly are wide transformations, so you will never ever forget the actual difference between both of them. Okay, so let's talk about narrow transformations. So I will start with an example. So let's say you have this table, employee ID, employee name, employee city, and this table is very big, let's say of 1 TB. And obviously, when there is a table, this will be distributed across a lot of partitions. Let's say this table have two partitions. This is a hypothetical scenario, so let's assume it is two. So now let's say half data in partition 1 and half data in partition 2. And now I will say that, hey, Databricks, I want to filter the data based on even employee IDs. In this case, Databricks will go to first partition and it will say, hey, partition, how many employee IDs you have even? So it will say 1. So similar way, it will go to second partition and it will say, hey, how many even employee IDs you have? It will say 1 again. So then it will combine the result from both the partitions. It will just add the results and then it will display me the output. So here I literally don't require any kind of shuffling, right? So I had written it down here. We don't require any kind of shuffling. My work is just done to have a view on partition 1 and to have a view on partition 2 and filter based on the even IDs and give me the output. So this is known as narrow transformation, where we literally require no kind of shufflings. We can just go partition by partition and we can get the output. Okay, so the second case is wide transformation. We have the employee ID, employee name, city, all the details. This time again, there are a couple of partitions. So I am asking to do the group by on these partitions. So if I just do group by on this partition, do you think it will give me the exact result? No, right? Because here I am grouping by a city. The city is London, and in the second partition also I am having the city of London. So actually the output should be, there are two employees who are living in London. But if I just group by on partition 1 and give the output, and then group by on partition 2 separate and give the output and encapsulate them, it will give me the wrong output. So here I literally require to shuffle the data, right? So these data should be talking to each other. Then only I can give them the final desired output. So here shuffling will come into picture. And after the shuffling is done, then I will get the final output. Here I had placed the component wrong. First shuffling will come here actually, and then group by will come. And I guess you understand the things, but I will just do that for you. So this is the exact picture. So because the data is separated between multiple partitions, I cannot just go partition by partition and do group by and give you the answer, because that will be a wrong way to give you the output. So here first shuffling will happen, then I will apply the group by, and then I will get the final output. And this type of transformations are known as wide transformations. If I go with definition, narrow transformation process data within individual partition without moving or shuffling data across the cluster, whereas wide transformations require the data shuffling across the network to group or combine data. Make sense? This is the easiest way I can explain you the narrow and wide transformation. Narrow transformation does not require any kind of shuffling, whereas wide transformation indeed requires shuffling to give you the output. This is the very, very easiest way to understand the narrow and wide transformations.
Let's now understand the another very important concept, that is lazy evaluation. Lazy evaluation indicates that Spark does not run your code when you just submit your code to the Spark. It just create a optimized physical plan for you, and it will not run any of your code until unless a action is performed. So what I mean is, let me give you the example. Let's say this is you. Okay, you had written a very optimized code. Okay, or let's say even a code that both are fine. Okay, so the thing is, you had written some code. So now when you submit your transformations or your code to the Spark, it will take your code and then it will create an optimized plan on top of your code. But Jaswinder, what if my code is already optimized? I had written the code in a very, very optimized way already. Then also Spark will create its very own optimized plan, because Spark knows better than us that which plan will be the most optimized plan. So it will create the optimized plan despite your code is optimized or not, using the Catalyst optimizer. What is Catalyst optimizer, Suspinder? Wait, guys, I will tell you, but just let me get finished with the lazy evaluation first, and then I will walk you that what exactly is the Catalyst optimizer. Okay. So now, just as of now, just think that there is some optimizer in the Spark system, which is known as Catalyst optimizer. Okay. So now it had created the optimized plan, and it will stop. It won't do anything. It will stop there until unless you take the action. What do you mean by action, this Vinder? By action, I mean either to collect, either to count, either to do kind of display or show. These are kind of actions. So till the time you don't take the action, Spark will lazily sit on your optimized plan and it won't display any kind of result. I will show you this in action as well. But as of now, just try to understand that whenever you are submitting your code, it will just create the optimized plan and it will sleep. Okay. And then when you hit the action, immediately Spark will wake up and execute the code based on the optimized plan. Make sense? This is all about lazy evaluation. But now we also need to understand the subset of the lazy evaluation, which is Catalyst Optimizer. So let me give you another scenario. Again, let's say you are there, you submit all the transformations. So now I am going to explain you what happens under the hood. Okay. So now the what Catalyst Optimizer do is, it will take your code and it will treat your code as an unresolved logical plan. Okay, it will say this is an unresolved logical plan. And then on top of that logical plan, it will create a resolved or optimized logical plan. Okay. So once it had created the optimized logical plan, it will create couple of physical plans. Okay, like let's say this is my physical plan one, physical plan two, three, four. It will create couple of physical plans, and then it will start comparing these physical plans using the tool which is known as cost-based optimizer. And this is the inbuilt tool available in your driver node. So it will start comparing each and every physical plan one by one, which is the most post optimized plan. So once it founds the most optimized plan using the tungsten engine available in the Spark compute, it will select the physical plan, and this physical plan will go to the worker node for execution. Okay. So this is complete full-fledged how lazy evaluation work. I hope now that makes sense to you, that how exactly Spark evaluates, how exactly Spark creates the plan, and how exactly the plan is getting passed for the actions. Okay, let's now quickly read the definition of lazy evaluation as well. So lazy evaluation in Apache Spark means that Spark delays the execution of data transformations until an explicit action is called. Instead of computing results immediately line by line, Spark records the operation in a blueprint which is known as directed acyclic graph or DAG. Operations like filter, map, select, and group by do not compute your data. They merely update the logical plan. Okay. But the actions, while these operations like show, count, collect, save, display, triggers, it actually starts computation based on your plan. Make sense? So this is all about lazy evaluation, and I guess this is a very simplest where someone had explained on the entire YouTube that what exactly is the lazy evaluation. Okay, now let's try to implement the lazy evaluation. I will go to my Databricks and I will create a new notebook. And now first thing I will say df is equal to far dot create data frame. This is the generic way to create a data frame. Okay. Then inside this, I need to pass two variables. First is the data and second is the columns. Okay. Let's define that as well. In order to define that here, I will say data and I will create some data. And I will say data is equal to here and I will start creating some data. Let's say employee ID 1 and then employee name, let's say Jaswinder, and then my designation, let's say data engineer. And then I will again mention my next one and I will again put copy paste this one for few of times. So yes. So now here I will just change couple of things. Let's say Jaswinder Sahil, and then let's say he's a data scientist, and then let's say next is Ayush. So I will come back once I create the data. Now I also need to define the columns. So in order to do that, I will say columns is equal to, so columns is equal to ID, name, and designation. So now this had created my data, my columns, and now I am going to create a spark.create data frame function. By using the spark.create data frame function, I will be creating the data frame. So if I hit enter, shift plus enter, it had successfully, see guys, it had successfully created the data frame, but it had not shown me the results because I had not taken any kind of actions. Make sense? So if I just show you, it will only show me that data types and it will say PySpark.sql.connect.data frame.data frame. So it had literally created the data frame, but because I had not mentioned any kind of action, it hadn't displayed me the results. So this is known as lazy evaluation. Okay, now I guess you are very clear what exactly is lazy evaluation. Let me write it down here. This is known as lazy evaluation. So once you had evaluated your data, now let's display that data as well. So I will say df.display. Display is one of the action. So once I hit this df.display, I should be able to see the data. Let me run this and see guys. This is my action. So let me write a comment here as well that this is our action. Make sense? Perfect. Perfect. So now let me display you the optimized plan which Catalyst Optimizer had created. For that, I will say df.explain and I will run this command. It had created my physical plan, and as of now, because my data set was very limited and I hadn't performed any kind of actions like filter or anything, final logical plan is only having the table scan. But imagine if you have a very big code where you are doing a lot of transformations and pulling a lot of data and doing a lot of things, it will have a literally very big physical plan. Let me show you some physical plan image if I am able to find from the Google. So I will say df.explain physical plan. And then I will go to images. And if I'm able to see something, I guess this one makes sense. I will say open image in new tab and see guys. So this is how the complex physical plans will be looked like in the Databricks. So whenever we read the physical plan, we start it from the bottom. So first thing this is doing, it is scanning the existing RDDs
And then it is filtering that if the data is not null or is null or based on the requirements. And then it is going on the project level, and then the physical plan is completed. Then it is creating the optimized logical plan. Then it is analyzed logical plan. Then it is passed logical plan. So this is how the Catalyst optimizer works behind the scene.
Let's now understand the Spark ecosystem. So this diagram indicates the how Spark ecosystem works. So we have the data sources. On top of that, we have RDDs. Then we have data frame APIs. Then we have Spark streaming and other generic libraries. And on top of that, we can write our code in either Python, R, Java, Scala. And whenever we write the code, nowadays we write the code and treat the code as the data frame. We no longer use RDDs. But when we create the data frames, under the hood, Spark automatically converts the data frames into RDDs. So what is RDD now? RDD stands for Resilient Distributed Datasets. Resilient means if you are running a piece of code and it failed at some point, it have a very clear lineage to backtrack and go back to the previous step and then reinitiate the run from the previous step. So this is a very fault tolerant and also resilient, indicates the immutability of the RDD. So if you create the RDD, you cannot change the RDD. You need to create another RDD if you have to change the RDD value. Okay. So as the definition is saying, it can automatically rebuild lost or failed data partitions, which is fault tolerance principle. Second is distributed. Distributed, as you already know, the data is distributed into the multiple partitions and these are processed across the multiple nodes. So it's simple one. But in the RDD, distributed is also schemaless. So we don't have the schema, which eventually makes the optimization more hard if we directly create the RDDs. Okay, then third is dataset. Dataset is dataset. It's just a collection of your partition data. Okay. So now, Jaswinder, why data frames are preferred over RDDs? I guess I had touched based on that already, but there are three major reasons that Databricks shifted from RDDs to data frames. And the first reason is automatic query optimization. Because data frames uses the Catalyst optimizer to rewrite and speed up all the execution plans. This makes the query more optimized and it helps the Spark to select the most optimized physical plan where RDDs exactly execute whatever you had written within your code, which force you to manually optimize the code. Okay. And the second major reason was schema enforcement, which we had just discussed. The data frame knows the exact name and the data type of each column, and Spark can catch the errors early and adapt automatically, whereas RDD treats data as a very generic Java or Python objects. And the final is expressive API and SQL support. Data frames offer high level API similar to Pandas or R, as well as native Spark SQL support. You can perform complex joins, aggregations, and filtering using simple functions calls instead of manually writing a lot of mapping functions inside the RDDs. So this makes the data frame more efficient, and this is the reason this was retrofitted into the Spark ecosystem. Okay, let's now discuss about jobs, stages, and tasks. Once you submit your code by taking any kind of actions, the action gives the code to the job, and job create the tasks. So then the tasks are the units of parallelism which will be executing the code in parallel. Okay, so we are just saying that job is a thing which will command to the stage that please trigger the code. Okay, and then the stage are the different set of transformations which can be executed in a single pass. So let's say you had submitted the job and in the stage it had
a lot of transformation. It have first wide transformation, then it have narrow transformation, then again it have another narrow transformation, and then it have wide transformation. So what stage will do? It will create three stages, because first was wide transformation. So first stage will be on wide transformation. Then we have two narrow transformations. So it will create one stage for both of the narrow transformations, and then it will create the third stage for the wide transformation. So if I just write it down here, W means wide and N means narrow. So let's say these are the jobs which are submitted to the stage. In the job, I am having wide transformations and narrow transformations and then wide transformation. So the first stage will only be for this wide transformation. The second stage will only be for these two set of narrow transformations. Okay. And then the third stage will be of wide transformation. So in this way, there will be three stages created for that code. And then these stages will be passed to the task, and the task is the smallest unit of work that can be scheduled. Okay, let me remove this quickly. So if I go to the definition, a job in Spark refers to the sequence of transformation on data. Whenever an action like count, first, collect, and save is called on RDD, a job is created immediately. And the stage in Spark represents a sequence of transformations that can be executed in a single pass. Make sense? That is without any shuffling of data. When a job is divided, it is split into multiple stages. Okay, each stage comprises task, and all the tasks within the stage perform the same computation. Okay, so a boundary between the two stages is drawn when the transformation causes data shuffling across partitions, which we had just seen. That first is wide transformation, and then two are narrow, and then wide transformation. So, whenever this kind of scenarios happen, then only they distribute the stages between the multiple boundaries. Okay, this is the easiest way I can say the stage is. Okay, and the task is the smallest unit of work that can be scheduled. Each stage is divided into tasks. A task is the unit of execution that runs on a single machine. This is pretty much about jobs, stages, and tasks. So these are the most atomic level of flows which you should know. Let's now start with PySpark transformations. And first thing, we will understand reading the data using PySpark, and we will read the data from CSV files, JSON files, and Parquet files. So let's go to the Databricks workspace. And here I am in my Databricks workspace. First thing first, I will create a new notebook, and I will name this notebook as read files from PySpark. Read files, let's say using PySpark. PySpark. And then what I will do is I will go to catalog, and I will upload these files as a volume. I will go to my browse layer. I will click on this demo, and I will click on create a volume. And I will name this as, let's say, PySpark demo. PySpark demo volume. And I will make it as a managed only this time, and I will click on create. And perfect, I had successfully created my volume. This is my PySpark demo volume. And here I will click on this one, and then I will say upload to this volume. And I will click on browse, and I will upload three files. First is this Parquet files, then this weather file as well, and then my customers 100 file. So I will upload three files: weather.parquet, weather.json, and customer 100.csv. Okay, and then I will click on upload. So I had successfully uploaded all the three files. Now I will just go to workspace, and I will open this one, read files using PySpark. And here I will open my catalog as well. In parallel to that, for that I will click on this option, then I will go to my browse layer, then demo, and then my volumes, and then this is my PySpark demo volume, and here are my three files. So first thing what I will do, I will create a data frame. I will say data frame is equal to spark dot read. So this is the command spark.read to read the files. Let me give some context as well. So here I will give the heading as reading CSVs. Okay. And I will click on shift plus enter. And then here I will try to read the CSV file. In order to do that, the function is spark.read.format. And then inside the format, we mention the type of file. In my case, it's CSV file. And then I will say backslash and I will go to my next tab. Okay. And then here you can see Databricks is automatically recommending me what should I put next. But I will put my own thing one by one. So I will say dot option. And first thing I will say header. And then I will say true. Okay, and this I will say in the Boolean way because this is the much professional way to define the header. And what this option do is it will treat my first record as the header. Okay, and then I will again put one backslash and I will move to the next tab. And then again I will say dot option. And now I will say infer schema. What this do is it will go to my file and it will read the file content for first few records and it will detect the schema type, whether it's a boolean or integer or float. So that's what infer schema is. And then I will say dot load, and inside the load I will mention my CSV file. So here I will click on this option and I will just click, and here I got my CSV file location. All I just need to do is I just need to wrap this up inside the double quotes, and then I will just say df dot display. Okay, and this should work. Let me run this. It's it started running, hopefully. If you notice here, we are not able to see the jobs, stages and tasks because I am using the serverless. That's the reason I'm not able to see that. This had worked successfully. I had successfully loaded my CSV file data inside my data frame. So this is the data and it looks pretty awesome. This is how you can load the CSV file using spark.read.format. Make sense? Perfect. Let's now also load the JSON file. So I will again give a heading. I will just say reading JSON. Okay, and I will say shift plus enter. And now we'll create another data frame. I will say df underscore JSON. And again, I will say spark dot read dot, and see guys, I hadn't done anything, but Databricks automatically started recommending me what I should put next. Right? This is really awesome. That's something which I really love about Databricks. Now I will put my own. So I will just ignore whatever Databricks is saying. So I will say my format is JSON this time. Again, I will put backslash and then I will say option. And here I need to mention infer schema. By the way, infer schema is not a good thing to mention, to be honest. It might go destructive as well. It's always recommended to define schema because you never know, right? So next thing I need to mention is multi-line. Because JSON is a multi-line file, so we need to mention multi-line is equal to true. Okay. And then again, I will mention the last but not least, which is load. And inside the load, I will literally copy paste my location of the JSON file. I will just go to demo, then volumes, then PySpark demo, and I will literally click on these two arrows and it will automatically paste my location. And once this is done, again, I will say df json dot display. I guess this should work. Let me run this. And perfect. It had successfully ran and I am able to see my data
in all the columns. And if you notice, it is successfully detecting the data type for all the columns. 1.2 means double, 1.2 means double, ABC means it's a string format. So infer schema is very helpful, but again, there are pros and cons. So be mindful whenever you are using the infer schema. Okay. The last, now I will go with reading the Parquet files. Okay. So I will say shift plus enter. And now I will create another data frame, df underscore Parquet. And then I will mention again Spark. Please read the Parquet file. Okay. Here I will mention Parquet. And then I will just mention the load. And inside the load, I will just copy paste this Parquet file. And then I will just say, please display me this data frame. The df.parquet display whatever is the data inside this Parquet file. And I will just hit run. And see, guys, it had successfully displayed me the data for the weather Parquet file. This is something which is very, very helpful. And I really hope that you now understand how we need to load the data. Let's quickly revise. In order to load any kind of file, you need to mention spark.read.format. And inside the format, you need to mention the format of the file, either CSV or JSON or Parquet. And then there are specific options for specific file types. And especially this is valid for JSON, where we have the specific option exclusively for JSON file, which is multi-line is equal to true. So this is how we create the data frame by using the file. Okay. And this is something which we as a data engineer regularly do. We consume the data from the files and create the data frames on top of that. Okay. And then obviously transformation and other things. So this is pretty much about reading files using PySpark in the Databricks. Make sense? Perfect. Let's now discuss about handling malformed records. When reading a standard file formats like CSVs or JSON, we can use the option when we are loading the file using dot option, and then we can mention the mode parameter to control how can Spark behave when we are actually encountering with any kind of faulty lines. So we have three kind of modes. First is permissive mode, which is the default mode as well. It sets the corrupted fields to null and inserts the original malformed row into the designated error column. Okay. And then we have drop malformed. It silently drops any rows containing the elements that is not exactly matching with the expected schema. And then we have fail fast, which immediately aborts the execution loop and throws a malformed record in parsing exception. Let me show you how we can work with these modes. So let me go to my Databricks notebook. I will use the same notebook of reading files using PySpark. I will just copy paste my JSON one, and I will go to last and I will mention a text saying malformed records. Okay. And I will say shift plus enter. And then here I will copy paste my above script. And after the multi-line, I will mention the option. And then here I will pass the mode. See, guys, I guess Databricks is mind reader. So it actually reading my mind that what I am actually looking for. Okay, so I will just press tab, and then I will again press tab, and this is the permissive mode. And here again, I will just put backslash, and then I will run this one. And it has successfully ran the results. Similarly, you can mention here, let me copy paste. And you can mention here drop malformed. Just say drop malformed, and let's run this. So it will actually drop any kind of row which will not match with the schema. And the third and last one is fail fast. So I will just copy paste and I will just change here fail fast. And I guess you got it what I mean, right? So I will just run this as well, and my work is done and dusted. So this is how you can handle the malformed records using the dot option mode. Okay. Let's now try to understand how we can define the schema within the Databricks. Okay. So for that, I will again create a new notebook.
and I will just click here and I will say notebook, and I will name this notebook as define schema. Define schema, and yes. So in order to define schema, we have two ways. First is using the struct type and struct field way, and second is using the DDL way. Okay, I personally love the DDL way, but I will show you both of them. So let me first give heading to this. So this first way is using struct type and struct field. Okay, so let's understand this. Shift plus enter. I will explain you what is struct type and struct field, but the important thing to note is in order to use these functions, we need to import these functions. Okay, so I will say import PySpark dot SQL, import star, and then I need to import PySpark dot SQL dot types. Okay, this is the library from which we will import all these things, struct type, struct field, and other kind of data types. And yes, and I guess I just need these two things. I will just say control plus enter, and it will even start executing. So it had executed both of the code, and then here I will define my data first, and let's go step by step. Okay, so let's say I will just define two records of dummy data. Let's say Alice, and then let's say age, let's say 28, and then let's say his salary, and I will say 5500.50, let's say. Okay, and then let me define one more. I got few auto recommended by Databricks. I will just click on tab, and I will just remove the David from the picture. I don't need very big data to help you understand what exactly I'm doing. So this looks fine to me. I will just remove the comma. And then after the data, I will define my schema. So earlier, if you remember, we used to say infer schema is equal to true whenever we are trying to fetch the data from the file, which is a way, okay, which is definitely a way, but that's not a very good way, right? So the good way is either using struct type or struct field, or either to define the DDL. Okay, it is automatically recommending me the struct type and struct field. So I will just click on that tab, and I will explain you now what is the struct type and struct field. So the struct type is a collection of list of struct field. Okay, so let me write it down here. I will write the comment. Struct type is nothing, just a collection or list of struct field objects. So this is about struct type. So it's just a collection or list of struct field objects which defines the complete structure of a row in your data frame. So now we are clear about struct type. So what is this? What is these things? This is the name of the column, as you can clearly see, and this is my null label. If I say true, this means name can be null. But if I say false, this means name cannot be null. So basically it indicates whether the value is null or not null. So now let's understand the struct field. Struct field defines the metadata for a single column. Okay, it accepts three primary parameters. First is the column name, then the data type, then the not null. Okay, let's write that as well. I will say struct field defines the metadata of for a single column. Make sense? So now as I had created my schema and I had also defined my data, I will run this complete cell. Okay, indentation error, no problem. Thank you Databricks for fixing for me. Okay, indentation error is there. I guess now this is fine. Yes. So I had successfully ran my data frame. It's time that I should show you the data types. For that, I just need to say df.print schema, and I will just hit run, and see guys, it had successfully defined the schema by name, string, age, integer, and salary float. And if you see, null label is equal to true, which was our third parameter. Okay, this is one way to define your schema. And whenever you create the data frame, you can mention your data as well as schema inside that, and this will get your work done. Okay, but I personally don't like the writing struct type, then struct field, then name, then data type. A lot of things is required here, so I don't like it. So there is another way, which is known as defining the DDL. Okay, so let's give that heading as well. Defining the DDL. Okay, shift plus enter. And here I will show you how I actually define the schema. Okay, so for that, let's say I will say my DDL schema, and then I will add triple double quotes. And now I will see, guys, it is automatically recommending me. Now I will mention my column as well as data type, and then I will close the loop by triple quotes again. So this is how I like to define my real schema. Okay. So once this is defined, all I need to do is just to pass it here and my work is done. Okay. So this is the another way, and this is something which I personally like and I personally follow whenever I need to create the DDL, because it gives me the vibes of my data warehouse where I am defining my DDLs. Okay, so this is all about defining the schema. You can define either of the ways, both are fine. This one looks more professional, so that's why I personally love it, but it's totally up to you which way you want to use. Okay, now let's completely focus on the transformations. Okay, so I will create a new notebook and I will name this notebook as PySpark transformations. And now let's deep dive into the transformations. So first thing, I will just go to schema tab and I will just copy paste my libraries here as it is, and I will say shift plus enter. And then first transformation, let's talk about select transformation. This is the very basic transformation. So let's start step by step. In order to do that select transformation, I will go to my workspace, go to read files using PySpark, and I will copy paste my Parquet file code here, let's say, or JSON file, anything. So I will copy paste my Parquet because this is the widely used one being a data engineer. So I will just copy paste here and I will just do shift plus enter, and I will let this run completely. I want this one to be go up. So I have an option called move up. So I will just click here and it will move up, and now it looks pretty much beautified. So we have data, we have couple of columns. In general scenario, you will never be required to have all the columns, and that is also not an optimized way to have a select star. Usually we try to prune the columns which are literally not required. Okay, so in this case, let's say I only need min temperature, max temperature, and the rainfall index, and also let's say rain today. Okay, so if I need 3 4 columns, why I should do a select star on all the columns, right? That's not a good and efficient way, right? So in order to handle this kind of scenario, we can use select transformation. Let's create a data frame df underscore select, and I will just mention my df parquet. Will copy paste from here, and then I will say dot select. Okay, and inside the select there are two ways to define your columns. First is you can directly mention the column name. In my case, let's say this is min temperature, so I will just say single quotes min temp. And second way is to use the column function. Okay, and then mention the column name, let's say max temperature. So both are okay, both works as it is, there is no difference. But the second one is something which I personally like to use because it gives my notebook a professional look, and it kind of convey to the third person that this is the column which I am pulling. Okay, so it's up to you, both will work. So let me run this for you. Okay, column is notified. Okay, no problem. So I need to import a library which is pyspark.sql.function, and here I will import star. So this will import all my SQL functions. So it's very important whenever there is a error like that, you should import all the libraries instead of importing a single library. So again, I hadn't ran this. So let me run this as well. So I ran this now. So this time it should not be throwing me any kind of error. So let's run this time. And yeah, perfect. So if I say df underscore select dot display, I will be able to see only two columns. See, guys. So both ways are fine. You can go with any of the way, but I personally like using this one because it looks very professional in the notebook. Okay. So this is the select statement. Okay. So let me copy paste this select statement and let's now discuss about alias. So alias is like how we can rename the column. If you want to rename the column, this is the function which you can use. So in order to use the alias, all you need to do is just after your column mention dot alias, alias, and then the max temperature. Let's say I want to name this as maximum temperature. Okay. So now I had mentioned the maximum temperature alias for this column. So if I run this one, I should be able to get the data. And see, guys, this is how you can rename your column using the alias function. Now let's discuss about the very important function, which is filter function. Filter is a narrow transformation, as you already know. So this is very commonly used function within your notebooks. In order to use the filter function, let's first see the data on which we can filter. Maybe we can say if the rainfall index is, let's say, greater than 5. Okay, let's filter on that. So for that, I will just copy paste my Parquet data frame and I will come here and I will say data frame underscore filter, and I will mention my Parquet data frame, and then I will use dot filter and I will mention the column, and I want to do filter on rainfall column. Okay. And what I want is, I want give me the output where the rainfall index is greater than, let's say, 4.0. So I will also say df filter dot display, and let's try to run this one. Perfect. Perfect. So I got the output where the rainfall index is greater than 4. Okay. So now let's say I want to, filter if the rainfall index is greater than 4, or if the sunshine index is greater than, let's say, 10. Okay. So if any one of the true, I want to filter. So let me go down. So I will say filter using or. Okay, I will say shift plus enter. And here I will just say or you can use or using pipe. And then you will mention the second column, which is sunshine. Yes, yeah, sunshine, small. And then I will mention again, sunshine should be greater than, let's say, 5. Okay. And instead of closing it here, I will remove it and close it here. And this should work. What? So sunshine column is string column, which is not actually. That's the, disadvantage of using infer schema sometime. So anyway, I had mentioned as a string. So now I got my output. Make sense? So this is how you can use filter using or. And similarly, if you want to use and, you can just tweak here. Instead of pipe, you can just say ampersand, and it will work the same way. Okay. Cool. Perfect. Perfect. So this is pretty much about the filter transformation. We had covered filter transformation, alias transformation, as well as the select transformation. Okay, so let's now understand the another transformation, which is with column rename. Okay. Rename, shift plus enter. This column renames the column inside the data frame. So now you will ask me, Jaswinder, we was also using the alias and alias was also renaming the column, then why you need with column? So that's what I'm telling you, that with column rename is used to rename the column in your actual data frame, but the alias is you use with the select for just the temporary purposes. Okay, if you have to change the name of the column in the actual data frame, you need to use with column rename function. Okay, so this is the difference between alias and with column rename. Let's try this as well. I will just take this df parquet, and here I will say df renamed is equal to df parquet dot with column rename, and let's say I want to rename column min temperature with minimum underscore temperature. Then I will just say df renamed dot display. And see guys, it worked. So it actually had renamed my column from min temperature to minimum temperature. So this is very useful when you have to rename the data frame. Instead of this df rename, if you mention df parquet only, it will literally rename the column inside this data frame. Okay, so this is how with column rename works. Let's now understand another very important transformation function, which is with column. Before explaining you the with column function, I will go to my read files folder and I will quickly grab another customer CSV data frame, and I will come back to my transformations and I will just run this data frame so that I can use it here. And by the way, you can also do the same thing using magic commands. We will cover that in future. Don't worry. As of now, just paste it. Okay. And then below, I will help you with the with column now. So what exactly is with column? Let me do shift plus enter. With column is a transformation function which we can use to add any new column if you want. If you want to update any kind of existing column, that also you can do with the with column. If you want to change the data type, that also you can do with column. And even if you want to do some kind of aggregation or calculations, that also you can do with column. So this is the master transformation function. If I have to say, let's create one more text and write what exactly it can create. So I will just say first thing, it is used to add a new column. Then it can be used to update an existing column. Then we can use this for change the data type. And then we can also use this to aggregate or perform calculations. So these four things we can literally do with column function. We can add a new column, we can update existing column, we can change the data types, and we can even perform aggregations or calculations. Okay, so let's do one by one. I will start with the aggregations. I have a data frame ready with me. So I will just copy paste this data frame and I will come here and I will say df underscore with, and I will say df dot with column, and first thing what I will do is I will perform the calculation. So in this table, I have first name and last name, and I don't have full name. Let's say I want the full name as well. So what I will do is here I will mention the full name. So I guess this only one code will cover add a new column and aggregate and perform calculation. Okay. So now in order to add the full name, I need to use first name and last name. So in order to concatenate them, I need to use the function called concat. So I will mention the concat function. By the way, there is another function called concat ws. Ws indicates with separator. We will cover that as well. So now I will just the tab, and what is this doing is this is selecting the first name, and there is a literal between the first name, I mean, which is a space. By default it will be added to everything, and then we will be having the last name, and then I will say df with dot display. Let's run this. Perfect, it ran successfully. So at last I should be having the full name. See guys. Okay, so this is how you can add a new column, first one, and perform the aggregations as well on the same time. So now we understood these two. Let's update an existing column. By updating an existing column, I mean renaming the existing column. Okay. So in order to do that, it's very simple. I will just say code and I will just copy paste this code itself here. And let's say I want my first name to be displayed as first underscore name. Okay. So in order to do that, I just need to say here first name, and the output should be first underscore name. So now I just ran with column and I passed my new column name and the old column name. And when I ran this, I can see the column is also renamed by first underscore name. But had you noticed that with column is creating a new column even though I am having the existing column? So this is where when you need to use with column renamed instead of with column, if you literally want to change the column name in place, else you need to now after this you need to drop the column. Okay, let's now see that how we can change the data type. For that I will go and create a new code template, and here I will mention my column name which is index, and then I want to cast the column index. I will mention index and I will say dot cast as string. Okay, and then I will run this. And see guys, now index is string type. Earlier index was integer type. So this is how you can cast the data type as well using the with column transformation function. So this is very powerful function is very widely used function whenever you are working with PySpark. So please do revise and please do hands-on on using this function. Okay. So as you had understand the with column, and I had already covered the cast as well with the with column itself only. But when you need to use the cast is, let's say you are joining the two tables, okay, and the joining key is order ID. Okay, in the first column the order ID is having the data type as integer, but in the second table order ID is of string type. If you try to join this, it will not be giving you any results, right? So this is where the casting is very helpful, and that's why you should revise casting as well. Okay, there is one more thing which is known as limit. Okay, so I guess you are already aware about what is limit. So you can just say limit 10 or limit 100 based on your requirements. So if you just want to see the subset, I am not covering the limit. Okay, I am just leaving the limit to you guys because this is pretty straightforward. Let's understand the sorting in data frames. I will just add a new text. I will say sorting, and I will there shift enter. So sorting is sorting, like you are just sorting either in ascending order or descending order. Let's sort this table based on subscription date. Okay, so for that I will just use df underscore sort is equal to df underscore width dot sort, and I will sort based on this subscription date. So I will mention here subscription base date. Perfect. I will run these and it will sort my data based on subscription date, and by default the sorting is in ascending order. If you want to sort it in descending order, you need to mention sort dot descending as well. So let's see first this one. So hey, see guys, so here they had sorted in ascending order. So first is 13, 23. So it had sorted everything in the ascending order. Now, if you want to sort this in the descending order, all you need to do is just mention this as a column. Then here, just mention descending and then close this, and this should work. Perfect. It ran successfully. So if we go and see now, this got sorted in descending order. This is how you can sort the things in ascending or descending order. But what if there are a lot of columns? Like let's say there are 3 columns you want to sort on. And let's say the columns are subscription date and then country. Okay, let's say. So in that, I will just go for a new code. And here I will write that code. I will say df underscore sort 2. And then I will say df underscore width. And then I will mention the sort function, and then I will create a list which things I want to sort. So as of now, I want to sort on subscription date and country. If I just run this, it will sort both of the thing in the ascending order. But I want country in ascending order and subscription date in descending order. So how we can do that? I can just say comma and I will say ascending is equal to, I will create a list and I will say 0 comma 1. I will just run this df sort to, and here this time I will say display in front. Both are fine. You can even say dot display or even you can start with display. Anything is fine. So now this got sorted in descending order and my country got sorted in ascending order. So this is how you can sort based on multiple records. Let's now understand another important function, which is drop. So I will just say drop, shift plus enter. And drop is something which you can use as it's a self-explanatory that it is used to drop a column. So let's say I don't want phone number 2. So in order to drop that, all I just need to do is I just need my data frame. I will say df drop and I will mention my data frame and then I will say drop. Which column I need to drop? Then I need to mention the column. So I want to drop phone 2. So I will say phone and 2. And then if I run display df drop, I should not be able to see phone 2. Oops, I had mentioned wrong one. Yeah, so let's run this again. Okay. So now after phone 1, I cannot see phone 2 because I had dropped the phone number 2. So this is how drop works. You can drop any number of columns using this drop function. And there is very similar function to drop, which is known as drop duplicates, which is not relevant to dropping the column, which is relevant to dropping the rows. Okay, so let's discuss that as well. So I will just go down and I will just add a text. I will say drop duplicates, shift plus enter. And now I will drop the duplicates and I will say df dupe 1 and I will say just say drop duplicates and then I will say display df underscore dupe 1. So it will eventually drop the duplicates based on the entire row. Okay, so if there are two rows which are entirely same, then it will drop the duplicate row. Okay, but let's say your requirement is very different. Your requirement is to drop the row based on few columns. So you have a subset of columns which should be unique. So in that case, you can mention the subset here as well. You can say, let me just say 1, 2, and here also 1 to 2. And then you can mention the subset here. You can just say subset and you can mention the list of columns on the base of which you want to identify the duplicates. Let's say customer ID and country. Okay, let's do that. Let's try that. It's just a demo. Customer ID and then I will say country. Okay, then I will run this one. So this again gave me the same records because there was no duplicates based on customer ID. So I will show you something. Maybe I will remove this country as well and let's see if there are any duplicates getting removed based on customer ID. No. Wow. Wow. So there are literally no duplicates in this data. But yeah, I got it. Maybe let's do duplicates, remove duplicates based on subscription date. Now there will be subscription date. So let's run this. Now the count should be decreased. See, 96. So this is how you can use drop duplicates. Drop is useful to drop the column, whereas drop duplicates is meant for dropping the record, which is duplicate based on either the entire row or based on either the subset. This is how drop and drop duplicates work. Okay, this is very important for interview point of view as well. Okay, please Do remember this difference. Let's now try to understand union and union by name. So let me give the heading union and union by name, and I will do shift plus enter. And here the union is nothing, it's just combine both the tables, table 1 and table 2, and it will give me the desired output. But if my columns are shuffled between two data frames, then I will use union by name. Let's see this with example. So here I have created two data sets. First is data 1 and second is data 2. And I had created a data frame on top of these two data sets. And let me first display both of the data frames. Here we have ID name and code and ID name and code. And let me insert one more ID. So let me copy paste this ID itself. I will say Control C and Control V. Perfect. So let me rerun this and it ran successfully. So now what I will do is I will first perform union. Okay, so I will say df underscore union is equal to df1 dot union df2. Then I will say display df underscore union. Okay, so let me comment these two lines. I will say control plus backslash and it will go for a comment, and then let me run this. So now I had ran this and you can see it had simply combined both the data sets in my output. So the reason why I copied the last row here, so that I can show you that it don't care if tables are having duplicate row or not. It will still combine those rows as well. So this is how union works. Let me show you one more example. So here the columns and the rows are same. Just I had shuffled the columns. So instead of code in my data frame 2, first is name, and instead of name it is code. So now I will just say df underscore union try, and I will say df1 dot union with df2. Okay. So then I will display my df union try. Okay. Let me run this now and see it had ran, but it had populated the wrong data inside the wrong columns. So this purely shows that union is very blind operation. It will literally combine both of your data frames and give you the desired output. It don't care what is the data type, even the columns are aligned or not. But if instead of union, I had used union by name, then the story will be very different. Let me run this now and see, guys. You got it? This is the difference between union and union by name. Let's now discuss about the most widely used function in the PySpark, which is date functions. So these functions are something which we literally use every day in every layer. I don't see any room where we don't use these kind of functions. Okay, so let me give a heading first. So I will say date functions, shift plus enter. And now I have data sample written already. So I had included 4 columns, and 3 of them are date and date time column, so that we can understand by using this data frame how we actually work with all kind of date functions available in PySpark. Okay, so I will just run this cell and then I will open a new cell till the time it's running. Okay. And now, first thing, let's discuss about very common date functions. Those are current date and time functions. So what I will do is I will directly use select df dot select, and here I will pass current date and I will give this as current date. And then I will say dot show. And then I had ran this one, and this is the first basic one, which is the current date printing. Okay. And similarly, we have another one, which is current timestamp. So I will just say same here, current underscore timestamp, and I will alias this one, and then I will close this bracket, and then I will again run this one. So these are the very basic functions which we can usually use with the audit columns. So if you see here, my current date is coming exactly full, but my current timestamp is coming truncated, right? So I'm not able to see my complete current timestamp. So in order to fix this, all you need to do is you need to say truncate is equal to false, and you need to rerun this cell. And that's it, guys. This is also fixed. Next category which I want to cover is date conversion and formatting functions. So let's give this a name, date conversion and formatting. And here also I will just use the above data frame only. I will say df dot select, and here I will try to convert my one column using two date function, and I will pass my column name is date str. Then I will just rename this column, let's say as standard date. So this is the default date conversion because I hadn't mentioned any date format. So it will convert whatever the default date conversion of Databricks is. So let me run this and see. It had created a column with the default date conversion, which is YYYYMMDD. Now let's try to convert into my specific format. For that, I will literally copy paste this one, and here I will change my column name to, let's say, other column. What is the other column I am having? Customer date, let's say. I will copy paste it here. And then I will mention the format. Here I want to convert this into DDMMYY. So I will mention it here, and then I will name this as, let's say, custom date, and yeah, that should be fine. Let me run this. Okay, it worked fine. So you can see the custom date, which was earlier in DDMMYY format. Now it converted into the default Databricks format. The third one is to timestamp. And here I will mention my timestamp column, and I will name this as, let's say, standard timestamp only. And then now let's run this. And now I got my standard timestamp as well. Okay, now I want to know the day as well. Okay, so in order to know the day, I will again use date format, and here inside this, first thing I will mention my date column, and then I will pass my format. So here I want the day, so I will be saying 4 is, and then I will say comma, and then I want month in 4 words, then I want dd, and let's say I want this only. Okay, so I will name this as, let's say, verbose format, let's say verbose format, and then now let's try to run this and see, guys. It is giving me date and as well as my day. These are my date conversion and formatting functions. Okay, we have two date, we have date format, we have two timestamp, and based on your requirement you can tweak inside the date format. Next category is date arithmetic and extraction. Date arithmetic and extraction. Perfect. Shift plus enter. And here also I will use again df dot select, and now the first arithmetic extraction function I want to use is date add, and I will mention my column name. I know it's recommending me to do things, but I will write my own code so that I can literally help you to understand in better way. Because I am adding 10 days in my current date, I am renaming this column as, let's say, plus 10 days. And then at last I will mention show truncate is equal to false. Let's run this. Perfect. So I got my plus 10 days. Similarly, I can do the same for minus 10 days. I will just copy paste this one till here, Control C, and I will add a comma. And here I will paste this, and I will, instead of date add, I will say date sub, which means subtract the number of days. And let's say I want to subtract 5 days. So it will be minus 5 days. Let me change this, minus 5 days. So let's run this as well. Perfect. See guys. Okay. Now I want the difference between the dates. Okay, how many days are coming between two dates? So in order to do that, we have a function called date difference, and then we mention two columns from which we want to extract the date difference. First column should be the highest value, and second column should be the minimum value. Okay, let me write something. I will say current date, and then I will say my other column, which is date str. I will mention it here. I will name this column as dot alias days difference. Okay, and let's run this and see guys. So it is giving me the date difference between my current date and my date str, which is mentioned in my data frame. Okay, but what if I reverse this? Let's do that as well. I will just copy paste my complete string down here, and I will remove this part, and then I will add this. Then I will run this again. Oops, it will not run. Okay, it ran even with my comma. Okay, that's fine. But yeah, now see guys. So if I mention the minimum date first and maximum date after, then it will give me the date difference in minus. Okay, so that's the reason I mentioned that in date difference, first thing you need to mention is the latest date, and second thing is you need to mention the other date. Okay, now date difference is also covered, and let's discuss about add months. Yeah, this is also very important one. How many months you want to add? So let's say I again use the same column date str. I want to add, let's say 3 months. Then I will say dot alias plus 3 months, and then let's run this as well. And perfect. So it had added 3 months in my date str column. I'm thinking why I'm not printing the date str as well. I should print that as well, right? So I will just say column date str. Yeah. So you can see that this is my existing date, and after adding the 3 months, this is coming. And after adding the 10 days, this is coming. So it actually makes more sense if I had added the date str in the first column, but that's fine. I guess you got my point. Okay. Last function in this category of date arithmetic and extraction is months between. Months between, again, it will calculate the months between the two dates. So here I will just mention whatever it's mentioned here, current date and my date str, and I will name this as months between, and let's run this as well. And see guys, so it had given me the months between the current date and my date str. This is how you can work with date arithmetic and extraction functions. Next category is date component extraction. Let's give that heading as well, date component extractions. So this means to extract the day or month or year from the specific date. Okay, let's again say df.select and try to extract year from my, let's say, date str only, and I will name this as year, and then I will say dot show truncate is equal to false. By default truncate is true, but if you say truncate is equal to false, it will actually show you the complete output. So the year is 2026. Okay. So now I will not do the same mistake which I had done in the previous. First column I will pull is date str only. It will avoid any kind of confusions. Yes, now this is fine. You can understand from this that this is my original date, and inside my original date year is 2026. So it has successfully extracted the year from this date. Next function which I want to show you is quarter function. So if you want to calculate the quarter, which quarter you are in, so you can say quarter, and then you can use that again the column date str, and let's name this as quarter, and let's run this. So I got the quarter because it, in my year we have 4 quarters, so it, this date sits in the first quarter, so it is saying quarter is 1. Let's also find the month. I will say month of this date str, and then I will name this as month, and let's run this, and my month is also first month, it's January. And then next one is day of month. This is also self-explanatory, day of month. I will just mention my column, and then I will just rename this. Perfect, it should be fine. See, so it is giving me the 15th January as the day of the month, And let's say you also want to find the day of the week. Day of week, you can mention again here the date str, and then you can mention the alias day of week. And let's run this as well. So I got my day of week for 15th of January. The day of week is 5th day of the week. We can also do the same day of year and week of the year. Let me quickly do both. Day of year, and then I will mention my column, and then I will say alias. And similarly, I will do the same thing for week of year, and I will mention my column name, which is date str, and then I will say alias week of year. And these all are data component extract. Now I will run all these and you can clearly see that how we can extract the date component from a column. Based on our requirement, we can extract year, quarter, month, day of week. It is very helpful when we are actually calculating the holiday logics. And the last category is boundary, truncate, and advanced kind of, let's say, dates. So you can say boundary, truncations, and advanced logics, shift plus enter. And here also, again, I will just repeat myself, df.select. And first thing I will calculate here last day from this date str. And I will name this as end of month day. And then I will just say dot show truncate is equal to false. And I can see that for this date str, my last day of month is 31st of January, which is true. Next is the next day function. I guess you got what is next day. So I will just mention here next day, and I won't explain this because it's self-explanatory. Yeah, and I will say alias next day. And then similarly, I can even truncate the date to only extract the year. I can even say truncate this date str and extract the year from my truncated date, or either month call also we can extract, but let's extract the year. And I will just name this column as truncated year. Okay. And then the last one, you can even do the date truncate as well. So you can say date truncate, and you can mention on what basis you want to truncate. Let's say this time I want to truncate based on hours. So you can mention the column. Let's say I will also change the column this time. I will say timestamp str, because timestamp str column is having the timestamp as well. So it will be actually making sense using this column. And then I will say truncated hour. Oops. So I will just remove these things. Run this complete cell. Oh, I forget to put the next day which I want to extract. Next day, expect two variables. First is the column name and second is the next day which you want to. Let's say I'm on Thursday, I want to calculate the next Sunday. So you need to mention that here as well. So the next day, Sunday, is 18th. Truncated year, 1st January 2026. Truncated hour is this one. So this is how it calculates truncations and boundary logics. Okay. So this is pretty much about date functions, and these functions are very, very widely used, and you will literally be using them on a regular basis. So please do practice them as well. Let's now discuss about the string functions, and let's give this a heading: string functions. This is a very long topic because there are a lot of string functions to cover. I had already written the script to create the data frame, as well as I had already written the type of string functions. So we will go one by one. So first thing first, I will just run this data frame. And it had ran successfully. So now the first type of string functions we have is case, conversion, and length functions. So I had created a data frame and I had mentioned df.select. And then first I am just literally taking the reference of my original column, because last time I did that mistake. So it was not looking good. So I had taken the reference of my original column. And then what I had done is I had used the dot lower function, okay, on that column, and I had named that column as lower column. Similarly, I had mentioned the upper function, and I guess you understand what dot lower and dot upper function will do, right? And then third function I had mentioned is init cap. What it does is it capitalizes the first character of every word, and the fourth is length. Length is length. It will just calculate the length of the string. So let's display this function. I will say display df underscore case. Let's run this. So this is known as case conversions and length. Okay. So once this runs, you will be able to see the beautiful result with the 5 columns. First is raw text. This is my raw text. And if I do the lower, everything will go in lowercase. If I do upper, everything will go in uppercase. If I do init cap, the first character of the word will be going into the capital case and rest all will be in the lowercase, and then the length. I guess that's pretty much self-explanatory how we can work with case conversions and length. These functions are very helpful, especially lower and upper, because whenever you are doing join, it's the best practice to convert the joining keys either to lower or upper so that it matches the conditions. Okay. And the length is also very helpful. So these all are very helpful. I'm not saying only length is helpful or upper is helpful, but these functions are widely used in the industry. Okay, these type of string functions are known as case conversions. Okay, next type of string functions are trimming and white space removal. Okay, and here I am creating a new column clean. Okay, and what I am doing, I am trimming my existing column raw text. So we will use this helper column clean to run all the subsequent things. Okay, so what I had done is I had used this helper data frame clean, and I had first obviously select the as it is original column, and then I had done L trim. L trim means trim all the spaces which are on the left, and R trim indicates trim all the spaces which are on right. Okay, and then at last I am literally printing the clean column. So if I just try to display this one, display df underscore trim, I should not be able to see any kind of spaces, either leading or lagging. So see guys, so this is how trim function works. Here you cannot see because there are actually no spaces in the raw text. If there was spaces, it will be trimming the spaces. So this is how we can work with trimming and white space removal functions. Third type of functions are concatenation and splitting function. And concatenation functions you had already seen in my past videos. And I guess you already know that concat merges the string without the separator, and concat underscore ws indicates with the separator, it merges the string with the separator. This first function requires 2 parameter, and this second function requires the 2 parameters. And we had already explored concat and concat underscore ws, and you know how this works. So here what I am doing is I am using my clean column which I had created up, and then I am patching a literal developer with this. Okay, and then I am naming this as concat, and similarly I am using the separator pipe, and then I am trying to attach the clean and the code column, and I am giving this column alias as concat ws. And the third is split. What split do is it will split your sentence based on the separator. In this case the separator is comma, and it will create the array for that. Let me show you quickly. I will say display df concat split. Let's run this. See guys, this is what I was talking. Concat and concat ws you are already aware. And the split, what it does is based on the separator, it splits the sentence and it creates the array. This is all about concatenation and splitting functions. The next type of string functions are substring and extraction functions. And substring extract the substring based on the past parameter from starting to the ending. And the substring index extracts the substring relative to a specific delimiter. Okay, I will show you how this works, and let's do that. Let's run this. If I pass +2, it will show me the index before. If I pass -1, it will show me the index after. So let me run this df underscore substring display as well. And here you can clearly see the substring index. This is how you can work with substring and extraction. We cannot remember everything, so you can obviously go to PySpark documentation and copy paste the template from there into your Databricks, or you can even use any kind of GPT models. But you should at least know that where you need to use which function. If you at least know that where you need to use substring, where you need to use substring index, where you need to use concat ws, you are sorted. You can do your work. All you need to do is go to documentation or go to GPT and grab the code and just get your work done. Okay. So these are all about substring extractions. Next one is search and matching. This again is very, 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 very important, guys. And this literally is very important. We use these things on very, very regular basis. Doesn't matter you are developing the things or you are testing it. These searching and matching things are the backbone of the string functions. Okay. So now, first thing first, I had just printed my original column, and then I am using the contains function. So what this function will do, it will check my existing string, and if the string contains the data word, it will say true. And if the string is not containing the data word, it will say false. Okay. So it's kind of the Boolean representation. Next is starts with, it checks whether the existing sentence starts with my specific words or not. So if the sentence in this case starts with data, it will say okay. But if it is not, it will say false. Similarly, ends with also do the same thing. And then we have INSTR. INSTR gives me the index of the first occurrence of the word. So let's say I have a big sentence, and wherever the first time in the complete sentence science is coming, it will give me the index of the first occurrence. Okay. So this is known as INSTR. And then we have locate. It will also do the same thing, but we can mention the optional start, like in this case, learning, and it will locate the word from that index. Okay, now let's try to run this as well. I will say display df underscore search, and let's run this. Oh, underscore. I had put hyphen. Yes. So see, guys. So start with true, false. It returned based on the required parameters, right? This is how you can actually use the string and magic functions. Last one in the string function category is padding and replacement. And regex replace and replace are most widely used. rpad and lpad I personally never used much in my development. I used replace and regex replace, and these are most important one. So regex replace will replace the string based on the regular impression which I pass. Okay. And the replace will simply replace the occurrence of that specific string. Okay. So let's run this as well. I will say dot display, and I will hit run. So see, guys. So whenever there is a keyword data, it is replacing that with big data. So it had already done that. Instead of data, it had replaced the data with big data. This is how replace works. And then regex replace had checked the occurrence of A to Z in lowercase. So wherever there was a lowercase A to Z, it had replaced that with star. So that's the intentional I had used A to Z. In normal production, you won't be using A to Z. We will be using regex replace to remove the special characters usually. But you should know that here I am using A to Z, and I am replacing all the lower A to Z with star, and you can clearly see that this worked, right? And then I had done the left padding with the width of 20. So you can see the result of left pad, and the complete string length will be 20. Similarly, I had done the right padding as well with the width of 20, and complete string length will be 20. This is how we work with padding and replacement, and that covers the complete string functions. Do practice them 1 or 2 times, you will be good. And whenever you get stuck, just go to the PySpark documentation and grab the required function and get your work done. So these are very widely used functions, and that's why I feel it is very important for me to explain you type of string functions we have in PySpark. So PySpark library is very vast, and you can clearly see what I am talking here. Let's now discuss about another very important function, which is drop NA function. This is very helpful function when you have to drop null values. So let's give the heading, let's say drop NA, and I will also cover fill NA. I will do shift plus enter. And this is the data set which I had already prepared in order to save your time. Here I have a complete data for one row with only one null, third row with two nulls, and fourth row complete null. So I will just run this and it started running. Perfect. And I am able to see data inside my data frame. So first thing first, I will show you how drop NA work. So for that, I will say df underscore drop and I will just say df dot drop NA. I will not say anything else. I will just say this and I will just display this. That's it. Let's see what it gives. So before I run this one, what actually drop NA will do is it will drop the entire record wherever if the drop NA will see even a single null. Drops any row with having at least one null. So this is how journal drop NA works. So it will drop any row which is having at least one null. So in this case, it will drop this one, it will drop this one also, and it will drop this one also. And my final output will be having only one record, right? So let's run this now. And see guys, as I just discussed, so drop NA, if you just mention drop NA, it will drop any record with at least one null. So usually we never use drop NA, we use drop NA with some subsets of column. Internally, drop NA uses a thing which is called how is equal to any. This is the default behavior. This default behavior only indicates that if in a record I am finding any number of nulls, even a single or even a 100 or even a 10 lakh, I am going to drop that record. So this is the default behavior. I will run this as well and it will show me exactly the same output as I was able to see earlier. Now, if I want to drop a record which is having all the complete entry as null, okay, complete entry is null. So in that case, I will just copy paste this one again and I will just change a behavior where I will say instead of any all. So what now will happen inside this data set, it will only drop that records which whole entry is null. So in this data set, it will only drop the last record because last record is total null, right? So I will now run this and I will show you the output for this as well and see guys. Make sense? The third one is we can mention the subset. Okay, so I will again just copy paste this one. I will come down and here we can also mention the subset as a list form. Okay, let's say I want to drop the column if age and city both are null. Okay, so in that case, I will mention in this subset that hey, if age and city both are nulls, then also drop the record. So in this case, now this record will also go out. Output will only be having two records, right? Let's run this. See guys, perfect, perfect. Now, as I had mentioned, how is equal to all, and as you know, the default behavior is how is equal to any. And if I mention here any, it will delete the record if either age or city or both are null. So in that case, I will also lose Bob as well. So you need to ensure that whenever you are using drop NA function, it's a good practice to always add how as well. Specifically when we have to use and, it's recommended to use how. We have one more. Instead of having how, you can even mention thresh as well. Thresh is equal to, let's say, 2. So what this indicates is in a complete record, I am finding two nulls, then drop that record. Okay. So in any scenario, when in my table I am having two or more nulls, those records will be getting deleted. So if I pass 2, it will be 2. If I pass 20, it will be 20. So let's run this now. So the output in this case, if I go to my source table, should be Alice and Bob, right? Let's see that if this is true or not and see guys, this is true. Make sense? Perfect, perfect. Let's try with one as well. So I will just rerun it. In this time, I will get Alice, Bob, and Tom. Okay, and let's try 3 as well. In this case, I will only get Alice. See guys, This is how you can utilize thresh function as well. If you don't know the subsets, if you know the subset, that's the best thing to do here. And you now know how you can use drop function to get your work done. Okay. And his similar brother is fill na. So let's try to code that as well. Here, instead of my drop na, I will say fill na. And before all those things, I will just rerun my existing data set so that I get back original data. Now I will say I want to fill the null records with, let's say, my name, Jaswinder. Okay, let's run this. So what do you think will be the output? Here, fill NA will go to name column. Okay, let's go to the above data set. This is not good one. Yeah. Here, fill NA will go to name column, and wherever it will see null, it will say Jaswinder. Okay. Here, when it goes to age column, it will never update anything in the age column. Why? Because Jaswinder is a string, not an integer. So age is the integer. So it will skip the age column, then it will go to city column. City column is again the string column. Again, it will update null to Jaswinder and null to Jaswinder. So output is very clear to us. Now let's see what exactly the output we got. And see guys, this is exactly what we was looking for. Make sense? Perfect, perfect. So Jaswinder, this is a very basic table. We understood that we can use fill NA, and if I want to use the fill NA for integer, I need to mention the integer. We are good with that. But in the real world, my table will not be having 3 or 4 columns. It might be having 100 columns or 120 columns. Then how we can manage with this fill NA? How Jaswinder, how we can do that? Don't worry, PySpark had given that option as well. For that, we will just define the unique fillers using JSON format. So I will say fill rules and I will say equal, then I will define my JSON. So let's say wherever there is a name, I want the name to be filled with Jaswinder. Wherever there is a age, I want to fill the age with, let's say, default age, let's say 100. Okay. And wherever there is a city, I want to fill the default city as Pune. And these rules I will pass inside the fill NA. Let me show you the magic. I will just grab this one again here and I will just do some enters. And here I will remove my name and I will say fill the rules. Perfect. And let me run this now. Now you will see magic. See guys. Jaswinder is also there, age is also there, and Pune is also there. This is how you can utilize fill NA function when you are literally working in your project. Because I know in project you will not be having a small table or a few column table. You might be working on a very huge table. So this is the way we can fill the default values in the respective columns. Let's now understand the next important function, which is split and index. I will give a heading split and indexing, and I will say shift plus enter. I have a data set. So first I will go is I will just click on this code and I will paste my data set and I will run this data set. Perfect. I had ran the data set. Now what I want is I want to split the full name column into first name and last name. Okay. So in order to do that, I will again go to next code and I will say df let's say, and I will say df split dot with column, which column I want to be created. I want to create first name. So I will say first name. Let me capitalize. I will say that please split my full name. I will add my column, which is full underscore name on the basis of hyphen. And if I just run this one, I will be able to see the array, which we had just seen earlier as well. So I will again show you. Let's see that. It will all hardly take a minute. df.display. I am running this and you will be able to see the split is not defined. Ah, okay. I hadn't imported the library of the split. So let me go to my very first tab and let me run this tab. Perfect. it is running. It ran successfully. Now I will come back here. I will just try to rerun this now. And see guys, as I just told you, if I just mention the split, it will create a array. But do I want array for first name? No, I literally want the first name. So how we can do that? I will simply come here and I will simply say that only give me the output based on my 0th index. So in this case, the 0th index will be zone. Let me run this now. And see guys, now I got the perfect first name. Similarly, I will copy paste this one complete. I will add a backslash. I will go to next tab and I will paste this again. And instead of first name, I will say last name. And I will just replace 0 with 1. And that's how I fetch the first name and last name from this data frame. And I forget dot. And so that I need to just rerun it. So perfect. See guys, this is how you can work with split and indexing function. If you have to split a column into multiple columns, you can use this function and it is very helpful when you have to extract some subset of data from a column. Okay, perfect. Let's now understand another important function, which is explode. What explode do is, let me grab one more text. So let's say you have an array of integer 1, 2, 3 as a data in a column. Let's say column name is order ID. So a single person can order multiple things, right? So in the single person order ID, I am having, let's say, this thing 1, 2, 3. If I use the explode function, what it will do is it will create 3 records for that. So let's say the customer ID was 1. So first record will be 1 to 1, then 1 to 2, and then 1 to 3. So this is how explode function works. Let me delete this one and let me grab the data set to show you what I meant. This is my data set. So I will just run this data set and this is my existing data set. As you can see, the person Alice knows Python and SQL. Bob knows Java, Scala and C++, and Charlie knows nothing. So if I use the explode function, what I will get is I will get 2 entries of Alice. As of now, it's only 1 entry. But if I use the explode function, it will explode. It will add entries based on the array. So the first entry will be Alice Python and second entry will be Alice SQL. Then again, the first entry of Bob will be Bob Java, then Bob Scala, and then Bob C++. But Charlie is not having any array. So it will keep the Charlie because we will be exploding on the language and language is none. So Charlie entry will be getting skipped. Let's see this in action. Here only I will, let's say, add exploded df and I will say df dot select and then I will select my column name. Now I will here use explode function. I will say explode and I want to explode based on obviously languages. So I will pass those and I will run this now. And see guys, now the output is instead of 1 record of Alice, I am having 2 records. Instead of 1 record for Bob, I am having 3 records. But Charlie was having array as empty, so Charlie got discarded from my final output. This is how explode function works. Similar kind of function we have is array contains. So let's cover that here as well. So I will say array contains and what it does is, I guess it's self-explanatory. If the array is containing the specific word which I am passing, it will say true, else it will say false. So let's add here only. I will say comma array underscore contains and I will pass the languages here. So I will say df.languages and I want to check if in the languages array Python is present or not. Okay, so now if I run this, I should be able to see the 3 columns and the third column will be having values of true or false. See guys, this is what I meant. Make sense? Let's now understand the group by and filter. Let's give a heading quickly. By and filter. I will say shift plus enter and I had created a data set. But first, I believe you already know what is group by. Group by groups the rows with identical values based on the specific columns. And the filter works same as the where clause in SQL. And group by also work as a same actually, but I'm just giving you the definition that what exactly is group by, who just want to just get the definition. So now let's implement this quickly. I guess this will be very quick one. And if you had seen my previous video, you know that group by is a wide transformation. So it impacts the query performance, right? And let's see how we can implement group by and filter using PySpark. So I will just run this below cell. And I have a name, department, state, salary, and bonus. So let's say I want to find the department where total salary is more than 8,000. Okay. So this is something which we can only achieve using group by, right? So let's implement that. I will say df dot group by. I want to group by department. I will add department. Then I have to use aggregate function. Inside aggregate, I want sum of salary, and I will name this as Elias total salary. This is how I had implemented the group by. Now I will also implement the filter. I will say dot filter, and I want to filter on this very column which I just had created, which is total salary should be greater than 8,000. And I will just add dot show as well at last. And see guys, I got the result of the departments where the department wise total salary is more than 8,000. This is how you can use group by and filter. And this is very, very straightforward, as you already know SQL. So there should not be any kind of trouble using group by and filters. Next up function is approx count distinct. Let me add the text approx count distinct, shift plus enter. This PySpark function is used to estimate the number of unique values in the column. This uses hyperlog algorithm, which is nothing, it's just a data structure which estimates the cardinality of any table by using exceptionally small fixed amount of memory. So that is known as hyperlog log algorithm. Let's write down here as well. This function is used to estimate number of unique values in a column. This uses hyper log algorithm, which is nothing, just a algorithm used to estimate cardinality using exceptionally small or fixed amount of memory. Okay, so this is what we call approx count distinct. Okay, let's take a data set and do this hands-on as well. I had copy pasted my data sets with two columns, item and category, and I am going to create a data frame on top of my data. And perfect, data frame is successfully created. Now let's calculate the approx count distinct. I will just grab another code and I will say df dot select approx count distinct, and I will add my column, which is item column here. And then I will say dot alias. I will name this as approx count, and then I will say dot show. And let's run this. See guys, so it had given me approx count. It hadn't given me the exact count. It had given me just the high level approx count. So this is the function. Here we have one more parameter which is known as RSD. RSD means relative standard deviation. By default, it is 0.05. This means allowed percentage of error is 5%. Okay, and you can tweak it to 1 or 2, whatever. So let's tweak it to 0.01. So this way you can add this value based on the accuracy level which you want. Okay, so this is how we can work with approx count distinct function. Let's now discuss about another important function, which is collect list. Let me give a heading, collect underscore list, and let me do shift plus enter. Collect list is exactly reverse of explode function. In explode, where we take the array and convert that into multiple records, in collect list, we take the multiple records based on the group by and we combine them into an array. Okay, let's see that in action. I will quickly create one data set. I will say control plus enter. Perfect. It had ran successfully. Now I will create another data frame. I will say, let's say result df, and I will say df dot group by, and I will group by based on employee. I will just copy paste. And then I need to provide aggregation as well, right? Aggregation of collect underscore list. And on top of which column I need to aggregate? I need to aggregate on top of project column, right? So I will just mention the project column here, and then I will give this column alias as, let's say, collect list column, and then I will just say result df dot display. Let's now run this and see, guys. Alice was having, let me also display this one as well, df dot display. I will show you both in parallel. See, Alice was having 3 entry, Project Alpha, Project Gamma, and Project Alpha, while Bob is having 2 entries, Project Beta and Project Delta. So that's why, because I grouped by own employees, it gave me 2 records in the output, which is Alice and Bob, and the respective array list as well. Okay, this is how you can use collect list, which is exactly the reverse of the explode function. Let's now discuss about pivoting and unpivoting. So let me give heading pivoting and unpivoting. So pivoting means converting the records into columns, and unpivoting means converting the columns into records. So both are reverse of each other's. Okay, let's try to implement them as well. This is my data frame. Let me run this sample data frame for you guys. So now, as I had ran the sample data frame, I will first apply the pivoting. Let's say I want to pivot the country column into the new heading. So what I want is, I want product, and then second column I want is USA, and the third column I want is Canada. In order to implement that, I will create a new pivot data frame, and I will say df dot group by, and I will be needing product column, so I will group by product, and then I need to mention the pivot function. And on which column I want to pivot? I want to pivot on country column. Okay. Okay, makes sense. So Jaswinder, you are doing group by. You also need to do aggregation. So this means we need to aggregate based on amount. Yeah, sure. Sum of amount. And let's try to show pivot. And see, guys. So I had converted records into columns. Unpivot is the reverse of this. Let's try to implement unpivot on top of this pivot data frame. I will say unpivot data frame is equal to pivot data frame, and this time please take notes. This one is very, very important to understand on pivot, because this is different than pivoting or applying any other transformations. So you have to understand this very closely. Okay, what I am going to do. So I had taken my pivot data frame, and first thing, obviously, I will just do select, and I will select the product column, because product column is available as it is in my original one, right? So once I mention the product column, I will say EXPR. What is this EXPR? EXPR indicates expression which allows you to write the SQL-like logic inside the PySpark. Okay? So this is nothing more than an expression which allows you to write the SQL code. Okay? So now inside the EXPR, start double quotes, and I will mention stack. Now what is this stack, Jaswinder? We never hear about the term stack. What is this? Basically, Spark does not support natively unpivoting. So in order to help you in unpivoting, they had introduced expression, and inside the expression they had introduced a keyword called stack, which will help the data frame to understand that, hey, I need to unpivot this data. So now in stack, I will open and close the bracket, and here inside this, I need to mention how many columns I want to create. In my case, I want to create 2 columns, because in my existing data I was having 2 columns, country and amount. So I will mention 2. Then it will ask me that on which records I want to create. In my case here, the records are USA and Canada. In pivoting, I created 2 columns, name USA and Canada. So I need to mention these columns here inside my expression. So first thing, I will mention the literal Canada, which indicates the value. And second thing, I will just mention the Canada, which indicates the column. Similarly, I will do for the USA. And once this is done, I just need to rename the column. I will say as, and what was the existing column name? Country and amount. So I will just pass here country amount. And then I will say unpivot df.show. And this should work. Perfect, guys. So see, So it had successfully unpivoted the data as it is was original. This is how you can utilize pivoting and unpivoting function. Unpivoting is very different. So obviously you need to practice unpivoting couple of times. The easy way to do is just remember that whenever you are doing unpivoting, you just need to mention the expression function because there is no unpivot function. In pivot, we have dot pivot function. So automatically everything is getting handled. But for unpivoting, you need to mention the expression. On top of that, it will unpivot the data. Okay. Let's now understand when and otherwise. So if you had worked with the SQL, you already know when and otherwise is very similar to case when statements. In the Python language, it is very similar to if else. Implementing this is even more easier. I will show you. So first thing, I will just create a data set. Okay, I have a data set where I have name of the people, their gender and their salaries. And I will just run this data frame. I had ran this data frame and now I will implement my when otherwise. Let's create the code for a scenario where gender is male and salary is less than some specific amount. I will just say df bonus, df tot with column. I will create a new column. I will say bonus eligible, and then I will start when and otherwise now. So okay, what I will do is I will say when, and my column is gender and that is equal to female, and column salary is greater than 50,000. Then I will say eligible for additional bonus. And then I will say dot when column is gender is equal to male and my column salary is greater than 45,000. Then I will say eligible for additional bonus plus candy. Okay, let's do that. Okay, if that's not the case, then it will go to otherwise. So I will say dot otherwise. Thanks for your contribution. And let's try to run this one. I know you are thinking about context. Don't think about context. Just focus on the function. Oh, so yeah, I had just beautified it. It looks good. So let's try to run this. It looks promising. Yeah, great. Great. So we are done with when otherwise as well. This is how you can implement when and otherwise PySpark functions. Okay, next up is joins. So here we will be covering all the kind of joins: inner join, outer join, left join, right join, anti join. Except broadcast join, we will be covering every join in this transformation lesson. Broadcast join we will be covering in future lesson. Okay, so now let's start with the join. So I have a data set of employee and department, and I will just run both of the data sets, and I can see employee data frame as well as my department's data frame ready there sitting. So it's the time to start with joins. Let's start with inner join. And I guess you already know pretty much about joins. I will just give a little bit of inputs. Okay, I will not be going in depth what is inner join, what is left join, because I know that you already know that. So let's create a data frame. Let's say inner data frame. And then I will use employees table. Yeah, employees table. I will copy paste here, and I will say employees dot join, and I will mention another table which is departments table, and then I will add comma and I will apply the join. I will say from employee table, from employees table, take the department ID. Do I have underscore? Yeah, we have underscore. Okay. So from employee table, take the department ID and join this with my departments tables department ID. This is the second parameter which we pass. First parameter is my joining table. Second parameter is my joining condition. And the third parameter is the kind of join. In this case, the join type is inner. So I will mention inner. And let's say inner dot show as well. And let's try to run this. So this is the output of the inner join. Okay. So that's all. Inner join gives common output from both the tables. And next one is left join. And left join gives the output all the records from my main table and matching records from my child table. Okay, so let me copy paste this one only and I will just paste it here. And instead of inner, I will say left. And here also I will just say left. And then I will join employees and everything looks good. I just need to change here left and I will just run this. Similarly, for right, it will take all the records from the department table and the matching records from the left table. Let's implement full outer join. I am not going to implement right join. I'm leaving it to you. So I will say full outer join, shift plus enter, and then I will copy paste my inner df, and here I will say inner outer, and here also I will say outer, and then here I will just say outer. And that's it, guys. I will just run this. So outer join includes all the records from department as well as employee. If there are unmatched records, it will populate nulls. Okay, this is how full outer join works. Let's now discuss about the most confusing and interviewer favorite type of join, which is left semi and left anti. I will add one more text to explain about left semi. So what is left semi? Left semi will give you records from left data frame which are matching with right data frame. Okay, in my case, right data frame is department. But Jaswinder, isn't it same like a left join? Yeah, if I will say till this point, it is same till left join. But now I am going to add more context to this. I will say, but it completely ignores the right table columns. Now make sense? This is why left semi join is different from left join. Okay, now let's talk about left anti. It is actually reverse of the above. I will just copy paste the above one here, and I will say it gives you record from the left join which are not matching with the right table. Okay, but it completely ignores the right table columns. Now makes sense? This is very, very important, and it is literally asked in the interviews. I even faced this question multiple times. What is the difference between left semi and left anti? This is very important to understand. Okay, so that's why I had written down definition here. It's the time to implement both of them. So I will just copy paste the above one data frame here again, and I will just change my data frame name to, let's say, semi data frame, and here also I will pass semi data frame, and here also I will pass left underscore semi. Okay, and that's it, guys. Let me run this now. And see, guys, it had only given me records from my left table. My left table is having employee ID, name, and department ID. Let me show you my left table. See, my left table is only having employee ID, name, and department ID. Although other tables, if you see inner, it had shown me department ID and department name. And let me go to left. See, guys, let me grab this notebook to below. For that, I will say move down, and I will move more down. I will align this with my left semi so that it will be easy for you to understand. I will again go down where move down, and then here I will again take one more step to move down, and then again down. Yeah. Now this is fine. Now you can clearly see. This is my left join, and the output was all the columns from the left table and all the columns from the right table. But this is my left semi, and the output is only from my left table. Now I guess it makes sense, right? So in this case, if you see, as the output was both from left and right, when there was nothing in the right table, it had done null, but this one excluded those entries. If you see David and Eva was null, here we even don't have the David and Eva. So this is exactly the definition of left semi. It gives you record from the left data frame which are matching with the right data frame. This is fine, but it completely ignores the right table columns. Okay, this actually makes the difference between left and left semi. Okay, now let's implement left anti as well. We just copy paste this one below only, and yeah, and then I will say instead of semi anti, here also I will say anti, and then here also I will say left anti. Perfect. Let me show you now. So as per the definition, it will give you the records from the left data frame. This means in the output we will be having 3 columns. Okay, but it completely ignores the right column, and it will give me not matching. So here I got matching records, but now in left entity, I should be getting David and Eva as the output. See guys, David and Eva is the output for the below. This is how you can work with left anti, left semi, and left join. It is very important to understand at least this one. Okay. With that said, we had again covered the joins as well. You have access to all of these notebooks inside my GitHub. You can literally download and tweak and try understanding all of these things. Okay. Let's now discuss about window functions. Before moving to the Databricks, I want to discuss about the 5 type of window functions, which are row number, dense rank, lag, and lead. So let's discuss about these functions one by starting with the row number function. So what row number do is, if I do partition by, let's say, department, let me write it down here. If I do partition by department, the row number will return here 1, then 2, then 3. Okay, so basically row number always return the value in the increasing order. Similarly for sales, here also it will say 1, 2, 3, 4, 5. Even though the values of these are same, still it will just print the incremental number. So this is how row number works. So whenever you have to index the data based on partition, you can use row number function. Now, what about dense rank? Dense rank means literally dense rank. Okay, I will show you what I mean. Let's say I partition by department, and let's say I am ordering by salary. And in that case, obviously by default, if I order, it will be ascending order. So the first dense rank for 1200 is 1. But if you notice, in IT department, there are 2 people whose salary is same. So in that case, both of them will get 2. Similarly, first it will get 1. Now 3 are having the same salary. So all these 3 will be ranked as 2. And now the last one is having different salary. It will be ranked as 3. This is how dense rank work. Okay, now let's see how rank works. Do partition by department, order by date. The first here, it will be obviously 1, but the second here, it will be 2, right? And here also it will be 2 because of the same value. Okay, now let's talk about sales. Here also first one will be 1. Now these 3 will all be 2, 2, 2, 2, but this one will not be 3. This one will be 5. Because if you see, its row number is very aligned with the rank. So this is how rank, dense rank, and row number works. So rank skips the index based on the similar values. Okay, in this case, it had literally skipped 3 and 4 because 3 and 4 was occupied by 2. And dense rank means it will not skip the 3 and 4. So this is how we work with the rank, dense rank, and row number. Now let's discuss about lag. So if you see here, lag means before the current value, right? So here, first value is 1200. So is there any value before 1200? No, right? So here the first will be null. For second, it will be 1200. For third, it will be 1290. But when I move to fourth, I am literally changing the partition. So it will again start. Before 1300, do I have anything? No. So it will say null. Then before 1500, which is 1300, it will print 1300. And similarly, before 1500, it is 1500, 1500. And then again here 1500, and then again here 1500. This is how lag works. And lead is literally reverse of that. Lead means the next occurring number. Here the first value will be 1290, then it again will be 1290, and partition ends here, so it will go null. Similarly, here also it will go 1500, 1500, 1500, and then the next partition is 16, then the next value is 1690, and then the last will be null. So this is how lag, lead, rank, dense rank, and row number works. Make sense? Let's implement them one by one in PySpark now. I will name this as window functions, and I will say shift plus enter. And this is the data set which I had created. I had already ran, but let me rerun this. Perfect. And now I will add another code and I will add one more text saying that below code is for row number, rank, and dense rank. First thing is I need to define a window specification. For that, I will create a variable window spec and I will say window dot partition by, and here I will mention the column. In this case, my column will be department. So I will mention here department and then dot order by, and on what basis I want to order, on basis of salary. So I will say, let's say salary should be in descending order, and this is how I had specified the variable which is window spec. Now I will use this specification in my select statement. I will say df dot select and I will pull all the columns like name, department, salary. So I will say name, department, and then salary, and then row number dot over, copy paste this inside the over, and I will say dot alias and I will name this as row num, let's say. Similarly, I will calculate rank and dense rank. I will just copy paste this template and I will paste below 2 times. First thing, I will just change here to rank and then I will say here RNK. Similarly, here I will change this to dense underscore RANK and here I will say DRNK. Perfect. And now I will just add dot show and I will run this one. See guys, this is how rank, dense rank and row number works. And I guess if you are from data engineering background, you should be knowing how we work with rank, dense rank and row number function, because these are the foundation of SQL. This is how we partition whenever we are working on the actual projects. So you should be knowing this, but I had already explained you about rank, row number and dense rank. So please practice that. That's very important. Now I will give one more heading, which is lag and lead. Okay, I will say shift plus enter. I will define one more spec. I will say window date, or let's say I will say Jaswinder. Okay. It should not be that you are getting confused that is this mandatory that we need to use window. No, this is just a variable. Okay. So now I will say here window dot partition by, and obviously I will partition by department and I will close this one, and then I will order by date. This time I will say order by date. Perfect. So this is how I had defined my spec. Now I will again say df dot select and I will select couple of columns, name, department, and then salary, and then date. I will mention lag salary over this variable, which is Jaswinder, and I will name this as dot alias lag column. Similarly, I will copy paste and do the same thing for lead. We'll just change here to lead. So once I had defined that, by default, lag and lead works with one precedence, either on next one or either on previous one. But you can even define the precedence. But before that, I will just run this first to show you. This is how lag and lead is working. So the by default, I just told you it is 1. So even if you mention here the precedence 1, it will still give you the same output. See, but if you mention 2, it will start lagging and leading by 2 precedence. See, so it actually changed the output. So this is the flexibility of this PySpark lag and lead, that we can move n number of times further or n number of time backwards based on our requirements. But usually lag and lead is used to go one step, and I never personally used going 2 or 3 or 4 steps. So I don't think that there will be the scenarios. But yeah, you should know that there is this thing which is existing in the PySpark and you can utilize it if it is required. Next up is aggregation window function. I will say aggregation window functions. I will say shift enter. These functions are like sum, average, max, min. So I will show you one. Again, we will define a specification. I will say jas underscore agg, and I will say window dot partition by department, obviously order by the date, and then I will mention dot rows between. Rows between, this is very important to note. I will start the bracket. I will say window dot unbounded. See, it is recommending me windows dot unbounded preceding comma window dot current row. So I had defined a variable. Now I will just use this variable inside my data frame. I will say df dot select. Let me grab it from above. Till this time it will be same, so I'll just copy paste here. Why to waste your time? So I will say here, let's say sum of salary, and obviously sum is only require one parameter, and then yeah, I will remove. No, I won't remove it. I will just change, let's say average abg, and then I will mention here, let's say abg, and here I will mention sum, and yeah, I just need to change this over. I will just copy paste and my work should be done. Let me run this now. Oh, okay. I forget to remove the 2 from the average, but that's fine. Yeah, see guys, this is how we work with aggregation window functions as well. And we had literally covered all the window functions. Please do explore all the row number, rank, dense rank, lag, league, and all the sum, min, max. Okay. Please do explore that. These are very, very important. Okay. Let's discuss about UDF now. So I will just give a text heading saying UDF. UDFs are user defined functions, and these functions allows you to apply custom Python logic to your Spark data frame. Okay, so let's say you have to write something of your very own, then obviously you need to use UDFs. Okay, let's do hands-on as well. In order to use UDF using Python, I will tell you two ways to use UDF. First is the earlier existing way where we used to have Python code written and then we used to call the UDF. And the second way is to use the latest PySpark UDF functions to get the work done. Okay. So I will give you both ways. I will, let's say, method. I will name this as method 1 and shift plus enter, and yeah, perfect. So the first method is Python method. In this method, I will define a function. I will say define, and let's say I will define a calculate discount function. We will use this function, and then I will pass parameter price and discount value. Then I will handle the edge case that if my price is none, this is the edge case, then I will return 0.0. So whenever I write the Python, this is the personal tip I am giving out of the Spark sessions. First thing I do is I handle all the edge cases. So in this way, I eliminate the unnecessary part, and then I just need to write the main logic to get my work done. The same thing I'm following here. First thing, I just eliminated the edge case. If price is none, return this thing. And if price is not none, then return price into 1 minus discount underscore value, and I need to divide this by 100, and that's it. This is how I had created a discount function. Now I need to register this UDF. So let's say I will create discount UDF, and I will use a function which is known as UDF, and I will mention the UDF name, and then I will mention the data type. I will say double type. So in this way, I had registered my function as well. Let's give that comment as well. Registering the UDF. Okay, so once the UDF is registered, we can use this UDF directly inside my data frame. So let's create another code, and I will paste my data set first here. This is the dummy data set which I had just created, and let's run this. Perfect. And let's also run this. Yeah, both of them ran successfully. Now I will create a data frame. I will say df underscore udf, let's say, and I will say df dot with column. I will create a new column. Let's say final price. Then I will use my UDF here. So what was my UDF name? It is discount underscore UDF. I will copy here and paste it here. And then all I need to do is I just need to pass my columns. The first column is price, and I guess it already guessed it. I will just click on tab and fill this out. And yeah, that's pretty much about this one. So let me display this. I will say df underscore udf dot display, and let's run this. Hopefully this will run. Okay, perfect. So I had successfully created a UDF. I had successfully registered the UDF. Then I successfully used the UDF inside my data frame, and I also got the desired output. This is how we work with UDFs. Now let's talk about method 2, using UDF with Spark SQL. So this is also pretty much same. All you need to do is whatever the function you had created here, you need to register the function, but in different way. So here I will use spark.udf.register function, and I will name the register, let's say SQL UDF. And then I will mention my Python function which we had created here, which is calculated discount. And I will just paste it here. And then I need to mention here is the data type, which is double type. And this is how I had successfully registered my function using Spark. And then I had just created the with column, and I had did the same thing. Just I passed this in expression. I had passed my register name, and I had passed my UDF name, the parameters, and then obviously the display function, and it had successfully displayed me the final price. This is the two methods. There is one more method. If I go to the documentation, let's say I search UDF in PySpark, search here, and I will go down. Uh, there is one more function which is using the UDF as a decorator. So you can literally define the UDF at the rate UDF, and you can define it, and then you can literally use directly inside the data frame. This is another way. Okay, and you can even return the data type if you want. So you can obviously try and explore that UDF. Okay, this is something which is not generally used. It is only used when you have a requirement which you cannot fulfill using the PySpark inbuilt functions. Okay, that's all about UDFs. Let's now try to understand write output modes. Let me give the heading write outputs. So in order to write outputs in Databricks using PySpark, we need to use modes. Modes are the behavior identifier, and we have 4 modes. Let me create one more text. First is override, second is append, third one is ignore, and fourth one is error. These are the 4 modes provided by PySpark. Overwrite means it deletes the existing file and replaces them with the new data. Okay. And append means it adds the new rows to the existing file. Okay. And ignore means it silently skips the write action if data is already present. Okay. So it will simply skip if data is already present. And the error, it throws a runtime exception, and this is also the default behavior of the mode. Let's try to run this. I will use this df only, this one, df SQL UDF, and for that I will create another code. And here I will say df SQL UDF dot write dot format. Okay, I need to mention the format of the output file. Let's say CSV. Then I will add backslash, and I will move to next. And then I will say dot option. And obviously I will say header is equal to true. Header is true. And then backslash, and then I will say dot option delimiter. What the delimiter should be. By default, it will be comma only, but it's the good practice to mention the delimiter. And then I will say dot mode. If I mention nothing, it will be the error mode. But first time I will mention override mode, and then I will say dot save, and in the save I will mention the location where I want this CSV file to be created. For that I will click on my catalog, I will go to browse there, and then I will go to demo, and yeah, and then here, and then I will click on volume, and I will click on these two arrows, and I will mention the volume, and here I will create one more folder. I will say CSV override folder, and that's it, guys. So let me run this now. And perfect, it had ran successfully. Now I will just refresh the catalog, and I will go to bronze and then demo, and then obviously in volumes and external volumes. Then yeah, see here, guys. So it had created a new directory, which is CSV override, as we had mentioned here. So now if I open this directory, I will see couple of files. First few files will be metadata file, and then I will be seeing a CSV file with a very stupid name. I will show you that as well. So see, guys. So as I told you, let me expand this. So I will get couple of other files. See, guys. So I got the CSV files based on my data. So this is how the mode override works. Because it had divided the file data into multiple partitions, that's why I am able to see 3 CSV files. Okay. If I rerun this, I won't be able to see any additional files. I will still be able to see 3 files only. Let me show you as well. Let me refresh again. Bronze, demo, volumes, and then external volumes, then CSV format, and see. These are still 3 files. So overwrite will delete the existing files and replace with the new files. Earlier it was 131, 132, 133. Now it was now it is 134, 135, 136. Make sense? Similarly, if I instead of overwrite, if I mention append, and I will change CSV override to CSV append, it will create a new folder with the CSV append name. Let me show you. Going to volume, then external volume, then CSV append. Then here you will see the 3 files. So if I rerun these one, it had ran successfully. Now let me refresh it. Go to bronze and then demo and then volumes, external volume, CSV append, and see, guys. Now this time it had created other set of files. But in CSV override, it was overwriting the existing files. So now this time it had created the another set of partitions. This is how we can work with override append. Similarly, ignore will simply ignore if the files are already loaded and the error is the default one. Okay. So please do practice this as well. This is how we can write the files using PySpark. Okay, so now we had discussed a lot about modes and we had even loaded the CSV files. But usually in the projects, it's not always that we are just working with CSV files. We are also working with JSON files, then Parquet files, then Delta files. Let's also try to implement that as well. I will just run the above script by tweaking that. So I will first do for the same with the JSON. The format and everything is the exact same as the JSON. All I need to do is I just need to remove these two things. Okay. And obviously I need to mention the mode as per the requirement. And then I need to just say instead of CSV, I just need to say JSON. That's it. And I will place this inside my JSON folder. So this is pretty much all about the JSON. Let me run this now. And let me parallelly go to catalog, and then I will go to bronze layer and then demo, then volumes, then obviously external volumes. Here I am seeing json.append folder as well. This means my JSON ran and I can see it had ran successfully. I will click here and I will be able to see the JSON files as well. Similarly, the same thing will be repeated for Parquet files. Nothing much here, to be honest. All you need to do is just change the JSON to Parquet. I will say Parquet, and here also I will say Parquet. And let me rerun this as well. And let me refresh. Again, I will go to bronze, demo, and then I will go to volumes, and then I will go to external, and then I can see the Parquet a dot. Apache_append folder as well, and I can see the Apache files as well. The last one is the Delta format, and this is the one of the most optimized and one of the most widely used as well. So Delta format is the advanced version of Parquet format, where in Parquet format we don't have any kind of ACID properties, commit rollback, and save points. In Delta file formats, we have the transaction log. Whenever we create the Delta files, it creates two things. First, it creates the Parquet for file, and second, it creates a Delta log folder, and inside the Delta log folder we have two kind of files. First is JSON file and second is CRC file, which I guess is known as cyclic redundancy check something. Okay, so let's implement the delta file as well. I will just copy paste the Parquet code and I will just change from Parquet to Delta. So see guys, it is very easy to write in any format, right? This is the beauty of PySpark. Let me run this and let me just refresh this once this ran successfully. uh 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 okay, perfect, and then it is refreshing. And here I can see the delta_append folder as well. And if I open this folder, you will see two things as I just discussed. First is Parquet file and second is this delta log folder. And inside this, as I just discussed, we will be having CRC files and JSON files. So this is how you can load multiple file formats using PySpark. Cool. Well, congratulations. We had literally covered the PySpark transformations. There is always a room to explore, guys. I will recommend you to go to PySpark documentation and do hands-on on all the PySpark transformations which we had discussed. And also there are a lot and a vast variety of PySpark transformations, and these are keep on adding by the time. Okay, so you need to be updated. For that, I will recommend you to go to PySpark documentations and understand which version is giving which new functions. Okay, so this is I am leaving to you guys. My whole intent was to help you understand the root and create the base on PySpark transformations, and which is done for you guys. And now I am sure that you will feel it is very easy to work with PySpark transformations. But there is other kind of audience who also utilizes Databricks, and that audience does not know about Python. So they are not familiar with Python. They even don't know the PySpark. So for these people, Databricks introduced Spark SQL. So they can literally use the SQL in the Databricks notebooks. And when you go to drop down, you will get the option of Python and SQL and few other options like Markdown. So Spark SQL was introduced to help those people who are not familiar with PySpark. So using PySpark, you can literally build the gap between the traditional relational database system as well as the gaps between a data engineer and a data analyst, because data analyst can also easily understand the SQL because it's like English. So let's see what is Spark SQL definition. Spark SQL is a core Apache Spark module designed for processing structured and semi-structured data using relational queries. It bridges the gap between traditional relational database querying and the massive scalability of distributed big data computing. I guess you are clear what is Spark SQL. It's nothing just the SQL inside the Databricks notebook, and you can use the Spark SQL on top of the data frames of PySpark as well. This is the syntax of Spark.SQL. Whenever you need to write the raw core SQL, you need to write the SQL inside a function which is spark.sql, and then you need to either create three inverted commas or either you can create three backticks, and inside that you can literally write your select queries and it will work as it work with PySpark. There will be literally zero difference. But then, Jaswinder, there is another question. If I am having PySpark, I understand that data analyst might not be knowing PySpark and they have to build something, they prefer the SQL. I understand that point. But what should be the best practice? Should I use PySpark or should I use SQL? To be very, very honest with you, in real projects, we literally don't follow a single approach. We follow hybrid approach. What I mean is that we try to utilize PySpark where we can, and we also try to utilize Spark SQL where we can. I will give you the example. Let's say left anti-join. Okay, this join is not something which was earlier available in Spark SQL. Now it is available, but earlier it was not available. So if you have to implement that, obviously you need to use PySpark, right? So the same way there are some functions in Spark SQL which are easy to implement, then it can be implemented in the PySpark. So that's the reason a good developer always use the combination of PySpark and SQL to create a perfectly optimized notebooks. Okay, so Jaswinder, okay, we are clear that we need to use the hybrid approach. Okay, but if my first cell in the notebook is PySpark, and if my second cell in the notebook is SQL, then how these two will interact with each other? How? That's the good question, actually. So, in order to interact with each other, we use views, and these views can be either global views or temporary views. So, let's say the first few cells are in PySpark, and obviously in PySpark, we create data frames. Right. So what we can do is on top of the data frame, we can literally create a view, either temporary or global view, and we can then use that view directly in the next cell, and in next cell we can just select the SQL as the option instead of Python, and we can literally write select star from that view, and it will work as it works on the data warehouse. So then again, if say after a few more cells you want to again use PySpark, then that's also fine. You can literally convert your view to data frame again, and then you can again start with your PySpark codes. This is how you can use the hybrid approach of PySpark and Spark SQL together. So now, Jaswinder, we are clear that we can use hybrid approach. We can have few cells in data frame, then we can create a view, and then we can have few cells in SQL, and then everything is in the sync and everything is talking with each other. I am understanding that point. Now help me in understanding what is the global and temporary view. Okay. So guys, the temporary views are the views which are only available for the current session. Okay. So let's say my compute is running. So till the time my compute is running, my temporary view will be active. And once the compute goes to suspended state, the temporary view automatically will be removed from the system. And let's say even the session is active. Okay. And you have two notebooks. In first notebook, you created the temporary view. Now you are moving to the second notebook and you are trying to query the temporary view which you had created in the first notebook. And you know what? It will give you the error. But Jaswinder, you told us that if the cluster is up and if we are in the same session, temporary view will work. Yes, yes, I told you that. But the thing is, temporary view is based on notebooks as well. So if you created the temporary view in first notebook and you are calling the same view in another notebook, it will treat that as different entity itself, and it will throw the error that temporary view does not exist at all. In order to provide the guardrail for that, Spark introduced global temporary views. So by using global temporary views, you can literally use the view in all the other notebooks you have. This is the difference between temporary and global temporary view. Don't worry, we will also see this in action, but I just want you to understand the difference between both of them. Cool. So I have also pasted an image which I had taken from obviously Spark documentation, that Spark SQL is actually sitting in the same level as the Spark session, data frame and dataset API sits. And this indicates that you are free to use PySpark and or SQL based on your knowledge or your company's requirements or whatever you feel. Okay. So this sits on the same level as the PySpark, as the Spark session, as the data frame. Okay, all you need to do is just to convert the data frame into temporary view or to temporary view to data frame. That's it, guys. Okay, this is all about Spark SQL introduction. Let's now create the temporary and the global view and understand what I meant by accessing them. I am back to my Databricks. Now I will close my PySpark transformation and I will create one another notebook. And this notebook I will name as Spark SQL. I will say Spark SQL. Perfect. And I will just push enter. And then first thing we are discussing about temporary views and global views. Global views. Perfect. Now what I will do is I will create a data frame and I will just copy paste any random data frame from my PySpark transformations. Let's say this one only I will just copy paste there, and I will go to Spark SQL and I will literally copy paste my data frame. And then I also need to import the libraries. I will go to the first cell and I will literally copy paste all these three libraries mentioned here and on top of this data frame, and I will run these things. Now I had ran that code, so I have 100 rows. Let's do convert this data frame into a temporary view. So I will give the heading here, creating temp view. I will say shift plus enter. And then I will say tf dot create or replace temp view. And I will give this name as, let's say, customer temp, cust temp. And I will run this one. Now I have a customer temporary table. So I will just click on new code and I will, instead of Python, I will select SQL and I will just literally write the SQL. I will just select star from cust underscore temp. And let me show you the magic. See guys, as I told you, this is how you can utilize Spark SQL. But all you need to do is create a view on top of your data frame and you are good to use the Spark SQL. Make sense? Let me also try to filter out something. Let's do that where, let's say, index is equal to, let's say, 20. It will show me one entry. See. Okay, so you can literally write all kind of SQLs here and it will work as it should. This is how you can use the temporary view. But now let me just copy paste this complete one and let me create a new notebook and I will try to run my temporary view here. And this time you will see the error that temporary view does not exist. Let's run this because this is eventually a new session. See guys, table of view is not found. This is the limitation of temporary view. But what if I create a global view? Let me go down and create the global view as well. I will just click on code. I will say control V, create or replace global temp view and I will say cust temp global and I will run this one again. Global temporary view is not supported on serverless. Makes sense. Makes sense. So let me go to more and let me attach my compute, which is my compute warehouse, and let me attach it here. And it will take some time to run this. I will wait for this to be getting configured. Now, as you can see, my cluster is up and running. It started running my global temp view query. So as this had ran successfully, I had created my global temp view table as well. And now I am even able to query the global table. I will go to another notebook and I will try to access the global temp view now. I will say select star from cust global view. If I'm not wrong, this is the spelling. Cust temp global. Let me copy paste from here. Select star from cust temp here. And I will just run this and see guys, I am able to see the data in global temp view as well. This is how you can use global temp view in multiple notebooks using the external clusters. Okay, now I will just terminate my cluster. Perfect. And now I will shift back to my serverless cluster and I will show you how we can create the DDL using Spark SQL. So this is very straightforward. In order to create the DDL, let's select Python. I will say spark.sql. And here I will just literally create the DDL as we create in data warehouses. Create table if not exist.
Then I will mention my catalog name. I will go to my catalogs and my catalog name is, I guess, bronze there. And then I will mention my schema name, which is demo dot, and then I will mention my table name, let's say customer temp. And I will mention customer temp using location. And here I will mention my location. This is how we can create the external tables. If you don't mention this one using location, it will create a table inside the managed Databricks environment. Okay. So this is the difference. Let me run this. And it has successfully created the table. Let's see this table. I will go to demo. I will open the tables and I am able to see the customer temp table. This is how we can create DDLs in Databricks. Next topic is joins. So I will just add a text saying joins. I will say shift plus enter. And here I will create two data frames. I had already copy pasted the code for two data frames. First is employee data frame and second is my department data frame in order to show you how we work with joins. Perfect. It had ran successfully. Now I will create a new code snippet and I will literally write the SQL code. I will say spark.sql and inside that I will say select e dot star comma d dot star from my employee temporary view. I will say key and then inner join, let's say, with my departments d on the basis of e dot department id is equal to d dot department id. And I will run this. Obviously, I just need to also add dot show so that it shows a result as well. See, guys. So I had joined both the table. So I guess joins are pretty straightforward, and you already know that. So you can easily explore other joins in a right, left, or a full outer join, cross join. So that's what I have for join.
Let's now understand how we can do upsert. And I guess you are already aware. I am just repeating the things because SQL is something which you already know that you already know that upsert is done using the merge command. So let me just do it quickly for you. Okay, so you can get a quick gist. And I have this DDL ready, so I will just run this one. Okay, and I had created this DDL as a managed table. Next, I have couple of insert scripts. I will insert some data into this table. And that is also done. Now I had created one more temporary view where I am actually storing the new or updated records so that we can see how upsert is working. So I had ran that as well. Now let's write the merge script. I will just open the new tab and I will just say here SQL. And here I will say merge into my table, which is my this table default dot employees. I will say merge into this table as target, and then I will say using my incoming view, which is the temporary view, because this temporary view is only having the updated record as well as the new record. And then I will name this as, let's say, source. Perfect. And then on what basis? On the basis of target.empid is equal to source.empid. Make sense? Perfect. And then I will say when matched. When matched means when the data is already existing and the target dot last updated date is less than source dot last updated date. When this is true, then I will say update set. But I want to set, I want to set target dot employee name, employee department, salary, everything I want to set. And when this is not matched, then I will insert. So I guess Databricks had already auto completed my code. But yeah, this is how you can write the merge script. Let me run this merge script now. Oh, there. Okay. Let me accept and rerun this. It started running. So perfect. It had successfully updated one record and total number of records affected is 2. This is how we can work with upsert, and this is how we write the merge query. And I guess you already know that. I'm just repeating something which you are already aware of. Let's now also understand the explain. We had covered the explain earlier also in PySpark, But here also explain is very similar to that. So let me quickly show you. I will add the text saying explain function. I will just say select star from my table and I will run this script. Okay. So now if in front I will just put the function explain, it will explain me the plan. Let me show you. It will explain me all the physical plan. See, so he had explained me the physical plan, and there is a photon, which is the optimization service. It had also mentioned if there are any kind of partial data or full data and what is the format and all this information. So this is very similar to explain in PySpark. It will show you the execution plan and as well as the photon explanation. Let's now try to read files using Spark SQL. What you are saying? Read files using SQL. Yes, I am saying read file using SQL. How we can do that? We use SQL for transformation, for DDL, DML operations, but we never used SQL to read the files. How this is possible? In Spark, this is possible, guys. And if I say more accurately, with Spark SQL, this is possible. So how we can do that? We can just create a temporary view. I will show you. First thing, I will select the SQL cell here from the drop down, and then I will say create or replace. I will create a view, let's say a temporary view, and then I will name this view as, let's say, customers underscore CSV, and then I will say using, here I will mention the format which is CSV, and then I will say options, and inside this options I will mention the path from where I need to take the file. So let me grab the file from the volumes and in the external volumes, and then yeah, I have this fact sales file. So I will pass this file only here, or even let's pass this only CSV append. I will go inside this and I will pass, let's say, this file. Makes sense. Yeah, and then let me give it into double quotes. Perfect. And then I need to mention the header because my first column is obviously header inside this. And I will say header and then I will say true. Then I will say infer the schema as well. It will also be true. And let me try to run this. And let me also say select star from this customer CSV. Let's run this. Okay. Oh, I hadn't added the comma at last. And here also I need to add the comma. Perfect. Now this should work. Okay. Oh, yeah. So I'm so sorry. Also semicolon I need to add. Then let's run this. Perfect. See guys. So it had printed the output in the CSV format. Similar way, if you have, let's say, other formats and let's say JSON format, let's do that as well. I will just copy paste this one only below here, new code, and I will just change wherever I had written CSV to JSON, and then here also it's JSON, and then I will just mention the another path, and yeah, this should be fine. Yeah, and then let me give it in the double quotes, and let's run this. Oh, I need to mention the JSON as well. Here I mentioned CSV. What you are doing, Jaswinder? Are you tired? No. Yeah, see guys. So it had successfully worked for JSON as well. Similarly for Parquet, you just need to change here Parquet. Similarly for other formats, all you need to change is just you need to change wherever the other file format is mentioned. So this is a standard template you can use for your reference. So this is how you can actually read the file using Spark SQL. I guess this is very crazy, right? And this is crazy. Now, as we had discussed about reading files as well, let me tell you one more trick that how you can directly read the data frame without even creating a temporary view using Spark SQL. But Jaswinder, is this even possible? Yes, yeah, this is possible. Let me give this heading. I will say dynamic data frames passing. How we can do that? Let me do Shift plus Enter and let me create a data frame for you guys. This is the data frame. Let me quickly run this, and I had ran successfully. Now what I will do is I will use spark.sql. I'll say spark.sql, and then inside this I will literally pass my select query. I will say select star from, and here I will add curly braces, and here I will, let's say, create a new data frame. I will say df okay, and then once this is closed, I will assign this object to my data frame, which is my df employee. Okay, and I guess this should work. Let me run this. Perfect, this worked. So let me display the output. So this is another trick where you don't need to create the temporary view and you can directly refer the data frame in your select query. Now let me tell you one more trick which we call as file format connector. So what this trick is, I will literally copy paste above one. Here I will, instead of mentioning this, if let's say if I am reading this JSON file, I will first copy paste this JSON path, Control C, and then here I will first say JSON dot, and then I will mention the backticks, and then I will mention the path, and I will close the backticks, and then I will close the double quotes, and I will remove this part. And to bracket, yeah. So if I run this, it will directly run the same way as it was running above query. See guys. So this is the another trick using file format connectors, where you can literally mention the file format using the file format name dot and then the file location, and then it will give you the same output as you was getting the above dynamic data frames. Let's now discuss about the another very important topic, and this is a very important topic from interview point of view as well, where interview expects that you should tell him the difference between shuffle, sort, merge join, shuffle, hash join, and broadcast join. There is always the confusion between shuffle, hash join, and broadcast join, and even when I used to learn that time, I was also keep forgetting the difference between both of them. Today, I had taken care of that part, that you will never ever forget the difference between shuffle, hash join, and broadcast join. I had simplified it in a very layman term. So I had used a lot of diagrams here, and you will really love it, guys. I had put my heart in creating the difference between these three. So please do like the video, and let's start with shuffle, sort, merge, join. Shuffle, sort, merge, join is the default join behavior in the Apache Spark. I know you already know the joins like inner join, left join, right join, and we even had implemented the joins in PySpark sessions, right? So the same joins actually uses shuffle, sort, merge, join internally. Okay, all the kind of joins get divided into the partitions, and then they shuffle between each other, and then they sort the data, then they give you the output. I will show you the execution plan as well, but let's first understand visually what exactly I am talking here. So let's say you have two tables, customer tables and orders table. So the joining key between customer and orders table is customer ID. So let's say you applied the inner join. Whenever you first create and apply the inner joins, it will get separated into multiple partitions. And the by default partition size is 128 MB, and the maximum partition it can reach is up to 200. Okay, this is latest for Apache 4.0.1. Even you can increase the partition size up to 2 GB, but the by default one is 128 MB. So let's say the tables are divided into multiple partitions when you execute the query. Okay, so now you said I want to do inner join based on my customer ID. So what it will do, it will start shuffling the partitions. All these partitions will go for a shuffle. The shuffling will happen based on a hash ID. So every customer ID will be converted into hash ID. Let's say my customer ID, this one, 135. So it will be like 135, and then it will say modulus, and it will do modulus based on the number of partitions. Let's say the partition are 200 and the tables are very big. Let's assume that. So in this case, the output of 135 modulus 200 is always 135 because modulus returns remainder, right? The remainder here is 135. So what it will do is it will assign this 135 customer ID to the 135th partition. Okay, in this way, 458 again will go for 458 modulus 200. The remainder for this will be 58. So this ID will flow into 58th partition. Make sense? So once it had divided the data into multiple partitions, it will look like something this, that the customer ID 135, let's say this is 135 partition. Let's assume this because I cannot create 135 partitions on this screen. So you just need to assume that executor 1 indicates 135th partition. Okay. So the customer ID 135th came into the partition 135th. Similarly, when you do the partition of this order ID of 135th, it will also come into the same, right? That's why you can see that 135 customer ID is also there from customer table and 135 customer ID is also there from orders table. And similarly, 458 is also here and 901 is also here. So in this way, all the partitions will get shuffled and it will get distributed to the worker nodes, or you can say executors. Once this is done, once all the hash IDs are in their respective partitions and respective nodes, it will go for sorting. Why it will go for sorting? Because if customer ID here is 135 and it needs to be mapped with 135 because we are applying inner join, actually this partition have to go to this one, isn't it? Then again 458 will go to this one. Then again 901 will go to this one. And similarly 598 will go to this one. 298 will go to this one. So there is a lot of shuffling again happening. In order to avoid the internal shuffling, we do sorting. Make sense? So once we sorted the data, it will be aligned in a single stack. As you can see, the customer ID of customer table 135 is directly aligning with the customer ID of orders table. And similarly, customer ID of customer table 458 is directly aligned with customer ID 458 of orders table. And similar thing will happen with other executors as well. And in this way, I had actually achieved the shuffle sort merge join. This is the final outcome, and this is now very easy for the executors to do the joins and give you the desired output. Okay, this is how shuffle sort merge join works. This is the default behavior of the joins. It will first shuffle the data based on partitions, and then it will sort the partitions, and then it will apply the joins, and it internally helps Sparks a lot. This is a default behavior. Okay, let's now understand the definition. The shuffle sort merge join is the default join strategy in Apache Spark. Okay, it pairs two massive data sets by redistributing data across the clusters, organizing it sequentially, and combining matching keys. This method is highly reliable for joining large tables that cannot entirely fit into the memory. Make sense? This is all about shuffle sort merge join. So whenever you are running any kind of inner join or outer join or full join, you will see the jobs, stages and tasks, and you already know what are these. So if I click on those job stages and tasks and open the plan, it will look something like this. It will be having multiple stages, and those stages will be having local table scan, and then it will be going for shuffling. So it will be exchanging the data between each other, and once they had exchanges the data, it will go for mapping the partitions internally, which means it will go for sorting, and once sorting is done, it will map the data and provide us the desired output. This is how shuffle sort merge join works. This is very, very important to understand because this is how all the joins are internally working within your Databricks notebook. Whenever you are applying any kind of join, this is how it is working in the background. Okay. Next one is shuffle hash join. This is very much a subset of shuffle sort merge join. But the only thing which we don't do here is we just don't sort the data. Let's say again you are doing the inner join and you are starting shuffling the partitions. These are your partitions. And what will happen is there are two tables, and based on two tables, it had created multiple partitions, as you can see on your screen, right? Now, what it will do, it will create an in-memory hash table for that table which is having less size. Let's say in this case, orders is having less size. So it will create an in-memory hash table for that, and it will go for respective partitions based on hash IDs, and it will distribute the customer tables. And when it comes to the in-memory hash table, all the orders table will be sitting in this one. Complete orders table now is in memory of the Spark. Now what it will do, it will go to the respective partitions and executors, and it will start doing the hashing for that memory. Okay, so output for this will be only these three customer IDs from the orders table. Similarly, the output for this will be the three customer IDs from the orders table. So it is only doing the hashing on the complete table. That is fine. But the output here is only matching the hash ID. Okay, this is very important. Let me change the color. So output here is only the hash IDs. Okay, not the complete in-memory table. Okay, that will be something which we'll be covering next. So output will be only specific to this one. Okay, this is how shuffle hash joins work. This is the most easiest way I can explain you what are shuffle hash joins. Hope that actually makes sense to you now. The last one is broadcast join, and the syntax for broadcast join is something which we had not covered in the joins. So I will first tell you what is the syntax. Here we will say dot join, then we mention the broadcast keyword, and we pass the smaller data frame. And by a smaller data frame, I don't mean the smaller table like in shuffle hash join. I mean the smaller data frame with the size less than equal to 5 MB. Okay, then only the broadcast join results will be very optimized. Else the join result will be very, very unoptimized. So always remember, use broadcast join when the smaller table data frame size is less than equal to 5 MB, and that data frame you are okay to share with all the executor nodes. Then you mention the join key, which is customer ID in our case, and this is how the syntax of broadcast join is designed. And now let's come back to the topic where we will be shuffling the partitions. So shuffling the partitions happens everywhere because Spark works on distributed framework. Shuffling will obviously happen. Once the shuffling happen, it will again create an in-memory hash table like we had seen in shuffle hash join. But the difference here is it will go again for hash ID, number of partitions. But now this complete in-memory hash table will be shared to the specific partitions. Okay, in my shuffle hash join, I was doing the hash ID modulus number of partitions, and I am only giving the subset of in-memory hash table to the partitions. But in broadcast join, I literally broadcast my complete in-memory table to all the partitions. Like I am literally giving you the example, like we broadcast the YouTube video. Whenever we broadcast the YouTube video as public, it is literally available for the whole world to access it. The same way broadcast join, broadcast the complete in-memory hash table to all the partitions. Okay, this is how broadcast join work. The difference between shuffle hash join and broadcast join, I guess, should be very clear. In shuffle hash join, we are creating in-memory hash table, but we are only passing the subset relevant to that partition to the partition. But in broadcast join, we are completely broadcasting our in-memory hash table. This is how broadcast joins work, and this is very important question for interview point of view. Please do make notes for these guys. I am literally telling you, this is very, very important. Let's now understand deployment modes. There are two type of deployment modes supported by Spark, which are client mode and cluster mode. So I won't explain directly to you that what is client mode and cluster mode because it will confuse you, which I really don't want. So I will again take an example to show you first how this works, and then we will jump to the definition. So let's say this is you and you submitted a code to your edge node. So now what is edge node? I guess you are already aware, but let me re-explain it. Edge node, or you can say a gateway node, is a dedicated machine that acts as an interface between you and a distributed Apache Spark cluster. It's not the actual computing cluster actually, but it contains all the necessary libraries, all the configurations file, and all the required things to communicate with the cluster manager. Okay, so now you had submitted your code to the edge node. So what edge node will do? It will request the resources from the cluster manager and it will create the driver node locally. Okay, so now driver node is sitting in your edge node. Now this driver node will go and request the cluster manager to execute the task. Then cluster manager will assign the task to the worker nodes. And this is how client mode works. In client mode, the driver node is present on the edge location. Okay, so let's see the definition. The client machine requests resource allocation directly from the cluster manager. Okay, but orchestrate task locally. Why locally? Because driver node is sitting in the edge node. Executors still live on the cluster worker nodes. Okay, makes sense. So now let's also see the edge node definition as well. The edge node or gateway node, which we just discussed, is a dedicated machine that acts as a primary interface between users and the distributed cluster. Okay, it's not part of the actual computing cluster. It is a separate entity, as you can see, but it contains all the privileges, all the libraries, all the files, and all the tools which will help the edge node to communicate between the user and the cluster manager. Make sense? Perfect. Now let's see what is the cluster mode then. Now again you submitted your edge code in the cluster mode scenario. Okay. Now what it will do is it will submit the package to the cluster manager. Okay. It won't go to the cluster manager and say, hey, I need the driver node. No. In cluster mode, it will submit your package directly to the cluster manager. And then what cluster manager will do? It will select the worker node to host, which will become your driver node. And this driver node will execute the driver programs by using other worker nodes. Make sense? This is the difference. So between client mode and cluster mode, the difference lies where the driver node is sitting, either in locally or either in your cluster of worker nodes. Makes sense? Let's read the definition of cluster mode as well. The client submits the package code to the cluster manager and can safely disconnect. The cluster manager selects a worker node to host, which becomes the driver node and executes the driver program by distributing the work to the worker nodes. Make sense? This is how deployment modes work. The biggest pros and cons for client mode and cluster mode is, if we talk about client mode, this mode is actually slow. Why? Because the driver node is sitting locally. So it have to bypass the cluster node to communicate with the worker nodes. And similarly, once the worker node had executed the task, it will again go back to the driver node at a distance. So it will create latency. But the cluster node will not create any latency because edge node is just submitting the package and then it is disconnecting, and all the worker nodes and driver nodes are very near to each other to communicate. Okay. It's time to discuss about adaptive query execution. Adaptive query or execution is an optimization technique which fine-tune the execution plan. It was introduced in June 2020 via Apache 3.0, and before that there was a lot of bottlenecks, and this adaptive query execution clearly became a lifesaver. I will show you how. Let's first understand the definition. Adaptive query execution is an optimization framework in Apache Spark SQL that dynamically re-optimizes and adjusts the query plans during runtime based on actual data statistics collected during the execution. Okay, so whenever you are submitting your job for execution, it will see your plan and it will try to optimize the plan automatically. Unlike static planning, which relies entirely on pre-calculated and often inaccurate or stale table statistics, adaptive query execution uses intermediate materialization points such as shuffling or broadcast joins to gather real-time metadata and continuously fine-tune the remaining execution plan. Okay, let me explain you in more detail. So there are three core features of adaptive query execution. If you understood these three core features, you will be very clear what exactly is adaptive query execution. Okay, the first feature is dynamically coalescing shuffle partition. So whenever we have multiple partitions and we need to change the partition size, do you remember we use coalesce function? Yes, right? So now the first point is very similar to that. It will dynamically shuffle your partitions. What I mean is, let's say you have partition 1, partition 2, partition 3 and 4, 5 and up to partition 200. This is the default partitions which is always there in Apache Spark. But now adaptive query execution comes into picture. It will see, okay, partition 1 is very big, partition 2 is less size and partition 3 is of also less size. Maybe we can combine partition 2 and partition 3. Then adaptive query execution will also see partition 4 and partition 5. And it will say, yeah, maybe we can combine these as well and process them together. So what it will do, it will literally combine these partitions so that it gets processed all together. So it uses the coalesce function behind the scene, and adaptive query execution will see, hey, I can see from partition 6 to partition 200 everything is empty. Why you are here? I am going to evict you. So adaptive query execution will evict all the empty partitions and it will combine the partitions if required and will process them all together, and it will optimize my performance. This is the first feature of adaptive query execution, and it focus on how adaptive query execution improves the performance. This feature prevents performance degradation caused by the default spark.sql.shuffle.partition setting, which is defaulted to 200 partitions. If post shuffle data is small, adaptive query execution automatically merges the small and contiguous partitions into fewer or larger ones at the runtime. This dramatically minimizes the task scheduling overhead and prevents executors from processing tiny chunks of data. Make sense? I guess this should be very much clear to you now. Next feature is dynamically switching join strategies. Before discussing this one, I want you to remember the join sessions where we had discussed about merge sort join, and broadcast join. And I told you that merge sort join is the default join which is implemented by Apache Spark, right? So now the scenario here is you have a 10 GB file and you have a 3 GB file. So what you want to join these two tables or files. So the by default, if there is no adaptive query execution, it will go for merge sort join, right? It will take a lot of time. But now adaptive query execution came into picture. It will first see the 10 GB file. There is a possibility that we can reduce the size of 10 GB file before applying the join? And when it will look the file, it will say, no, there is no possibility. We need to take the complete 10 GB. Fine. So then adaptive query execution will go to the 3 GB file and it will again ask the same question that, hey, 3 GB file, is there any possibility that we can reduce you? If the 3 GB file will say yes, then adaptive query will say how much your data is actually required. It will analyze and it will say, okay, you are required data less than or equal to 5 GB because of the filtering which is applied in the in the query. So if the case is that if the object size is getting shrinked to less than or equal to 5, adaptive query will immediately evict the merge sort join and immediately apply the broadcast join. Okay, this is something which adaptive query internally do. We don't do that. But Let's say this is not the case. The file of 3 GB is still required, complete. Then adaptive query will go with the merge sort join only. But it will try to understand how much data we can filter. If the filtering is coming in the criteria of adaptive query broadcast join, it will not hesitate to evict it. This is the beauty of switching join strategies using adaptive query execution. The traditional optimization determines the join type before the execution starts. If filtering reduces one side of a join below the broadcast threshold, which is there in spark.sql.auto broadcast join threshold, adaptive query execution automatically converts the heavy sort merge join into a much faster broadcast hash join on the fly, eliminating the unnecessary disk and networking shuffles. Make sense? Cool. The third one is dynamically optimizing the skew joins. What do you mean by skew joins, Jaswinder? I explained you earlier also. If the table is very huge and let's say the 95% of the data is coming in a single partition, this problem is known as data skewness. Okay, so now what happened here also, adaptive query execution understood that there are only two partitions for this object and the first partition is almost 95%. So what it will do is it will split the partition one into multiple sub partitions, and then it will take the partition 2 as it is, and then it will process the partitions. In this way, it is avoiding the data skewness by splitting the partitions into sub-partitions. Data skew occurs when a few partitions hold the vast majority of data, stalling the entire stage while a single task struggles to finish. Adaptive query execution detects the skewed partitions based on runtime statistics and split them into smaller subpartitions. It then processes them in parallel alongside duplicated matching keys from the opposite table, saving developers from manually implementing the complex sorting techniques. Make sense? This is all about adaptive query execution, and it is the most important topic from interview point of view as well as the Spark exam point of view. You should be knowing that what exactly adaptive query execution do and what are the three core features provided by adaptive query execution. Okay? Perfect. Let's now discuss about the very important topic for the interview point of view, which is cache and persist in Spark. And I guess you are already familiar about what is cache and what is persist. If you are not familiar, then these two terms in very layman language are used to store the temporary data so that you can use the data set somewhere else. Okay, it is a very simplified definition. Okay, so now let's talk about cache and persist with the Spark perspective. So these two again are the optimization techniques. Okay, and these are used to store the intermediate computation results as same like other cache and persistence. And these intermediate computation results are stored from a data frame or data set or RDDs based on obviously the requirements. And these obviously can be reused for any kind of subsequent actions. Okay, this is the most simplified way I can say. Both are optimization techniques and both store computation results and both reuse the stored computation results. Okay, three things: optimization techniques, store computation results, reuse the computation results. Cool. So now let's talk about the difference between cache and persistent. Cache is the very shortcut method that saves the data directly within the default storage. What do I mean by default storage? Jaswinder, what is default storage? By default storage, I mean memory and disk in case of data frames and only memory in case of RDDs. Okay. Then what about persist? Okay. Persist is the flexible one. Cache is the shortcut method. It is not flexible. Persist is the flexible method and it allows you to specify your custom storage configurations. And these are stored on storage level parameters. What? What is storage level parameter? Storage level parameter means you have the flexibility to store the data either in memory, either in disk, either in both. Okay, let's see the definition of both of them. Catch and persist are optimization technique. Number 1 point, let me take the highlighter. Number 1 point, these two are optimization technique used to store intermediate computation results. Number 2 point, over data frame, dataset or RDD, so they can be reused across subsequent action. Number 3 point, this is all about catch and persist. Make sense? The difference, catch is a shortcut method that saves data with the default storage level, because you cannot configure the cache. So you need to store in the default storage level. And what is default storage level? For data frames and data sets, the default storage level is memory and disk. Okay. And for RDDs, default storage level is memory only. Make sense? Whereas persist is the flexible method. Why it is flexible? Because it gives you the complete flexibility where you want to store the data, Jaswinder. Do you want to store the data in the memory and disk? Do you want to store the data in the memory only? Tell me. So it will give you the flexibility. That's why Persist was introduced in the Spark. And if I am not wrong, this was also introduced in Apache Spark 3.0. Okay. And if I'm wrong, please correct me in the comments. Okay. So now let's talk about more differences about catch and persist. First feature, if we talk about flexibility, can you guess what will be the answer for catch? Do you think catch is a flexible? No, right? It is clearly written in the above line that persist is a flexible method. So do you think flexibility catch comes into the picture? No, right? It is the fixed wrapper. Okay. I will print out the features, but I will expect answers from you. Okay. Because you already now know what is catch and persist. All you need to do is to use your mind to answer me. Okay. Now let's answer about persist. What do you think? Is the persist is having flexibility? Yes. Yeah. It accepts the custom storage behaviors. Perfect. Now, next parameter is default storage. Tell me, if the default storage is data frame and dataset, what should be there in the cache? Yes. In cache, it should be memory and disk. And if you are saying, no, Jaswinder, is memory only, then please, guys, please listen carefully. Okay. So the correct answer is memory and disk. Okay. What about persist? Perfect. Yeah. It is also memory and disk if no parameter is passed. Perfect. Now, what if the default storage is RDD? Yes. If you set that, Jaswinder, if the default storage is RDD, cache will be memory only, then you are accurate. Here, the answer will be memory only. But about persist, in case of all the legacy RDDs, default behavior is memory only. Doesn't matter you are using catch or persist. In case of persist, the flexibility is if you mention it, you can change it. If you don't mention it, it will again stay the memory only. Okay, perfect. The last one, parameters. Does cache need any parameters? No, right? Don't need any parameters, right? What about persist? Yes, yeah. It accepts the storage level parameters, right? So now you are very, very, very clear that what are cache and persist, and you yourself answered about all the features. So now the same thing I want you to answer in the exam as well as in the interview. You should be very clear now because you answered to me. And I expect the same answers you should be giving to the interviewer, and you should be able to crack the interview. I want you to get a decent high paying job. Make sense? Cool. Let's now understand the partition pruning and dynamic partition pruning. These both are again the query optimization techniques. What happened earlier in Apache 2.0 was there was no dynamic partition pruning. So if you have to filter and optimize the query, you need to ensure that you need to apply the partition by explicitly. This works fine when you know that on which column you are applying most of the filters and which columns are most widely used. This is very, very, very helpful in that. And till today, partition pruning is very helpful in that. Then there is other case. Other case is you have a table. Okay, table have a lot of columns. Okay, now you don't know that which columns will be filtering out in which. So the column filtering is unknown to you. In Apache 2 Spark 2, you don't have any option. But then in Apache 3.0, they introduced dynamic partition pruning, which automatically partition your data when the columns for getting partitions are unknown. Make sense? So let's read the definition. Partition pruning and dynamic partition pruning are query optimization techniques in Apache Spark that drastically reduce input, output, and processing time by skipping the unnecessary partitions. If we talk about partition pruning, which is known as a static, here what happens is Catalyst Optimizer will come. It will see the filters which you had applied in your query, and then it will evaluate the filters against the table's partition schema, and then it will read only those folders which will satisfy the conditions, and it will prevent all the table scans. True. But this is only true when you know the columns on which you need to do the partition. This is known as partition pruning static. And you can say partition pruning. It is still there and it is still very helpful. I'm not saying it is deprecated, but it is more mature now with dynamic partition pruning. So the partition pruning occurs at query compilation time. When you explicitly filter a dataset on a column used to partition the data on the disk, Spark skips reading all the directories files that do not match the criteria. It will literally prune all the folders. Okay, how it works? I just explained you that Catalyst Optimizer will come and it will examine the filters and then it will evaluate them against the table partitions. And then it will only read the folders which actually satisfy my partitions and conditions, which prevents the full table scan automatically. Make sense? Now let's talk about dynamic partition pruning. So now I had already told you that this was introduced in Apache 3.0 for the audience, for the requirement, or for the use case where the filter conditioning is unknown. That's all about dynamic partition pruning. Now let's read the definition as well. Introduced in Spark 3.0, DPP is an advanced query optimization that handles scenarios, okay, where the filtering condition is unknown at compile time. This is important to note and is instead determined at the runtime, typically during applying a join. How it works? If we talk about that, so I had written a complete scenario for you. You can read that. I will also read for you. Imagine joining a massive partitioned fact sales table, okay, with a very small customer dimension table, okay, and you are trying to filter based on country. Cool. You said select star from my dimension table where country is equal to India. Before Spark 3.0, partition pruning was there. So it will read the entire sales table. Then it will read the entire customer table. Then it will shuffle the data across the cluster and apply the filter of country is equal to India. Very time consuming, very unoptimized approach. Now comes the DPP into picture. What will happen now? Spark will strictly go to the small dimension table. It will try to filter out and try to identify the partitions which matches the partitioning keys. Once it identified that, it will pull all the other data and it will take that subset of data and it will dynamically create a filter on the larger table and then it applies the joins. Oh, so here filtering is happening before the joining is happening and it is even creating a filter on top of my sales table. Oh, that's why dynamic partition pruning is advanced query optimization technique. Yeah, exactly. This allows Spark to completely bypass reading the irrelevant partitions of the large table. That's all. Let's now discuss about another important to remember topic, which is salting. Although we don't use salting much nowadays in Apache 4.0, but you should know what exactly is the salting because there might be the cases where it might come into the picture again. So you should be knowing how to implement the salting. Before going into the definition, let me help you understand what exactly is salting by the example. Let's say you have a 10 GB file. Okay. And obviously there are two columns, ID and name. And when you will try to apply the partition by ID, you will notice that 95% of the data will go in a single partition, right? ID1 will be carrying all the 95% or let's say 98% of the data, right? So this is a very big problem of data skewness. Majority of the data is in a single partition and second partition is very light. In order to avoid that, we used to use salting as a method. What we do here is we add a new column which is salt column, and we will assign the random values using rand function of Python. We will assign the random values to all the IDs. Okay. So once this is done, then we add another column which is the aggregated column. Aggregated column means concatenation column of salt ID and ID. So as you can see, so first is ID, and then I had used hyphen. You can use underscore or you can even use space. It's up to you. So then we concatenate the main partition column with the derived salt column, and we create a new column, and let's say that column name is salt ID. Okay, and you can name this column anything as per your choice. So once this is done, now if you apply the partition by based on salt ID, do you notice the difference? Now instead of having a single partition of ID, we are having multiple partitions, which eventually is resolving the data skewness. Make sense? Now let's go to the definition. Salting is a technique in Apache Spark used to resolve the data skewness. It involves artificially adding a random value, a salt, to heavily concentrated keys like ID is equal to 1. This breaks the massive partitions into smaller, evenly distributed chunks, preventing out of memory errors and drastically speeding up joins and aggregations. Let me show you an example. Okay, and for this example, I will take you to my Databricks notebook. So I am into my Databricks notebook and I will create a new notebook. I will click on notebook and I will name this notebook as salting. And now first, obviously, I will import some libraries. I will say from PySpark.sql, import everything. And then I will also import from, yeah. So these much is fine. Let me run these. Okay. Now I will give a heading here, salting with joins. Shift plus enter. I have a data set. I will copy paste my data set here. Here having two tables. First is skewed transaction and second is my user profile table. So on top of that, I had created the data frames, df skewed and df users. Let me just run it quickly. Perfect. So it had ran successfully. Now we will apply the salting to the skewed data set. Okay, we just had seen in my PPT, salting is applied on the skewed data set. Now you tell me which data set is skewed. Is this one is skewed or this one is skewed? Obviously, this one is skewed because Jaswinder, we can clearly see that guest ID 01 is repeating multiple times and it is itself creating a bigger partition and other partitions are very, very small. Yes, you are right. Let's do that. So let me add a new text. I will say applying salting to the skewed data. Okay, I will say shift plus enter. And now let's do that. How we will do that? I will first define the number of salts. Let's say I want to have a number of salts, let's say 2. Okay, it can be 3, 5, 10, up to use case. If the data is really huge, really huge, in normal scenario, it might be, let's say 15, 20. So you need to figure it out how much should be the salting you need to apply. I had mentioned the num salt 2. This means we will split the skewed guest 1 rows across two distinct salt buckets. That will be 0 and 1. Let me give that as well. We will split the skewed transactions into two buckets. Those are 0 and 1. Now what I will do is I will add a new column on top of my data frame. So I will say df skewed, let's say salted. I will mention my data frame name, which is df underscore skewed. Then I will say with column because I need to create a new column. And the column name I want to create is salt. I will say salt. And then I need to mention the floor value. I will say f dot floor, the floor of random value f dot rand, then multiply by the number of salts. This will create a new column. Let me show you that column. I will say display df skewed salted. Yeah, let me run this now. I hadn't defined the function as f, so let me remove the f. See guys, so now we have a new column with random value as 0 and 1 because I had created only two buckets. Num sol 2 means two buckets. So it had randomly assigned few guessed 0 1 as 0 and a few guessed 0 1 as 1. Now next step, let me comment this out. Control plus backslash. Now I will generate a new composite key. Basically, by new composite key, I mean is I will drive a new column by concatenating my this salt column with my original, I guess, user ID column. Yeah. Let me give the comment as well. I will say generating new composite key. Okay. So I will create on top of this only. So let me just copy paste here. I will say this one dot with column, and then I will name this column as, let's say, sorted user ID only, user ID, and then I will mention the concat function. I will concat my column user ID, and then I will pass the literal comma lit and the literal, let's say, underscore, and then I will pass the second column, which is the salt column. Perfect. Now let's say display of df skewed salted, and now let me show you how it had generated a new column by combining the user ID and the salt, as you can clearly see. So this is my step 2 where I am applying the salting to the skewed data. So now we had successfully applied the salting to the skewed data frame. Now let's move to the third step. Third step, let's say I will name this as step 3 as replicate the lookup dataset. Shift plus enter. So now we need to create a array range of our salt values. Okay, so let me give a comment. Create an array range. I know it might be challenging for you to understand in a single go. So I will recommend you to watch this video 2 to 3 times. Then it will be very clear. Why I need to create an array so that all the values will be sitting in a single place, in a single record. Okay, so let me define that. I will create a new data frame. Let's say df salts, and I will say spark dot range, and here I need to mention my variable which I had created up, which is num salts, and then I will say I need a column with column, and I will pass the column id comma salt. I will say display df salts. So here with column renamed, it is not a literal, so I need to pass the complete one, and yeah, let's try to run this. See guys, so now I have values based on my num salt in my data frame salt. Okay, now I will replicate every lookup row by cross joining it with my this data frame. Let me write a comment. Replicate every lookup row by cross joining it with my salt range. So what I mean is I will literally apply cross join between this df salts and this user table. Okay. In that way, it will be completely replicating the salt value with the user table. Okay. So let's do that here itself. First thing, I will just comment this one, control plus backslash. And then I will just say df user replicated, let's say. Here I need to use my user data frame. and then I will say dot cross join. Then I will add my df salt here. Yes, that looks good. So now after that, let me display it for you. Let's run this now again. And see guys, so now I had applied a cross join. So by applying a cross join, my three values in the user table, initially I was having three values, and in the salt we was having 0 and 1. So 3 into 2 6. The output is 6, one row with the salt 0 and second row with salt 1. And similarly for user 99, one row for 0 and second for 1 0 1 0 1. So it had successfully applied the cross join. Now it's the time that we should generate the matching composite key on this lookup side. So what I am saying is, let me write down, generate matching composite keys on the lookup side. Let me show you what I mean. So what I will say, I will just use data frame. I will just copy paste here and I will overwrite it with the same data frame. And then I will say dot with column. Basically, I'm adding a new column, and the column is, let's say, sorted user ID, because I had defined the same column in my skewed sorted data frame as well. So the same thing I am going to do here actually. Okay, so now the next step is I will copy paste from here only. This one only, let's copy and save the time. So this is the step of replicating, generating the matching composite key on the lookup table. It's very similar to generating the composite key for the main table. So let me now again display it, and let me just first comment this one. I don't want to confuse you guys. So let's run this again. Now we got the sorted user ID as well. This means now this can be joined successfully with my main table. Now let's apply the join. The next step is joining on the balanced keys. Okay, shift plus enter. So in order to join, I need to create a new data frame. Obviously, I will say df join sorted, and I will just grab both the data frame names. First one is df skewed sorted. Let me copy and paste it here. And I will say dot. Obviously, you know how to join. And then I need to mention the lookup table, which is my this one, df user replicated. Copy here and paste here. Perfect. And then on what basis I need to join, I need to mention that. So I want to join this on sorted user ID. I will mention that. And how I need to join, let's say I need to join with the base of inner join, and after this is join, I will display my output, and that looks good to me. So let me run this one as well. Yeah, perfect. So now I had successfully joined both the tables based on my sorted user ID. Cool. Now everything is done. The next step you can do is you can just drop the sorted user ID, because now it is no longer required. Make sense? So in this way, it had divided the things into multiple partitions, and it actually removed the data skewness. So this is all about salting. Okay, I will attach this notebook in my GitHub. Don't worry, but just go through that and you will be good to go. And I will recommend you to go through this salting video at least twice or three times, because first time might look challenging. So I don't want that you just binge watch this specific video. Okay, perfect. Let's now discuss about SQL Hints in Spark. So SQL Hints helps the Spark optimizer sometimes to give the Spark optimizer hints. SQL Hints helps sometimes Spark optimizer by giving it the hints that please do this and please do that. In that way, Spark optimizer use the hints to select the efficient strategy instead of just going with the Spark optimizer strategy. And these hints are not always which Spark follows. Sometimes it even reject the hints because Spark is very mature and it understands if your hints will really help the Spark or not. If the Spark found knows your hints are very helpful in optimizing the things, it won't hesitate to use it. But if it feels that no, your hints are not much relevant, it will go with its own way, but it will give the priority to your hints. Okay, so let's go with the definition. SQL hints in Apache Spark are optimization directives that let you manually guide the Spark SQL Catalyst optimizer execution plans. They are especially helpful when missing or outdated table statistics cause Spark to select an inefficient execution strategy. Okay. We can apply hints in native SQL using standard comment syntax, which is \* and then we can mention the hint name with the parameter. Then we can close it *\/ or natively within the PySpark using .hint in the data frame API. Okay, let me show you few examples. So this is the first example. When you're trying to apply the broadcast join and you know that your joining table is very small, so you can mention the hint so that Spark will avoid the default merge sort join. And anyway, if you even don't mention it, Spark is very clever to understand. But if you mention this, obviously it will help Spark in getting the more confidence that yes, the broadcast join which I am going to apply is very relevant here. Similarly, the second example is when you are trying to apply the merge join, you can literally mention that don't apply any other join, just go with the merge join. And similarly, if your table will be distributed into 5 partitions, it will be very much optimized. You can mention that as the hint and Spark will consider that hint and it will see if the things are true, then it will automatically do the same. This is how SQL hints in Spark work, and these are very helpful with the Spark optimizer executions. Let's now discuss about broadcast variables. These are the read-only variables which you can obviously broadcast to all the executor nodes. Let me give you an example. Let's say you have couple of executors. Let's say you have n executors, and let's say you are using a dictionary which is giving you the full form of the words, like US indicates United States, IN indicates India, UK indicates United Kingdom, in that way, so on and so forth. You have a dictionary of the nations. So it is not a big data set. It is hardly of 200 records or let's say 300 of records data set. So now if you pass this only to one executor, so what it will happen is, if executor 2 needs the same thing, it will face a network latency and it needs to go to executor 1 and then demand it, then shuffle it, then it needs to get the work done. And similarly, if you have n executors, this same process will be repeated n times. In order to avoid that, what you can do, you can create this dictionary as a broadcast variable. Okay, and broadcast variable by default are read only. This means you cannot change it. So then once you broadcasted it, it will get cached inside your memory and it can be used by all the executors at the same time. So this is the beauty of broadcast variables. Cool. So once you broadcast your variable, all the executors can use that broadcasted variable simultaneously or parallelly, anything you can say. So this is very, very helpful when the same piece of input is used by multiple executors. Let's see the definition. Broadcast variables in Apache Spark are read-only variables that are cached on each executor node rather than being sent dynamically with every individual task. By default, when Spark runs a closure containing a reference to a standard variable, it serializes and ships that data to every single task. For large lookup tables or data sets, this default behavior creates a massive network and memory bottlenecks. I had highlighted it in red to indicate that it's not something that you just want to broadcast something and you are just going it. You need to ensure that the variable which you are broadcasting is of the fixed length. It is not something, it is a very large data set which you are broadcasting. This is how broadcast variables work. Cool. Let's now discuss about accumulators in Apache Spark. Actually, accumulators are just the shared distributed variable which are used for aggregating the information. That's it, guys. Okay. So whenever you are aggregating the information across the worker nodes and you are supplying that information back to driver nodes, this is where the accumulators are used. Okay. And these are very helpful in debugging, monitoring, or keeping the track of any specific metrics during the distributed data processing.
So let's read the definition. An accumulator in Apache Spark is a shared distributed variable used strictly for aggregating the information across the worker nodes back to the driver node. So basically, it is the write only shared variable and driver only will read this value. Okay. And as I already told you, these are very helpful in debugging, monitoring, and keeping track of specific metrics during the distributed data processing. So what will happen is executor will come and they will add or update the values. Okay. And then these values will be used by driver to read. Okay. And this is mainly used for actually tracking the bad records or any error records. And if we talk about the key characteristics, first is, as I just discussed, these are write only executors because all the worker tasks can only add to the accumulator, but they cannot read its value. Read can only be done by the driver. Okay, that is my second characteristics, read only for driver. And the third point is it is associative and commutative. This means if I had done the update operation, it will aggregate all the information so that the final task order execution won't be impacting your final results. Okay. And the fourth one is it is fault tolerant, and obviously Spark handles the failure very gracefully and it takes all the required actions immediately, and it ensures the accumulator is applied exactly once, ensuring the item potency. So the syntax for accumulator is sc.accumulator, and this is how you can enable the accumulators. These are not something which we widely use, to be honest, and I personally never used accumulators in my work. But obviously, this is important topic for Spark examination point of view. That's why I had highlighted what is accumulator. So you should understand this as well. Cool. Let's now discuss about garbage collection. So as you already know that Spark is heavily reliable on the in-memory computations. So it is very important to have a garbage collection in place which will collect all the garbage and throw it away so that JVM can actually reclaims its memory back and it can use the same memory in other tasks. Okay, so this is the very high level that what exactly is the garbage collection. It will go, it will see the objects which are no longer used, and it will try to reclaim the memory back. Okay, so once the memory is reclaimed, and by memory I mean heap memory. Okay, so once it reclaimed the heap memory by deleting the objects that are no longer referenced by any task or applications, this memory will further be utilized for other Spark tasks. It will prevent avoiding the application crashes because it is collecting the non-referenced objects on time. Okay, so let's understand the definition now. The garbage collection in Apache Spark is the process by which underlying JVM automatically reclaims memory occupied by unused objects. As Spark relies heavily on in-memory processing to achieve high performance, inefficient garbage collection can stall the application execution, spike CPU usage, and even cause job failures. So this is what we had discussed. That's what, I always love to explain the things in advance and in the raw format, because when I was learning and I was going through a very, very tough terminologies, it was very tough for me. So I always prefer to simplify the things first, and then I prefer to go with the definition, because when I help you understand first and then if you read the definition, it will automatically make sense to you, right? Like right now it is automatically making sense to you that garbage collection is very helpful to reclaim the memory occupied by the unused objects. Why? Because Spark is heavily rely on in-memory processing. Cool. Let's discuss about how JVM affects the Spark. So basically, Spark runs on JVM, right? You know what? The JVM divides its heap memory into two main spaces. Okay, or you can say two main generations. First is young generation and second is old generation, obviously, right? So yeah, so these two are the generations, or these two are the spaces, you can say, where GVM divides its heap memory. Okay, whenever I am talking about memory, please do note that I am talking about heap memory. Okay, so now you have two generations, young generation and old generation. And can you guess which one is the latest one? Obviously young, right? So now let's discuss about young generation first.
So young generation is very helpful when you have to store short-lived temporary objects. Okay, which we can say which you are running something and which are created by the task on the fly. Let's say example is, let's say, map operations. Okay, so this is a memory which is very highly frequently used by Spark and it is very fast. Okay, and you can even call it minor garbage collector or GC. Make sense? So let me repeat myself. Young generation stores the short-lived temporary objects and it is highly frequently used by Spark. Cool. Now what is old generation now, Jaswinder? Old generation is the opposite of the young generation, where young generation stores the short-lived temporary objects. Old generation stores the long-lived data sets. And to be honest, these old generations was used in RDD's time. Now we are usually focused on young generations things because now we work with data frames. We are no longer work with RDDs, but when there was RDDs, so these old generation spaces were used to cache the data, but garbage collector is very rare here. If we try to reclaim the memory from the old generation, it might consume a lot of time and it eventually will pose all the running threads. So this is the major difference between young generation and old generation. So if I talk about the latency in young generation, it might be in milliseconds, but if I am actually trying to reclaim something from old generation, which is obviously using RDDs, it might go to, let's say, 30 seconds or 15 seconds, like that. So this is the major drastical time difference, right? You can clearly see one is doing its work in milliseconds and second is doing in work it's more than 10 seconds. And obviously because it is taking a lot of time, it will potentially pose all or some of the application threats. Cool. So let's go with the definitions now, and I will not explain you these definition because I explained you, so I guess should be self-explanatory now. So you can read this definition. Stores short-lived objects created during task execution. And we had covered this. Example, map objects or temporary iteration variables or shuffle rows. Okay. And old generation stores long-lived data such as cached RDDs, persistent data frames, and long-running broadcast variables. Major garbage collectors run here when the space is nearly full, causing significant application pauses. Now let's talk about steps to optimize and fine-tune that garbage collection. So obviously it is very important to optimize and fine-tune the garbage collection, else application will go on pause and the things might start failing and it might spike the CPU usage as well. So the first thing is you need to switch to the better garbage collection algorithm. So we have two garbage collection algorithms. First is G1GC and second is GZC. Okay. So G1GC is highly recommended for multi-gigabyte heaps because it divides the memory into regions and tracks where the most garbage sits. Okay, but this thing you need to activate manually. G1GC is not by default activated. You need to activate it using the Spark configurations rule. Okay, so we have, I guess, spark.executor.extra Java option, something like that. Okay, G1GC indicates garbage first garbage collector. Let's read the definition now. Garbage first garbage collector G1GC. It is highly recommended for journal Spark applications using large heaps. Okay, because it divides the heap into regions and compacts them concurrently to avoid full garbage collection process. And yeah, you can see that we can configure this using spark.executor.extra Java options. Okay, and don't worry, you don't need to remember this. And even if you are working on something and you need to do that, you can literally go to the documentation or do chat GPT and you will get this command. This is a bash script. Basically, it's not a command, but yeah. So second one is ZGC. And GGC is the modern approach where it is very ultra fast, I can say, and it is very efficient and we usually prefer ZGC. So it is best suited for modern demanding ultra low latency pauses at cost of slight throughput overhead because It offers the high raw throughput, and it forces massive stop the world process over the large heaps. That's why it is having a slight throughput overhead. The second step to optimize it, modify your code and data formats. What modify code? What do you mean by modify code, Jaswinder? By modify, I literally don't mean that you are actually going to your Spark code and trying to modify something. Okay, this is not I meant by modify code and the data formats. So what I mean is, first I will talk about the data formats. Okay, what I mean by data formats is that always try to use the data frames and data sets. Don't use RDDs because RDDs are thing of dinosaurs time. Try to use and build the things in data frames and data sets. This will also optimize your code, and it will also help you in a better garbage collection. What happens is Spark's SQL internal tungsten execution engine, which we had just covered in the initial time, it manages the off heap memory using raw bytes. Okay, instead of any standard JVM objects, that actually completely bypasses the JVM garbage collector pressure. So that's why it is important for us to create the data frames, because the tungsten engine manages the off heap memory in the raw bytes. Okay, which bypasses the JVM GC pressure. That's the reason for using the data frames and data sets. Second, if I talk about now modify, I will say use unpersist function for unused data. So you can literally manually invoke the unpersist like you had manually invoked the persist and cache in the previous videos. So you can literally do that. And so when you manually invoke unpersist on the cached data frames, it will ensure that when the cache is no longer useful, it will totally unpersist it. So it will check if there is any dependency. If it founds anything, it will not unpersist immediately. But if it don't found anything, it will immediately unpersist it. So it's obviously kind of lazy evaluation, and this is also very helpful. So I had written down here both. Third one is also there. Third one is you can reduce the object counts. What is this object count, Jaswinder? How we can do that? Okay, by object count, I mean that you can use data structures with fewer distinct objects. Example, okay, example is an array of integers instead of any kind of primitive linked list. Okay. Third one which is coming in my mind is use the reduce object count. This means that you can use the data structure with fewer distinct objects like array. That is also one of the thing. Okay, I hadn't written it down here, but this came in my mind on the fly. Third and the final step to optimize and fine tune the garbage collection is adjusting the partitioning and the memory ratios. And I guess you already had seen how we had adjusted the partitions and how it help us. Right, so I am not going to explain you. You already know about spark.sql.shuffle.partitions that helps you to break the massive memory heavy data chunks into smaller tasks that can exactly fit easily in the young generations, right? So you already know about the partitioning part. Second one is you can even expand the young generations. You can even allocate more room to the young generation, and you can adjust the XX value. Like you can see here XX use G1 GC, and you can also mention XX as new ratio to or G1 new size percent something. Okay, but you don't need to remember this. Okay, your work will be done if you adjust the partitions. If your data is already partitioned in a very optimized way, there is no need to worry about the memory ratios. But you should know that you can even expand the young generation size. There is one more thing which I forget when I was creating this PPT, which was use the Cairo serialization. So that's why I had written down in red and green. Spark uses the Cairo serialization to swap out the standard JVM serializations. By default, it is Spark.serializer, but you need to swap this Spark.serializer by setting Spark.serializer to org.apache.spark.serializer.Cairo serializer. So what is now Cairo? Actually, Cairo is just an object which takes up significant less space, leading to fewer objects which JVM actually needs to track. So this is also one another way to optimize this. And that's all about garbage collection. Okay, and this is the most detail I had covered the garbage collection. Although you just need to remember that garbage collection is underlying that reclaims the memory. There are two kind of spaces, young generation and old generation, and the steps to optimize, if you remember it in a high level, that is more than enough. You don't need to remember this complete slide. Cool. Let's now cover the very important module of Apache Spark, which is Spark Structured Streaming. Structured streaming indicates the continuous data ingestion in the streaming order, and I guess you are already clear about how we can use the structured streaming using read stream or write stream function inside the PySpark. But this structured streaming works on top of your SQL, which is Spark SQL, and it is a very highly scalable and fault tolerant solution. By highly scalable means like you can ingest any number of data in the near real time if you want, using the Spark structured streaming, and it uses a process which is known as data stream plus unbounded table. Okay, data stream is self-explanatory that the streaming of data is coming from external sources, and unbounded table means a table which allows the data to be getting appended continuously. Okay, so there is a table. So when the data stream is coming, it is allowing that data stream to get appended directly into the table. So in this way, it stores the data, and in this way the structured streaming works. Let's now go with the definition. Spark structured streaming is a scalable fault tolerant stream processing engine built directly on the Spark SQL engine. It treats a live data stream as an unbounded table that is continuously appended. Make sense? Allowing you to write streaming queries using the exact same data frame and dataset APIs used for the batch processing. Okay, so it is nothing, just a data stream plus unbounded table which is built directly on top of your Spark SQL engine. If we talk about core concepts, there are three core concepts. First is unbounded table model, and we had just discussed this, that as the new data arrives, it is processed as new rows appended to an infinite input table. So as you can see here, the data streams are coming and data streams are immediately getting appended to the unbounded table. And this means that new data in the data stream is directly equal to new rows appended to the outbound table. So it is the whole concept of streaming. So whenever the data is coming, there is an unbounded table which is allowing the data streams to get appended to the same table, and the table size is keep on increasing. The second is unified API. You can apply the same operations which you used to apply in the batch processing in the stream data as well. That's why it is the unified API. You can apply filters, aggregations, and anything whatever you want within the same interface. Either it's a streaming or it's a batch loading. And the third one is exactly one guarantees. This means idempotency principle. So whenever you are trying to ingest data from your unbounded table to your other tables, it ensures the data which had already processed won't be getting processed. So for that, it uses the checkpoints, and we will be covering that out in a couple of minutes. But exactly one guarantees is something which is very important part and which is the very helpful in the Spark structure streaming. Next topic is stateless and stateful transformations. Stateless transformations are those transformations which actually don't require any kind of back history or any kind of intermediate data to be stored to process further data. And stateful is the opposite of stateless, where you actually require the intermediate results. Okay, what is the example of stateless and stateful, Jaswinder? Okay, let me give you a real world example of stateless and stateful. Let's say the data stream is flowing. Okay, your data is coming from external providers to your systems. Now the requirement is that you need to filter the records where the payment type is credit card. So now first stream of data came and you seen where is the credit card. So whenever you found the payment type as credit card, you are filtering the data. Actually, you are only allowing the data. Do you need any kind of intermediate results here? Even if the first batch is coming or second batch is coming or third batch is coming, actually batch is not the exact word. It should be micro batches. So let's say the first micro batch came. Do you need any kind of data from your first micro batch to process the second micro batch? No, right? Because actually we are just applying the filter. It doesn't matter it's a first micro batch or 100th micro batch. I really don't need any kind of intermediate result just to filter based on the payment type is equal to credit card. That is known as stateless. Okay, where you can literally process n number of micro batches without any need of intermediate results. Now, what is stateful example? The stateful best example is, let's say you want to aggregate the data based on the payment mode type. There is a bank name ABC and they wants to know in this financial year how much is the total credit card usage. So do you think if you just process the first micro batch and you do the group by, your answer will be accurate? No, right? You need to process all the micro batches and you need to store the result of all the micro batches so that you can keep on aggregating with the other micro batches, right? So this is the example of stateful transformation. So stateless don't need any kind of intermediate results to be stored, but stateful transformations require the intermediate results to be stored. Now let's see the definition. In Apache Spark, the primary difference is that stateless transformations process each row or micro batch independently without any historical context. Make sense? Whereas stateful transformations maintain and rely on an evolving intermediate state across multiple rows or micro batches. Now, I guess it is making sense to you. So, I even have a picture to state the same, that stateful transformation data stream is coming and there is a state tracking system which is tracking the intermediate state for the current batch, and then we are doing all the aggregations and all the stuff which we are doing. But in the stateless transformation, data stream is coming and it is literally getting used in the data frame. So this is the difference between stateless and stateful transformation. Let's also see the in-depth difference as well. So I have written a couple of features for both stateless and stateful transformation. The first feature is core concept. In stateless, the core concept is it processes each and every row or micro batch completely independently, because you literally don't need the previous or next micro batch results to process the current micro batch. For example, filter. Next is stateful. Stateful requires the intermediate state results. That's why it retains and updates the intermediate state across the batches so that it can use the intermediate result for the next batch to maintain more accuracy. Group by is the best example here. If we talk about historical data, what do you think, guys? Do you think the stateless maintains historical data? And I need answer from you because I had just explained this thing. So answer is no. Okay, because you don't need any kind of past memory or intermediate results in the stateless. But in stateful, obviously we need the results so that we can process the further micro batches. What about resource overhead? Because we are not maintaining any historical data, do you think there will be any kind of resource overhead in stateless? No, right? Because there are literally low to no resource overhead. And that's the case here. Very low memory and CPU footprint. But in the case of stateful, obviously there will be very high resource overhead because you require memory tracking and state storage in every micro batch processing. Fourth one is fault tolerance. In the stateless, fault tolerance is very simple because actually you are just doing independent work, and even if a single micro batch fails, you don't need to worry about the previous or next micro batch. You can literally restart the current micro batch. But in stateful, fault tolerance is very complex and it requires a state to checkpoints. Now, Jaswinder, can we discuss the checkpoints? Yes, guys, this is the very time that we should touch base on the checkpoint. But before that, I want you to be very clear on the Spark structured streaming and stateful and stateless transformations, because these will be very helpful whenever you are working with the Spark structured streaming. And by the way, these stateless and stateful transformations are not something which a user manage. You obviously will mention the conditions like filters, aggregations that will decide the stateless and stateful transformation. And this is something which Spark decides internally based on the code which you had written. So if the code is grouped by, obviously Spark will understand the code and it will go that, okay, he's trying to group by, I need to use the stateful transformation. There is no syntax that you need to configure the stateless and stateful transformation. It will purely be depending on your code base. Now let's jump into the checkpoints directory. So checkpoint directories are kind of a checkpoint location which is useful to store the state of the streaming queries. Okay, so let's say you had processed the first batch. So what will happen is it will create a checkpoint that first batch is processed and these are the results. So it is actually storing the state of your queries so that it can reuse the queries in further micro batches. Okay, so this is very high level of checkpoint directly. And whenever you configure the checkpoint directly, and yes, checkpoint directory is something which you need to configure because you need to mention the location where you want to store the checkpoint directory results. So this is how the checkpoint directory looks like. Inside the checkpoint directory, whenever you configure it with the name, let's say checkpoint directory, or you can give any name, let's say just in the directory, that's fine. But inside the directory, you will be having 4 folders. Metadata folder is self-explanatory that it tracks all the metadata. Then we have offset folder. Then we have sources folder. And then we have commits folder. Okay, I will help you understand what is commits folder, offset folder, and source folder. But let me first read the definition of checkpoint directly for you. Checkpoint directory is a designated fault-tolerant storage location like HDFS or S3 used to store the state of streaming queries. Make sense? It is useful to store the state of streaming queries, truncate long data lineage for data frames, and guarantee the fault tolerance. I hope this is very much clear to you now. So now let's discuss about commits, offset, and state and sources. So offset tracks the read offset batch by batch. So it keeps the track of all the read offsets either from Kafka or from any streaming API batch by batch. Commit is self-explanatory. It keeps a record of batches that have been successfully completed. And by batch, I don't mean batch. I mean micro batch. And the sources and state, it maintains the stateful information and specific source snapshots if required. Okay, so this is how checkpoint directory works. And if you have to configure the checkpoint directory, you need to use the command dot option, and then you need to mention checkpoint location, and then you need to mention the path where you need to store the checkpoint directory. And whenever you will be running this write stream command using the checkpoint location, you will be getting a folder created checkpoint directory. Inside that, you will be having 4 subfolders, like you can see commits, offset, sources, and metadata. This is how checkpoint directory works, and it is very helpful in storing the intermediate results. Now, Jaswinder, there is one question in our mind. You told that checkpoint directory will be keep on storing the information, right? Yes, I told you. But Jaswinder, isn't it there will be a state in future that if the checkpoint directory keeps on storing the information, it might run out of memory at some state? Yes, guys, you are definitely correct. If we obviously keep on storing the information and we are not dropping the information which is not required, obviously at some point of time checkpoint directory will create chaos and my Spark system will be starting throwing out of memory errors. That is true. But Jaswinder, what is the solution for that? Should we manually go to the folders and delete the files? Or should we just totally delete the checkpoint directory when we are done? Actually, guys, you don't need to do any of the both. There is a concept which was introduced by Apache Spark which handles this thing automatically for you, which is known as watermarks. A watermarking is a mechanism that tells the engine how long it should wait for late arriving data. It tracks event time and allows Spark to drop excessively old events and safely clean up the internal state memory to prevent out of memory errors. This engine will ensure that it will drop the data which is no longer in use. So watermarks are very helpful in preventing out of memory errors. So how it works is there is a watermark threshold that because you are actually working on the streaming data. So you will be having a maximum event time, that this is the maximum time that my streaming data will accept the data. Once the time is reached, all the delayed threshold watermark won't allow all the delayed request. Okay. So what happens? Then the watermark advances the end of the time window and Sparks drops all the window states from the memory. In this way, it prevents the out of memory errors by cleaning up the state once my streaming data is successfully ingested. And third is dropping lead data. Any incoming data with the timestamp older than the current watermark is automatically discarded. The third point will make more sense when we are discussing about window operations in Spark. But as of now, you should know that there is a concept called watermarks, which is very helpful in dropping the excessively old data, and this is kind of a cleanup drive. This will ensure that your Spark will never go out of memory because of these checkpoint directories. Cool. The third point, as of now, please take a note. When I will be explaining you window functions in a couple of minutes, then it will definitely be making sense that what I mean by dropping late data. But as of now, it is important that you should be very clear with the formula and the state cleanup thing. The third point, you will automatically be getting very clarity whenever I was explaining you the window functions like tumbling window functions, sliding functions, and default functions. So be with me. But as of now, take a note of this third point. So this is the syntax of defining the watermark. You need to use your data frame name dot with watermark. Then you need to mention the type of watermark, which is event timestamp. And then you need to mention the threshold, which is in this case 10 minutes. You can increase or decrease that threshold as per your requirement. And after this threshold time, the watermarks will start working on dropping the data, and it will also stop accepting the late arrival data. Cool. Now there is another topic which is triggers, and it is also the important part of Spark structure streaming. So triggers define exactly when your stream data is processed, whether it's execute continuously at a fixed interval or a single batch. It's like just a simple trigger where you mention the trigger type. So we have a couple of trigger types in Spark. So whenever you mention the trigger in your Spark query, it will trigger the streaming. It will work on the streaming part when the trigger is fulfilled. Let's say the micro batches are coming, but let's say the trigger is saying that I won't process the micro batch till this specific state. Then these micro batches will be there in the unbounded table. It won't be getting processed unless the trigger condition is fulfilled. Okay. By default, you do not explicitly configure a trigger because there is already the default or unspecified trigger which Sparks run on behalf of you, which automatically processes all the new coming micro batches as soon as the previous micro batch processing is finishes. So this is the default behavior. Usually we don't mention the triggers much, but there might be the scenarios where you be requiring the triggers to be mentioned. So that's why I am going to explain you the triggers available in the Spark, and it will help you whenever you are working with the actual streaming data based on the requirement. It should not be like that you don't know trigger and you are just going with a default trigger, because there are other triggers which are useful, which are very handy when you are actually working with your streaming data. So I had divided the trigger into trigger type, syntax, example, latency profile, and what this trigger is bestly used for. The first trigger is unspecified, which is the default, and there is no syntax example because it is a default behavior. You don't need to mention explicitly anything out here. The latency for this is 3 to 5 seconds. Why? Because it needs to process the previous micro batch and then only it will move to the new micro batch. And it is best for journal purpose because this is a default behavior. Now, if you don't want the default behavior, all the other trigger types will come into picture. First one is processing time. Syntax example is dot trigger. Processing time is equal to 10 seconds, let's say. So what will happen is it will create a custom latency based on the processing time which you had mentioned. In this case, it will be having a latency of 10 seconds. If you mention, let's say 1 minute, it will be going for a 1 minute latency. So this is the custom trigger which you can use if the requirement is that. It is best used for performance based balanced cloud computing, and it is cost effective. You are literally waiting for a specific amount of time to process the next batch instead of checking out every 3 to 5 seconds. Next one is available now. Here also the syntax will be the dot trigger, then available now is equal to true. And it is the batch like process which is very cost efficient. It is a scheduled process and it is best used for incremental batch jobs. And next one is continuous. Continuous is the most expensive one. And here you mention the trigger is continuous is equal to 1 second. And the latency period might be up to 1 millisecond. So as the latency profile is very low, this obviously means it will be very high cost and it is highly experimental. And this is how you can mention the trigger whenever you are creating the stream inside your Databricks. You can say df.writestream.format and you mention the format. Then you can mention dot trigger. Then you need to mention the syntax. Then you need to mention the trigger type with the latency. Then you need to say dot start and it will immediately start consuming streaming based on the trigger types. This is again a very, very important concept. Whenever you're working with the actual streaming, you should be aware about these trigger types, because if the requirement is batch type and you are not mentioning the trigger type, you are actually wasting the compute. You are actually increasing the cost of your company. So you should be very aware that which trigger type suits my need. And that's why you should remember these 4 trigger types for surely, and please take notes for these things because this is very important. Being a good Spark developer, it's your responsibility to ensure the effective costing. Let's now discuss about Windows operation in streaming. Whenever you are going for a streaming, you might get the word like Windows operation or window function. So whenever you are listening the name window function, this will only mean the window operations. Okay, so what are window operations? Window operations let you group and aggregate your streaming data over the time intervals using the event time embedded in your data. So basically there is an event time, you will mention the Windows time and the trigger time, and based on that it will group and aggregate the streaming data and provide you the output. Okay, so let's discuss about the tumbling window, which is the very first kind of window operation, and 90% of the time you will be using this window function. Let's discuss the tumbling window with an example. Let's say you have a window of 10 minutes and then you have a tumbling window of 5 minutes. Okay. And let's say we start at 4 a.m. First window is of 4 a.m. to 4:10 a.m. The second window is from 4:10 to 4:20 a.m. The third window is from 4:20 to 4:30 a.m. And then the fourth window will be of 4:30 to 4:40 a.m. Right? This is the window size. But the tumbling window trigger is off at every 5 minutes. So the first tumbling window trigger will be at 4:05, the second will be at 4:10, the third will be at 4:15, 4:20, 4:25, and so on. So this is our tumbling window. So let's say the data came at 4:02. Okay, the data is Russia and UK. It came at 4:02. Now what will happen at 4:05? It will create the aggregation for the data came. As of now, the aggregation will be UK with 1 and Russia with 1. Now, let's say at 4:08, new record came, let's say UK. At 4:10, it will again aggregate my data. Okay, because new UK will came and the window is stopping at 4:10. So whatever is there between the window, it will aggregate and give you the final output. The final output at 4:10 will be UK 2, Russia 1. 4:05 is not the final output. It is the intermediate result. The window finishes at 4:10. The final output of window 1 is UK 2, Russia 1. Now the window 2 starts at 4:10 to 4:20. Now let's say the new record came at 4:12 of UK and Spain. Now what will happen at 4:15? If your answer is that it will aggregate the results of 4:10 and 4:12, you are wrong. Answer will not be UK 3, Russia 1 and Spain 1, because the 4:15 is not the window. Window is 4:10 and 4:20. So the output will only be given at 4:20. So what this means, Jaswinder? This means that the output at 4:10, this output will remain as it is at 4:15. And this one create a new group. As you can see, UK1 and Spain1. So this is how tumbling window work. Whenever we have a tumbling window session, it won't generate the final output. The final output will only be generated when the window time is getting finished. This is my final output of the first window. This is again my intermediate result. But now let's say I am going into 420 with the same data. Now here it will go UK 3 and Russia 1. Let me write it down. Yeah, like this. So now at this window, window 2 is getting finished. This is my window 2, right? So it is getting finished at 420. In 420, it will aggregate my streaming data and it will give me the result as UK 3, Russia 1 and Spain 1. This is how tumbling window works. Okay. It is a fixed size. As you can see, window 1 is also fixed size of 10 minutes. Window 2 is also 10 minutes. Window 3 is also 10 minutes. It is a fixed size, non-overlapping intervals. Okay. So this is what I had written here. These are fixed size, non-overlapping, contiguous time intervals. Every incoming event belongs to the exactly one window. Make sense? This is how tumbling window works. I hope this is clear. Let's now discuss about sliding window operation. For that also we will take one more example, and it is sliding window operation. So this means the windows will be overlapping each other. So now we can say that sliding windows are overlapping windows with the fixed size. Okay. And in this case with the fixed time, you can say. So now again, let's say you are having a time of 4:10 a.m., 4 a.m., 4:10 a.m., 4:20 a.m. and the window size again is 10 minutes and the sliding window is of every 5 minutes. Okay, as you can see clearly. So now what again, let's say the data came. Okay, at 4:05, obviously it is in the first window, it will group by and it will give me the result as UK1, Russia 1. Now at 4:08, new record came, and again this is the part of window 1, but this is now also overlapping with the window 2. So what will be the output at 4:10? Any guesses? If your answer is UK2 Russia 1 only, then you are partially correct. Because actually now window 2 is overlapping with window 1. So the output will be UK2 Russia 1 plus this UK1 as well, because this is coming from my second window, right? This is the part of second window. So this will obviously come as the second output of the group by. Similarly, let's move. Let's say at 4:12 you got UK and Spain. Now the window 2 is finishing here, but window 3 is overlapping. So the output will be UK2 Russia 1, which is same here. And then this UK1 will be concatenated with this one, which will become UK2 Spain 1, which will be the output for my window 2. And now in window 3, we have UK and Spain alone. So this will also be giving a new group aggregation. This is how sliding window operation works. Usually we don't use it because it is very complex to maintain, but you should know that what's the sliding window operation. Okay, so if I talk about the definitions, sliding windows are fixed size but overlapping window based on the sliding intervals. In this case, the sliding interval is 5 minutes, so it is overlapping by 5 minutes. Cool. If I talk about the use case example, it is very useful for computing rolling statistics or trends monitoring, such as tracking a 5-minute moving average of the stock price over the last 5 minutes, last hour. Make sense? This is all about sliding window. By giving you the example, actually, it makes very easy for me to explain the concept. So I hope you are really enjoying this one as well. Next window is session window, and it is self-explanatory that it will expire once the session is over. So session windows have a dynamic size that expands or closes based on the period of user activity and inactivity. So when there is an activity, session window will keep on going, and once the session expires, it will be considering the next stream in the new window. Okay, so how it works is, instead of fixed time, it uses the gap duration as we just discussed. A window opens when the event arrives and keep expanding as long as the new events keep on arriving unless the session is active. Okay. And once there are no events within the gap and the session expires, the window immediately closes. And then when the new event come, it will be completely in the new session. This is how session window works. And the example use case is it is useful in analyzing user behaviors patterns, like tracking an e-commerce checkout session that ends after 15 minutes of inactivity. Okay, so this is pretty much self-explanatory that the session window will be active until the session is active. And once the session is expired, the new window will be opening when the new event came. Until the new event is not coming, there is nothing happening. Everything is on the hold. This is how session window works. Cool. So now it's time to discuss about the Spark Connect, which is also very important and decoupled architecture. So earlier what used to happen is, if I talk about the time which was before Apache Spark 3.4, everything was very tightly coupled. So whenever you need to submit your codes, you need to go to the driver, and that was very tightly coupled. In a nutshell, everything was very much tightly coupled, which was not a good thing, right? So that's where Spark introduced a new concept which they call Spark Connect. It is the decoupled architecture which allows you to connect with your Spark from your local IDEs or from any external tools like Jupyter Notebooks, VS Code. Okay, so let me give you the example how the Spark Connect works. So let's say this is you, or it's me. Okay, anything is fine. So you are using either Jupyter Notebook or VS Code, and you are having a code base. Earlier you will be submitting these code directly to the driver, but now what happens is, whenever you are working with your external IDEs, you create the code, and that code gets converted into an unresolved logical plan. So once the plan is ready, it stays in your environment and it don't go directly to your Spark driver or your Spark servers. Okay, it is sitting with you. So now once you use the Spark Connect, and you can use Spark Connect with gRPC. What is this gRPC, Jaswinder? It is Google Remote Procedure Call. It is a very modern and a high performance open source framework, okay, which primarily used in Spark Connect. It allows you to communicate with any kind of external clients like VS Code or Jupyter or any local client, and it will also responsible to help you in executing the workloads on your remote Spark cluster. Okay, so gRPC is a bridge. If I conclude this, gRPC is a bridge. Okay, the full form is Google Remote Procedure Call. Okay, your local system will be using gRPC to have a Spark Connect, and it will be using the Spark Connect to submit your workloads to your Spark server. This is all about Spark Connect. So if I read the definition, Spark Connect is a decoupled client server architecture introduced in Apache Spark 3.4 that allows remote connectivity to a Spark cluster. Make sense? It separates the client application process from the Spark driver. This design lets developer write and run the Spark code from anywhere using a lightweight client like VS Code or Jupyter or IntelliJ IDEA. This approach completely removes the requirement to run code directly inside a massive monolithic JVM driver process. I guess it is very clear to you. That's the catch, guys. Whenever you are trying to explain someone with a problem statement and try to explain them with a diagram, it will make more sense than just going and reading the definitions, right? So this is all about Spark Connect. It is a decoupled architecture which helps you to use your remote connectivity, and it can help you to directly connect with Spark driver, which is on your remote instance, using Spark Connect gRPC framework. Cool. That's all, guys. That's all about Spark Connect. Let's now discuss about few delta optimization technique. And first technique is how we can use optimize on the small files. Okay, let's say you have couple of Parquet files for, let's say, table name is customers table. So obviously in your cloud provider you will be having a lot of Parquet files, and inside delta log you will be having couple of metadata files. Because there are a lot of files, and if you have to backtrack, it might take a little bit of time, right? But if you just mention the function optimize, then you mention the table name, What it will do is it will combine couple of files and create a big file. So in this way, you can easily go to less number of files instead of pinging multiple Parquet files. So this way, it optimizes your performance because you are having less number of files compared to earlier where you was having a lot of files to go through. Okay, so this is a very helpful. All you need to do is whenever you want to optimize your tables, just mention optimize and then table names and you are good to go. If we go with the definition, it minimizes the disk input output, it reduces the data serialization cost, and it also eliminates the unnecessary network shuffles. Why? Because you are having a larger Parquet files instead of having the general small Parquet files. And there is one another relevant topic to optimize, which is z-ordering. What z-ordering does is it will sort your Parquet files, okay, and it will sort your Parquet file in the ascending order. Let's say here the files are present from 1 to, let's say, 18. And in your next file, the files are present from, let's say, the minimum ID is, let's say, 25 and the maximum ID is, let's say, 38. In this way, it had sorted the partition. So let's say you just want to find the record where ID is equal to 15. So it will immediately prune all the other partitions and it will strictly go to that specific partition and get your data. So this is how z-ordering work. It is actually a data layout optimization technique because you are laying out your data in the order in all the available files. This method drastically accelerates read performance for all the Delta Lake tables by maximizing the efficiency of data skipping because you are actually skipping the data as you are applying the sorting algorithms. Cool. So this is another important concept which is z-ordering. Let's now read the definition. Z-ordering is a data layout optimization technique used in Apache Spark to cluster multi-dimensional data physically on a storage. So this is a data layout optimization technique that physically co-locates the related information within the same set of files, if I have to simplify it. So as you can see, it had co-located the IDs from 1 to 18 in the first Parquet file. So co-locate, I means sorting the file. Okay. So in this way, we are having the minimum and the maximum for all the Parquet files, and where this information is stored, this is again stored inside your JSON file, which is available in your Delta log. So in this way, it optimizes your performance. And this is again very important Delta optimization technique. Third optimization technique is using the cluster by. And this is something which is recommended by Databricks to use in all the tables. So let's say you are having a couple of Parquet files and you apply cluster by ID. So what will happen? It will try to map the specific IDs into a specific set. Okay. So in this way, let's say you are doing a filter or you are doing the aggregation on a specific set of IDs, it will directly go to that partition and get your work done. Okay. So if I go to Spark documentation, and here if you read, we call clustering in Databricks as liquid clustering. And if you read here, liquid clustering is a data layout optimization technique that replaces the partitioning and z-order. Cool. It simplifies the table management and optimizes the query performance by automatically organizing your data based on the clustering keys, which you just mentioned, right? So let's say you have having a very big table and you are not applying the clustering keys. So this means your table will not be in an optimal way. And if you try to query the things, if you try to do aggregation, that won't be much optimal. But if you use the cluster by and you specify a couple of columns which have very high cardinality, it will be very helpful in optimization. So let's go down to understand when to use liquid clustering. So Databricks recommend liquid clustering for all the tables, and we had just discussed that, including the streaming tables and materialized view. These are the scenarios which actually get benefits from clustering. The first is the queries that filter on high cardinality columns, which we just discussed, right? The second is tables with very heavy skewness. Okay, that is also valid. And then when you have fast growing tables that require maintenance and tuning efforts. And the fourth one is tables with concurrent write requirements. Cool. And fifth one is tables with varied or changing access patterns. And then the last one recommendation is tables where a typical partition key returns result from too many or too few partitions. So all these scenarios are the scenarios which actually get benefited by clustering keys. And by default, Databricks recommend you to use clustering in all the newly created tables. So how to enable clustering key? It's very easy. Whenever you are creating a table, just mention cluster by and then the column names. And it might be 1 column, 2 column or 10 column. It's use case to use case. Then if you already have a table and you want to apply the clustering on the existing table, all you need to do is you just need to do alter, and then you will need to mention the table name, and then you need to mention cluster by and the cluster by columns. Okay. And then yeah, that's pretty much about clustering. Okay, so I will attach this document URL in the description so that you can refer how the clustering works, and you can even remove the clustering, as you can see. So yeah, that's pretty much about clustering, guys. Now there is a very interesting and controversial question which many of the people usually ask is that if we have PySpark, why some companies uses Pandas API? Yeah, that's a really good question. If you ask me this question, that Jaswinder, in the actual projects, what should we use? Or even what you use? So I will say that 99.99% of the time I uses PySpark. Okay, because I love PySpark. And this is not only me. PySpark have a lot of flexibility, and it actually makes your work very, very easy. But Jaswinder, where is this 0.01% where you don't use PySpark then? Yeah. So this is where 0.01% I use Pandas. And the case of using Pandas is whenever I have to create the UDFs, user defined functions, some functions which are not provided by PySpark inbuilt, and I need to create the function. Let's say you had created the function for, let's say, calculating the square root. So you will define a function, and then you will say return x into x, right? So this is some custom function. So whenever there is a need of custom function, I use Pandas to get my work done. And once my work is done, then I convert that code back to PySpark code. Okay, and this is the only use case where I personally use Pandas. I know some companies are literally using Pandas, but the number of those companies are very less. And I don't personally see a much benefit in purely using Pandas because Pandas is not that much mature as PySpark is. Okay, but yeah, to answer your question, I will recommend you to use PySpark only. Only go to Pandas when you have to create UDFs, because UDFs are much, much faster with Pandas comparing to PySpark. Okay, Jaswinder, makes sense. Now, how Pandas UDF are faster than PySpark? Can you please elaborate? Sure, guys, this is why I am here. So let me give you one example, and let's start with very general example that what happens when you write the PySpark code. So this is you had written the code and you had ran spark.submit and you had submit your code to Apache Spark. What Spark will do, it will give the code to the driver node, and then driver node will convert your Python code into Java using Py4j, right? This is what we had discussed initially as well, right? So your code is converted into Java using Py4j, and then the driver node will call the worker nodes and will hand over the plans to execute the codes. This is the very initial scenario where you don't have any kind of UDFs. Okay, you are just doing transformations, you are creating your data frames, and everybody is happy. Okay, there is no UDFs in the picture. Okay, this is the normal scenario, right? You understand, right? Cool. So now we have the scenario where you are using PySpark, but you require to create a custom Python UDF as well. Let's say there was no function in PySpark supported for the requirement which you are having. So obviously you need to write a custom function for that, and you had created a UDF in Python for that. Okay. So now again you had submitted your code with that UDF as well to the Spark. Spark will give your code to your driver. The driver will again convert your Python code to Java using Py4j. Till here everything is as the normal scenario. Now, when driver node will hand over the plan to worker node will also be giving your Python UDF to the JVM. Okay. And then what will happen? It will go for serialization and deserialization as per the UDF. So what is serialization and deserialization? I hope you know, but I know some of my audience don't know. So don't worry. Your bro is here. So serialization is nothing. It's just a process of converting a Python object into a format that can be easily saved to a file or let's say transmitted over a network. Okay, this is known as serialization. And what is deserialization? Deserialization is the reverse, where the stored bytes or streams is converted back into the active Python object. So one is converting the Python object into a format and second is converting the format back to the Python object. Cool. So now this happens because serialization and deserialization is happening row by row because you are obviously using the Python UDF. So everything will be happening row by row. It is doing serialization, deserialization and all those things, and then it going back to the worker node, and that's why it is consuming a lot of time, and that's why it is not optimized to use Python UDF here. Okay, so now you understood the problem with Python UDF, and this is not something, guys, that we always using Pandas UDF because of this thing. It impacts the performance, but there is no very big impact even that you can say that impact is very huge, but it is the best practice that if you are actually working with UDFs, always try to use Pandas UDF. Okay, and that's why I mentioned that 0.01% case is the UDF case, because I really write UDF. PySpark library is very vast that you literally don't need to even go to Pandas library, but there might be some cases even I encountered 2 3 cases, and even I asked this question in the interview to the candidates. Okay, and they was not able to answer it clearly that why should be they going with the Pandas UDF instead of Python. So that's why it is very important for you to understand the process. So the catch here is that things are serializing and then deserializing, and it is taking time. Now let's see the PySpark plus Pandas UDF, how it is optimized. Again, this time instead of writing Python UDF, you had written the UDF using Pandas. You had submitted your code to Apache Spark. Apache Spark gone to driver. Driver converted your Python code into Java using Py4j. Then driver gone to worker nodes with the plan. Then now worker node will again have a Python which will be converting your code to JVM. Okay, but this time it will be using Apache Arrow to convert your code from Python to JVM. That's why it is fast. Now, what is Apache Arrow, Jaswinder? You just said that's why it is fast. What do you mean by this? Okay. So Apache Arrow is a columnar memory format, which is open source, obviously, and it is designed in a way that it represents the data in memory and move across all the different data processing applications. Okay. So it is a columnar memory format. It organizes your structured table-like databases by columns instead of rows. Whereas, let me grab my pen. Whereas in this PySpark plus Pandas UDF, you are doing serialization and serialization row by row. Let me write it here, row by row. Here, because of Apache Arrow, the things are happening in batches. Instead of row by row, it is going batch by batch. And because of columnar memory format, it is even more fast because of whole data set is considered by the column, not by the row. So it actually fast pace your processing powers. So this is the whole idea of using UDFs with Pandas. I know you can learn Pandas. There are a lot of tutorials available on Pandas. I am not going to teach Pandas, and that's not the part of this tutorial. We will cover that Pandas in some other time, but you should know that whenever you are working with Apache Spark, try using Pandas UDF. All the other places, I am happily saying you that go with PySpark. Cool. But yeah, obviously, if your company is saying that use Pandas only, then yeah, Pandas. But if that's you have the flexibility, most of the cases you will be having the flexibility. So obviously, use PySpark as much as you can. Only go for UDF when it is literally required, and that to use Pandas UDF. Okay. So now you understood the difference between PySpark plus Python UDF and PySpark plus Pandas UDF. Let me again repeat it. So the problem in PySpark plus Python UDF is heavy serialization. Second problem is row by row execution. And third, because it is going row by row execution, let's say your table is having 1 million records. So it will be iterating millions of times, isn't it? Right. The solution in Pandas UDF is it transforms the whole table into batches and it will convert your column to arrow format. Okay. And then if Python function calls it, it will have to call fewer times instead of calling row by row, which will go million times. So that's all about how we should use PySpark and where you should be thinking about Pandas. Okay. And I know this is little bit controversial, but I am telling you guys, this is from my personal experience that it actually fast the things, and there is no harm in using Python UDF, to be honest, but I personally recommend you to use PySpark as much as you can. And if you have a requirement to use UDF, please try to use Pandas UDFs. Okay, that's all from this topic. Let's now discuss about the types of Pandas UDF. Because we had discussed a lot about UDFs, so we should also be knowing about the types of UDFs which we can use and implement within the PySpark codes. And yes, you can literally create your UDFs in the Pandas and you can just use the same Pandas UDF in the PySpark directly. You don't need to do anything. That's why I am emphasizing you guys that when it's come to UDF, please create UDF in Pandas because of the PyArrow advantage which we are having in the Pandas. Cool. So I won't go into the types of Pandas UDF directly. As always, I will go to my Google Colab because my Databricks now is community edition, and my previous Databricks where I was having my own cluster, that was a 14 days trial and that is expired. Community edition, I cannot create anything Pandas. I need my own cluster to work with Pandas. So that's where the workaround is, to go to Google Colab and understand the Pandas. So now I am into my Google Colab. Here, obviously, I don't have any Spark engine. I don't have any Python libraries or anything. I need to install my PySpark and PyArrow. So for that, I will say pip install and then I will say -q. Then I will say PySpark. And next I want to install is PyArrow. Cool. Let me run Control plus enter, and till the time it is running, I will create a next text. And this text is to initialize Spark. I know in Databricks we don't need to initialize Spark, but now we are not in Databricks. So actually it's good, I guess. You can actually learn now that how you can actually initialize Spark when you are not in the Spark environment, right? So yeah, that's also a good learning. So shift plus enter, and now this had ran. So in order to initialize Spark, I need to import some Python libraries, obviously, right? And I will also import Pandas as well. I will say import Pandas as PD. And then I will import some PySpark libraries. I will say PySpark dot SQL import Spark session. Obviously, in Databricks, you don't need to do all those things. And I guess it's good that my Databricks account now is community because I hadn't shown you how you can actually create the Spark session when you are not in Databricks. When Databricks was not in the picture, then how things work, right? So it's also important. Yeah, everything happens for good reasons and it's like a blessings in disguise. Definitely will love to. I will import star from this one as well. And then is one more, which is PySpark.SQL.types. I will also import that as well. SQL.types import star. Yeah, I guess that's enough. If we need anything, we will obviously install that in the next cells. But as of now, I am good. So then in order to initialize the Spark, we write Spark is equal to Spark session dot builder dot master. Okay. And then in master, we mention local and I will also mention star. This is the template. Okay. and then you mention dot app name, and then let's give some app name, let's say UDFs demo, and then I will say dot get or create. This is how we used to initialize the Spark when Databricks was not in the boom. Okay, so I will also give this a comment, initializing Spark. So we had successfully initialized the Spark. Now I will also need to create some data. I had already copy pasted the data so that we don't waste much time in creating the data. So this is it. Let me run this, and hopefully this should not be giving me any error, because even I am running this after years. Okay. Since I moved to Databricks, I totally skipped all those things. Obviously, right? So anyway, I guess it worked. Yeah, it worked. So it reached till this point. This means it worked. Perfect. Perfect. So this is how we initialize the Spark. Yes. So now let's come back to the topic. What is the topic? Topic is types of Pandas UDFs. Correct. The first type of Pandas UDF is series to series. Okay. This is the first type of Pandas UDF. In PySpark, if you create the UDFs, obviously you already know that it will be iterating row by row. But in Pandas UDF, you can see the first type itself is series to series. This means you can literally pass a batch of data and it will immediately give you the output in the batch. So can you think how fast it will be? It transforms one or more input columns directly and returns a single Pandas series of the same length as soon as it can. This is the beauty of Pandas UDF. Now you can literally see that why I was emphasizing a lot on using Pandas UDF instead of PySpark UDF. In order to create the Pandas UDF, we need to mention a decorator which is named as pandas underscore UDF, and we need to mention the return type. Let's say I want to return double type. Okay. And then I will create a function. Let's say I want to just do x multiply by y or something. Okay. So let's create a function. Let's say demo value. Okay. And then I will mention my values. Here values means my literally complete column. Okay. So for that, I will just say anything x a b c. Let me give my name so that you don't get confused. I will say Jess, and I will say p dot pd dot series. This is how we mention and pass the variable. Then let's say second is again just second is, let's say Amit. Okay, anything, then pd dot series. So now we had passed the total series to my function. Okay. And obviously the output is also I want in series. Yes. So let's return something. Let's say return Jazz into Amit, if that makes sense to you. Cool. So now this is how I had defined the function. Because this is a vectorized pandas operation, it will run very fast, right? Because you are literally having a complete series passing as a argument, not a row by row it is going. Make sense? Let's apply this to the data frame. I will say df dot scaled is equal to df dot with column. And you know what I am doing. I am using this PySpark now. So let's say result is scaled result. And then I will mention my function, which is demo value. Just copy and paste it here. And then I will mention the columns on which I need to pass. So first I will pass this value x, and second I will pass this value y. That's it. So I will say column value underscore x, and then I will say column value underscore y. Now I will just say df scale dot show. Can you see how easy it is to integrate your pandas UDF with the PySpark? I literally hadn't done anything. I just literally created a function and I directly called the function in my PySpark code. This is the beauty of using pandas UDF. So this is how series to series UDF works. Obviously, it is very exciting, right? You are fast pacing the processing using arrow functions. Second type of Pandas UDF is iterator of series to iterator of series. In series, we are passing the column in the batches and the result are actually super fast. Why I need to do the iterator of series and what exactly is the iterator of series? Is this means that I am iterating on the same series again and again? No, no. This means that you are creating a list, because in series to series, even though you are passing a complete column, this complete column exists in the Spark in partitions, or you can say batches. So the series to series in the background again running the batches of your data. Okay, it does not run the complete data set. It runs the batches of the data one by one. In order to overcome this, we got iterator of series. So what happens is, let's say you have a table with 100 records and the partition of that table is 10, let's say. So series to series will go 10 times, but iterator of series will store these 10 partition as a list. Okay. And when you pass the iterator of series to the function, it will only get processed one time till the time you are not having a for loop. Jaswinder, we are very confused. This is not clear to us. Don't worry. Now it will be more clear to you. Let me create it. Okay, then it will be very good. So in order to do that, I need my iterator. So iterator is present in my typing library. So from typing, I will import iterator if I am not wrong. Then again, I will just mention pandas underscore UDF and the return type, which is my double type. Yeah. And then I will again create a function. Let's say multiply. Multiply. And then here I will pass the iterator. I will just give my name so that you can understand that this is just a function. I know you know that, but still some people might get confused, so which I don't want. So I had passed the iterator. Then obviously I need to return the iterator. It's not I need, I have to. Okay. So then I will say pd dot series. Cool. Yes. Iterator. Iterator, Jaswinder, iterator. Now this looks good. So what is now, let's say I have a couple of logics. Okay, let's say x is equal to 1.5. Or let's say print, hello, Jaswinder, how you doing? Something, okay. I had mentioned, let's say couple of more things. Okay, so for that, I will just copy paste this one. Let's say there are a couple of parameters which you are doing, couple of things which you are doing. I don't care. You mention all your code. Now you mentioned the for loop to iterate on this iterator. So what will happen? These codes which you had written before the iterator, all these codes will run only once. But when it goes to the iterator, then only the list will go one by one. Okay. So from here, you can say that it is becoming the series to series. Before that, it is iterator to iterator. Let me give that as well. Iterator to iterator. This is the difference. Okay. Even though this series to series is not actually series to series, it's kind of list of series to series. So that's where this iterator is coming. So now why this is giving error? Okay. I had mentioned jazz. So I need to change this to jazz. Perfect. Now it is not giving me the error. So now I will say yield s multiply by, let's say, x. And yeah, you can use return also here. It's same. But nowadays developers started using yield. So that's where I had also used yield here. So anything is fine. Now again, I will create a data frame. Let's say df multiply. And then I will say df dot with column. And I will mention the column name multiply, and then I will just copy paste my function. You can see, right? It's pretty easy to work with these. It's almost like PySpark. Then I will mention my column. Let's say here a column will be value X. So if I say df multi dot show, it should work. Let me see if this works or not. Hopefully this should work because I'm not able to see any errors. Yes, it had gave me the output and it had multiplied my value X with 1.5 and it have gave me the answer. This is how iterator of series to iterator of series works. And the third type is series to scalar. Let me give that heading as well. Series to scalar. Scalar means a single value as an output, and this scalar is valid on a specific group. Or you can say it's like a group by. Without group by, you cannot have a scalar. Okay, so let's implement that as well. So I will say pandas underscore UDF, and then I will again return as double type. Perfect. And then I will create a function. Let's say it's custom function. And then here I will say X, anything, even my name. Then I will say pd dot series. And then Y, I will say pd dot series. Simple. And then the output here I want is scalar value. So I cannot say I need iterator or I need series. Here I need an output as a scalar value. This means I need to mention some data type. So data type here will be float. I need my answer as a float data type. Okay. So then I will say return and let's say float of, I will just typecast it. And let's say I will calculate the mean. I will say x dot mean. Let's subtract, yeah, y dot mean. Perfect. Yeah, this should work. Yes. So now I will create a data frame, let's say aggregation data frame, and then I will say df dot group by, because when you are converting the series to scalar, group by is non-negotiable. Okay. And group by on group ID. I will just copy paste group by this group ID. And then I need to say dot aggregation. Aggregation on what? Aggregation using this function. I will pass this function and then I will pass the two arguments. First argument will be value X and second argument will be value Y. So I will say column of value underscore X and then I will say column of value underscore Y. Okay. And then I will just rename this, let's say demo column. Perfect. And yeah, let's close this bracket also. Let me run df.aggregator.show. Hopefully, this should also work. See, guys, this is what I mean. Series to scalar will only work if you are applying the series to scalar on a group of entities. Cool. This is all about types of UDFs. Now I will go back to my PPT and now I will just read the definition and the use cases. Here I am back on my PPT where I started. The first is series to series, which we had seen. What is series to series? It transforms one or more input columns and returns a single panda series. Makes sense? And the use case is it can be used for element-wise math, string manipulations, or applying any custom ML models. Okay. Second is iterator of series to iterator of series. And you can read the definition. It takes an iterator and returns an iterator. In the Panda series, the use case is it is perfect when you need to load a heavy machine learning model or a large lookup configuration once per data partition. Make sense? That's the beauty of iterator because you have some things in your function which you only want to run once. Okay, but if you do the same thing in series to series, you are actually running the same model, same function multiple times, which will impact your tokens or you can say your cost, right? It is unnecessary cost. Why you will waste your tokens or cost running the single function multiple times when you are knowing that you can just run it a one time and store it somewhere. If you are actually working on machine learning models, you know the pain. This is the biggest pain when if you don't have the iterator of series functionality and you are actually using the series to series, you are calling your expensive model n number of times. But in iterator of series, you are calling your expensive model only one time, which will eventually cut the cost. Now I guess you are very, very clear where to use series to series and where to use iterator of series to iterator of series. And the third one is series to scalar. It accepts one or more Panda series, obviously, and it returns a single scalar value, as we discussed. And use case is very custom here when you have to do some aggregations, and the requirement is something where you cannot have something inbuilt PySpark. So obviously this is where you can use series to scalar. This is all about types of Pandas UDFs. And with that said, we are actually completed the Pandas intro. I really want you to revise these things. You can learn Pandas. There are a lot of tutorials, and even I will create a tutorial in future. But this is not something which is very much used in Databricks or in Spark. We majorly work with PySpark, or nowadays even there is Spark declarative pipelines which we use. But you should know Pandas UDF, because even though you are having a PySpark capabilities, this is something which can fast pace your development. And when you are sitting in interview and interviewer is asking about the UDF and you are talking about Pandas UDF, it will eventually help you to get the job, and it will help you to get a decent package also. Cool. Now it's the time to discuss about the latest Spark declarative pipelines, and this is coming to boom since Spark 4.1, and I am 100% sure that by 2027 this will be every company's preference. This is actually creating revolution in the Databricks environment. And even it's a open source, you can understand how big the impact will be. So definitely this is a revolutionary announcement which Databricks made in June 2025. Trust me guys, when you work with this Spark declarative pipelines, it is very, very easy and convenient to maintain the CDCs, to even implement the SCDs. If I say you that you need to implement SCD type 2, you will literally have to write at least 400 or 300 lines of code to implement the SCD type 2. But here we have a complete template to manage the SCD type 1 and type 2, and it is hardly of 7 or 8 lines. And that's why it is a revolutionary invention of Databricks, and it is definitely going to be the boom by 2027 or 2028. Mostly by 2027, because already it is point of conversation and companies started understanding these things, and in future you will be seeing this thing in the job descriptions as well, that we require a person who have hands-on experience on Spark declarative pipelines. This something which definitely you have to learn, and once you learn this you will be ahead of 95% of other persons, and you will definitely get prioritized when you had mentioned the Spark declarative pipelines in your resume. Interviewer will be very impressed, and you definitely gonna crack that job. But as it's me, it's Jaswinder, I literally don't go directly what is Spark declarative pipelines. I always prefer to help you with the problem statement, the evolutions which was happening and everything, right? So yeah, here also I will do the same thing. So first thing, I will help you understand what exactly the need of Spark declarative pipelines, why it was invented, and why Databricks is so much pushing this new framework. Okay. So what happened? This is the Databricks architecture. If I say more precisely, this is the Databricks architecture back in 2021 or 2020 or 2021. Okay, anything. You need to handle all the operational governance and the quality things on your own. It was a challenge, right? Because you need to spend ample amount of time in doing these things instead of directly going and jumping and getting your work done. This is where in 2021 Databricks introduced Delta Live Tables. What they said is that it will enable all the data engineers to streamline and democratize their ETL jobs, and it actually makes the ETL life cycle very easier, and it enables all the data engineers to build and leverage their own data pipelines by directly building the production ETL pipelines. They are very happy because they don't need to take care of any kind of operational governance and any kind of quality challenges. So by introducing this DLT, Databricks said that please just focus on this part, which I am just highlighting. So Databricks said that please focus on this part. All the other things I will take care of you. You don't need to spend your time here. This concept they name is Delta Live Tables, and these are not the tables. This is a framework which they introduced in May 2021. And this was a revolutionary framework because now lineage, operational things, governance, quality, I can literally leave these things to Databricks. Databricks had provided me some very quick functions in DLT library. So all I just need to focus was I just need to write the code either in SQL or in your PySpark, and you are done and dusted. And it was publicly available in June 2022. Since the time it was available, everybody started using Delta Live Table framework, and it actually helped a lot of companies in fast pacing their project deliverables. So now let's understand the Delta Live Tables definition as well. Delta Live Tables is a declarative framework. Yes, it it was not, it is not a vast thing. It is still there. Okay. It is just evolved, but it is still there. So Delta Live Table is a declarative framework on Databricks that simplifies the building, testing, and managing of data pipelines. Instead of writing complex script to orchestrate data, you simply define what data transformation you want using either SQL or Python, and DLT will automatically handles the infrastructure scheduling and any kind of error recoveries. So this fast paced the development in June 2022 when it was publicly available. A lot of good things was happening at that time, and it was very revolutionary. So let's talk about the key features. The first feature is its declarative pipeline design. You can declare the target state of your data and the framework automatically, which can track all the dependencies and even helps you in resolving them. And second is automated operations. It automatically manages all the cluster scaling, task orchestrations, error handling, and any kind of retries. So you don't need to care more about the operational perspective as well. The third is data quality, which we had already discussed. If your rule is failing, you can literally ask DLT to handle that thing. You can say, DLT, if my rule is failing, just give me warning, or just fail it out, or let's say just drop it, or anything you can do. You have now complete flexibility. The fourth one is batch and streaming. And obviously, it natively supports the streaming data and batch processing. By streaming data, I means obviously micro batches, right? And it allows you to use the exact same logic for both of kind of batch as well as the streaming processing of data. So when you have to create the Delta live tables, all you need to do is you need to mention create live table, and then you need to mention all your SQL if you are working with SQL. And if you are working with the Python, you need to import the DLT library, and then you can just use and get your work done. Here also you can see the clear example that this is how you define the live table pipelines. You don't need to worry about any operational infrastructure thing, any testing scenarios. Everything Delta live table framework will handle for you. So Jaswinder, we are clear with Delta live tables. We understood that it was a revolutionary thing, and Databricks introduced this thing in 2021, and since 2022 everybody started loving this thing. We understood this thing. Then why you mentioned the evolution? The thing is, guys, Databricks obviously introduced the DLT, but they introduced DLT as their proprietary closed source abstraction layer. This means you can only use DLT when you are having actually the Databricks subscription or additions. This was totally isolated within the Databricks. Okay, so let's say there is a company who had worked on all these DLT things and they had definitely built everything out in the Databricks. Now they decided, due to XYZ reason, they decided to move out of Databricks and go open source with Spark. You know what will happen in this case? Because this is the proprietary framework of Databricks, you cannot directly move out of the Databricks because DLT relies on custom Databricks APIs and all the decorators like import DLT. That was also the custom Databricks API. If you try to run this on Apache Spark, the code would immediately fail with the module not found error because DLT module was not existing in Apache Spark, right? It was only existing within the Databricks environment. If you have to migrate it, you need to redefine your codes because DLT library does not exist there. There is no concept of live table. You obviously need to reinvent the wheel, right? The second problem was complete loss of orchestration engine. Here in DLT, you just write your codes and automatically DLT framework ensures that your code are having a coordination between the workflows. So let's say you had a code in the row table and then you had written the code using the row table for the bronze layer, it will automatically detect that the row table is referenced in the bronze layer. So this means row table should be first and then the DAG will be having bronze layer. So this was automatically detected by DLT and this is still automatically detected. But things little bit changed. Change, I mean, little bit got more advanced, more helpful. Okay, but yeah, coming to the point, it was a complete loss of orchestration engine because you first is reinventing the wheel, and when you reinvent the wheel and you are now open source, you again need to define the orchestration things on your own. And obviously guys, if you remember, we used to use Airflow and ADFs. If you remember, even before DLT, if you have to schedule these things, people prefer ADF and Airflow and any other orchestration tools, right? That was the second major problem. The third major problem was the data quality rules. The thing was, DLT allowed developers to easily declare the data quality checks using simple configurations. Okay. And there we had a configuration like expectations. Okay. We have a configuration term in DLT which we call expectations. Okay. Don't worry, we will cover that out. But you just know that open source Spark have no native thing which can help you automatically declare the data quality frameworks. So if you have to leave the Databricks back in 2022 to 2025, something in these 3-4 years, engineers have to manually build the custom validation functions using Spark native commands, or you need to integrate with the third party libraries like Great Expectation Library. Okay. And then the fourth biggest challenge was you need to rewrite the incremental ingestion of CDC because features like SCD or handling CDC were built in DLT by the Databricks team. Okay. And it was provided to you as a simple declarative commands. But now you decided to move out of the Databricks, you need to replicate this in the open source Spark, which requires writing extensive boilerplate code like merge into or implementing your SCDs. And you need to manually manage all these streaming checkpoints. Can you understand the pain if you want to move out of Databricks at that time? So a lot of engineers was complaining that, hey Databricks, we are implementing the things in DLT. We love DLT. There is no problem. There is no doubt in our love. But if we want to go open source due to XYZ reason, we cannot have DLT there. So that's the pain for us. We need to reinvent the wheel. Please help us. Then Databricks decided in June 2025 to make the DLT as an open source framework. So in June 2025 in Databricks AI Summit, they announced that moving further, DLT will be an open source framework for everybody on this in whole world. When they made the DLT as an open source framework, that was a very, very big relief for a lot of data engineers, because some people really love to go using open source Apache Spark. I mean, even till now, many people use open source Apache Spark to get their things. Being DLT as a open source in the picture was a very, very big relief for everybody. Then once it gone open source, then Spark team, obviously Spark and Databricks was invented by the same team. Then Spark team added a few additional features and they named this DLT as Spark Declarative Pipelines. And that was the birth of Spark Declarative Pipelines. I guess it should be crystal clear to now what I had said till this moment. This is the time which gave birth to Spark Declarative Pipelines, or you also can say Lakeflow Databricks Declarative Pipelines. Some people say Databricks Declarative Pipelines. Anything is fine. Anything is fine. And again, this is open source. So open source give a lot of flexibility to the developers, right? So that's how Databricks evolved from 2021 to 2025, and now in 2026, Databricks declarative pipelines are the priority for most of the companies because it is minimizing my excessive overheads and it requires my data engineers to focus purely on the development part. That's why I had said in initial minutes that Spark declarative pipelines will be the future of data engineers. By 2027, this will be seen in the job descriptions as well. And this is already being seen in couple of companies' job descriptions. You can go to LinkedIn and you can see the Databricks jobs, and they are demanding this Spark declarative pipelines because it is now getting mature. So by 2027, I can literally bet that there will be very limited companies which won't be having Spark declarative pipelines in their JDs. That's the motivation for you guys to master this Spark declarative pipelines for Apache Spark 4.0. Okay, let me write this here. Apache Spark 4.1, not 4.0, 4.1. So this is the latest 4.1 and we will be focusing on this one. And by the way, this Spark declarative pipelines are not part of your examination. So as I initially mentioned that this complete course is your job ready plus examination ready plus to enable you for being a project ready person. So everything under a single place, right? So yeah, I am very excited to share all these things with you because as of now I'm recording it. So once I share it, I really want to get your feedbacks. I really want your blessings here. And please do like and subscribe to my channel. Now let's focus back and let's understand the Spark declarative pipeline definition. And if I just print it on your screen, you can literally see that it is very similar to DLT framework definition. Let's read this. Spark Declarative Pipelines is a framework built for Apache Spark that shifts data engineering from writing manual step-by-step scripts to simply declaring what data sets you want. So Spark Declarative Pipelines focus on what instead of how. You just need to work on what when you are working with Spark declarative pipelines. How these things will work, that's not your headache. That's Databricks headache. It automatically figures out the execution order, orchestrates all the dependencies, and handles the incremental data processing. And when I will show you this thing, guys, you gonna love this because if you had worked with any kind of SCDs, you know how much effort it take. And I am telling you in advance that I will create a SCD type 1 and type 2 for you within a minute. A minute, yes. That's the revolution, guys. Cool. Let's now discuss about the key components present in Apache Spark declarative pipelines. First is flows. Flows are nothing just a way where you define your logic and it creates a complete connection between the source and load the complete data with the process to the output tables. So this focus on what you want to do with transformation, and obviously the how part will be taken care by Spark declarative pipelines. So flow is a foundational stateful unit of computation. It reads data from sources, process it through user defined logic, and writes it to the target. Okay. This whole reading the thing, processing it, and writing it is nothing just the flow in Spark declarative pipelines. Cool. So as we just discussed, it focused on what data to transform and how, and that frameworks, all those things are managed by Spark. This is known as flows. Next is datasets. Datasets are the target objects which is generated by the flows. So you have a data in source, obviously you process the data, and there is a target which is formed with your flow, right? So that target object, we can call it as a data set, because that target is stored somewhere in your Databricks, right? So this is known as data set in context of Spark. Let's go with the definition. In Spark declarative pipelines, data sets are not just temporary in-memory objects, but are persistent managed entities that define the state and structure of your data infrastructure. So simply they are just saying that it is a target object which defines the state and infrastructure of your data, right? Because in target table, you have a complete structure, the state of the columns and all those information. So now we can have a flows stored with the three ways, okay, in the data sets. So that we call supported dataset types. Spark declarative pipelines have the three abstraction types which can manage the data sets. The first is streaming data, and that's self-explanatory, that we are consuming the data incrementally as the micro batches, and we are appending the stream to the data set. Second is materialized view. This is the view which pre-computes your results and it automatically updates any incremental changes happening to your data. Okay. So it is best for complex transformations, joins, or aggregations. The engine pre-computes the query results. That's important to note. Materialized views stores the pre-computed results. Okay. And automatically updates them incrementally when underlying data changes. Make sense? Cool. And third one is temporary view. Temporary views are just for holding the query and compute the results whenever there is a requirement to run the specific script. So obviously they are again reusable, but they are kept private in the pipeline and they are not exposed directly to the final data catalogs. So this is all about datasets. So flow is a process, that how you are getting the data from sources, how you are processing it, and how you are writing it into a target. And the data sets are the persistent storage objects which defines the state and infrastructure of the data. And then we had seen the type of ways where you can store the flows, like streaming tables, materialized views, and temporary views. There is one more component which is pipelines. And I guess you know what are pipelines, right? But still it is basically a DAG of all the components, right? So by components, I mean DAG which can contain one or more flows, right? And flows can be streaming tables, materialized views, correct? So it's just a process of encapsulating one or more flows in a single process, which basically forms a DAG. Let's now jump to the Databricks. I hope till the point you have your Databricks Community Edition, which is obviously free. If you don't have, just type Databricks Free Edition, and then you will be redirected to this Databricks website. And here, just click on sign up for free edition and create your account here. Cool. Now, once you log in into your Databricks workspace, this is how it will looks like. They are providing a learning section as well for the data engineers. That's really commendable. Then we have a workspace. Workspace, already you know what is workspace. And then catalogs and jobs and pipelines. And this is where we will be creating our Spark declarative pipelines. So as of now, I will just move. And then obviously in the free edition, the compute we will be having serverless. That's okay. And then we have marketplace and other couple of options, right? So it's a lot. Now let's first go to workspace and let's create a folder. That's the best practice. So the folder name, I will give it as SDP pipelines. I will click on create. Perfect. My folder is created. Now I will go to catalog and I will create a catalog as well as schema. So I will say create a catalog and I will mention my catalog name as SDP YouTube demo. Yeah, everything looks good. Then I will just click on create. Yeah, then I will click on configure catalog. Yeah, and then all workspace have access. I will say that. And then I will grant the browse option as well, principal as all account users. And I will provide all the grants. Yes, grant. Then I don't have any external destination. I will just click on next. And then I will just click on save. And perfect. I had created my SDP YouTube demo catalog. And now let me refresh this. And then inside this, I will create couple of schemas. First schema I will create is bronze. And then I will say create. Perfect. And then I will create two more schemas. I'll click on here. Second schema I will create is silver. Create. And third schema I will be creating is gold. Perfect. I will go to my bronze and here I will create a table and I will browse one CSV file and SDP underscore orders. Perfect. And the table name, I will give it as, let's say, row orders. Perfect. And then I will click on create table. My table is successfully created. Let's now also create the customers table. I will go to bronze and then I will click on create and create a new table. I will click on browse and I will just click on customers. And here I will name this as raw underscore customers. And yes, then I will click on create table. So we had successfully created bronze layer, gold layer and silver layer. Plus we had also defined two tables in the bronze layer. Now let's go to jobs and pipelines. And this is the place where we will be creating our Spark declarative pipelines. In order to create your first Spark declarative pipelines, just click on this create option and click on this ETL pipeline option. And this will open a new window where you have a folder called transformation, and inside the transformation folder you have a dummy my transformation.py file which is empty. So first thing first, I will name this pipeline as SDP pipeline 1. Click enter. Before doing anything here, you also need to ensure that one property is enabled in your setting which is related to Lakeflow. For that, click on your user icon here, then click on settings, and then you go to developer and here just search for Lakeflow. See guys, Lakeflow pipeline editor and ensure the Lakeflow pipeline editor is enabled. If it is not enabled, then you won't be able to work and run these things. By default, it is enabled only, and even this account is new account, but ensure that it is not disabled. Okay. So let's go back to our Lakeflow instance. And yeah, and now first thing first, let me explain you a couple of things. This is where you select your catalogs and schemas. So I am selecting my catalog as SDP YouTube, and then I am selecting my schema as silver schema. This is the target schema where we need to select. Okay, this is not the source schema. So once is selected, it will show you the default root folder. And I don't want that I am directly creating this pipeline inside my username. So I had already created a folder, and here I will just click on move to root folder. Then this is the folder which I had created as SDP pipelines. And then I will click on move. In this way, it will automatically move everything from this instance to that specific folder. Okay. And if you try to move this one by one or in any way, you might miss a couple of things. So it is the best practice to go here and then move your root folder to the respective folders. So now we had selected our catalog name and our target schema name. And then here we have the option to compute, which is serverless compute. And then there are a couple of settings which I had shown you that, as you can see, now my pipeline will be created inside the SDP pipeline folder, right? And then we have a source code which will be there in the transformations, and all the other information is available here. So this is one thing. The second thing is you can run the pipeline from here, you can share the pipeline from here, you can schedule the pipeline from here. And then in the bottom side, you have three options. First is tables, then performance, and then pipeline graph. And when you click on this pipeline graph, you should always try to have first dry run for the pipeline. Okay, we will do that. Now let me go to my workspace again, and I will go to my users, and I will go to my SDP pipelines, and this is my pipeline, and I will try to rename this pipeline, and I will say my first pipeline. I will click on OK, and that's it. Now let's go back to jobs and pipelines. And here I will click on my SDP pipeline underscore one. Then I will click on this edit pipeline. And first thing, I will connect my serverless server. And I will now try to do transformations on my bronze layer data, right? So I will create two files. First of all, let's go to my workspace, and let's go to all files. And here I will delete this file, my transformations.file. I will say move to trash. And instead of this, I will create two files. First, I will create my SQL file. I will name this as silver customer orders.sql. And then I will create another file, which is my Python file, silver customer orders.python.py. Cool. So now I will show you how you can work with PySpark as well as with SQL, because I know my community. Some of you guys are from Snowflake background and some of you guys are from Python background. So I need to ensure that both type of audience can work with the Databricks, right? So the best way is that instead of just going with my PySpark notebooks, I should also create SQL files in parallel so that they can actually see and implement either of them. If you say that, Jaswinder, which you personally prefer, then I personally prefer Python, or you can say PySpark. But I am not totally biased on the PySpark because dynamics are changing very fast, and now every platform is giving the SQL compatibility so that even data analysts can work with their tools, right? So yeah, let's start with SQL. I will first create a materialized view. I will give a heading, materialized views. And you already know what are materialized views, right? Even though you are from a Databricks background, I had explained you. And if you are from Snowflake background, you are very much versed what are materialized views. So I don't need to explain you here. So yes, so let's create the materialized view. In order to create the materialized view in SQL, we write create or refresh. Then I will say materialized view. Then obviously I will say if not exist in order to ensure the idempotency. Then I will give the name because I am going to create my materialized view in my silver schema. So I will name this as silver underscore customer underscore orders. Let's say silver underscore cust underscore orders. Okay. And then I will mention a comment because this is very important, guys. Commenting is the good practice, and I always recommend my team, my fellows, to have a meaningful comment in all your DDLs, even in all your columns. Okay, it's very, very good practice to have a proper commenting section. Okay, so let's say the comment I will say is cleaned and joined customers and orders dataset. Cool. Now I will mention alias, and then I will say select something something. Then I will go down. I will fill that later from my bronze layer, bronze dot orders, and I will name this as O. And see, guys, it is automatically guessing what I am looking for. So I will just click on tab. then I had successfully created my join between my orders and customer table based on my customer ID. Okay. And let's also pull all the columns. I will say O dot star, comma C dot star. And yeah, I guess this should work. Oh, I hadn't mentioned row. Actually, the tables are row underscore orders and row underscore customer. I guess here also it is wrong. Maybe I just put O dot customer ID. Yeah. Similarly, I need to put C dot customer ID. This looks good. I had fast forwarded and I had pulled all the required columns from my orders table and from my customers table. And now the first thing I will do is I will just click on this dry run option and I will see if this code is working as expected or not. Cool. And see guys, it had successfully ran and I can see the data inside this newly created table. I can also see the performance, how much time it take, how many rows it had read, and how many final rows it had written. So yeah, so let's minimize this, or even you can click on this X and then let's run this one. So I will just click on this run pipeline and it will start running my materialized view. And once this ran, I will show you the materialized view inside my silver schema. So it had ran successfully. Now I will go to another tab. I will click on this silver schema and I can clearly see my table. I will click on this table, silver customer orders, and I can see my table here. So now I can even query this table, and in order to see my data, I can just go to my this option and I will go to workspace and then I will go inside this and let's create a dummy notebook where I will just query from this one and I will just name this as testing notebook. Okay. And here I will just select SQL as option and I will just say select star from my SDP underscore. Let me click on catalog and my catalog name is SDP underscore YouTube underscore demo dot silver dot wow. I will just run this one. Shift plus enter. And see guys, it had successfully given me the joining result inside my materialized view. This is how we can create a materialized view using SQL. Now let's go back to your Spark declarative pipeline and then I will shift myself to my silver customer orders. And now it's the time to write the PySpark code to create the same table with a different name, right? This is also important. So yeah, for that first thing, I just need to import my library. I will say import PySpark. I will say from PySpark import pipelines. Then I will say from PySpark.sql, PySpark.sql, import functions. Let's say as F. Cool. And now I just need to define a decorator, which is dp.materialized view, materialize underscore view. And yeah, so this will ensure that my final output will be a materialized view. Cool. So inside this, I first need to mention the name of the materialized view. For that, I will just go to my this SQL file. I will copy paste the same name and I will add underscore py in the table name so that you can actually see that it had created another materialized view. Okay. And then I will also add a comment. Comment is equal to, I will just copy paste the comment from there only. And I will say control V. Yes, that looks good. Now I will define my function. Okay. And in order to define the function, obviously I need to say define silver underscore cusp underscore orders underscore pi. And then I will read both the tables which are there in my bronze layer. I will say orders underscore df is equal to spark dot read dot table. And then I will mention my location from the bronze layer. I will go to my SQL file and I will copy paste this from there. Control C and Control V. And then same thing I will do with the customer DF. I will literally copy paste this line. And yes, I will say DF. And then here I will say raw underscore customers. Yes, that's done. So now I have two data frames, which is holding my bronze layer data. So all I need to do is now I just need to return some output. And obviously, I need to join these two tables. So I will say orders underscore DF. And I will just name this as, let's say, O. And then I will say dot join. With whom I want to join? I want to join this with customer underscore DF. And on what basis I want to join this? And on what basis I need to join this? I need to put that here as well. I want to join this on the basis of customer underscore ID. Now we had written the code for materialized view. I had mentioned couple of columns. I will click on this pipeline and I will run this pipeline. Hopefully this should not give me any error. Actually, I should be first doing dry run. But yes, hopefully everything looks good to me. Yeah. So it started running both. It had done the full refresh and it had loaded the 524 records. And these records are same as my SQL records. And this is the expected, right? Because we are doing inner join in both SQL as well as in Python, which is good, which is good. So now all I just need to do is I just need to copy this name and I just need to check if this is also having the same count or not. So I will just copy paste here. I will copy all the other things and I will just change here from Python to SQL. And then I will just say select star. Hopefully this should work as well. And here I am not pulling all the columns as you had seen. I am pulling limited number of columns. So obviously in output, I am expecting limited number of columns. So yeah, as expected. 524 rows, 524 rows. Same output in both SQL as well as in Python. This is how you can utilize anything, either SQL and Python, and you can create the materialized view. Make sense? Similarly, you can create the temporary views as well. All you need to do is instead of materialize, you just need to mention temporary. See, it is already recommending me. I will just say this one. And here also in the orders.sql, instead of materialize, you just need to mention temporary and you are sorted. Cool. So this is how you can create materialized views as well as temporary views as per your requirement. Now let's try to insert couple of more records because this was the first time and it had processed all the records. Next time it should only process the incremental records, right? So I will just go to my notebook and I will just create a new code and I will just insert couple of more records inside my SDP YouTube demo catalog and then my bronze customers table. And the customer table, I guess it's raw underscore customer. Yes. So let me try to run this. It might fail because I had just created it using AI. So now this is done for the customers table. Similarly, inserted 5 records for my row orders as well. Now, if I go back to my pipeline and if I run both the pipelines, I will just click on this run pipeline. This time, it should process the incremental records. It's running both. Let's open any one. As of now, it is having 524 records. So it should increase the records. See guys, this time it is saying that it had incrementally pushed the data. It hadn't pushed all the records. It had only pushed the incremental records. So if I go to this one, and if I open this one, I can see now earlier I was having 524 rows. Now I am having, as per this notebook, as per my pipeline, I should be having 533. So let's cross verify this. I will just say control plus enter. I will just close this one. And see guys, it had successfully updated 533 records for my SQL as well as for my Python. Let me run my Python as well. And yeah, it is fetching the results. And cool. See guys, 533 for Python as well. This is how it incrementally pushes the data from bronze to silver. Then the next batch of data coming, it is not doing truncate and reload. I will just click on this X. Now let's create another pipeline for the streaming purposes. So I will click on these three dots and I will create a new file, which will be my streaming file. So I will say stream underscore customer underscore orders dot SQL. Okay, I will click on enter and let's start working with my streaming using SQL. So first thing first, I will just copy paste my materialize view code as it is here. And then instead of materialized, I will say streaming. Working with SQL is very easy, right? So then obviously I will just say underscore stream. Okay. And with Python, I will say underscore stream underscore Python. Okay. In this way, we can differentiate. So obviously streams are not views. These are tables. So I just need to change from view to table. Cool. So yeah, now I need to mention stream keyword here, which will order this SQL that please treat my row underscore orders table as a streaming table. And as you know that streams are append only, whenever I am doing the entry, it will keep on appending the data. Instead of calculating whether it's upsert like in materialized view, it will keep on appending your data. Cool. And I just want to mention the stream on my main table, which is my row underscore orders table. You can mention stream on both as well. It is fine. But as of now, I am just playing with one table. Now, I had created this table. I will just dry run this table. And hopefully this time it should not be giving me any errors because I had just copy pasted the already running code. Yes. So it is not giving me the error. So now I won't run this directly. I will show you the lineage. So in the lineage, you can see my materialized view, which we had created. And now you can see one more, which is known as streaming table. Makes sense? So this is how it is managing the things. So now obviously if I just click on this run pipeline, it will run all the things. Now I don't want to run everything. I just need to run my stream table. So I will just click on this run of stream table option. So it will start running my only stream table. Okay. And yeah, it is running. It is setting up my table. Yeah, it had successfully refreshed my streaming table. So let me go to my notebook and let me just create another code and I will just copy paste the name. This is the name of the table. And yeah, I will paste it here. I will select here SQL cell. And then I will just say select star from this one. And this should be working as expected. Yes, let me run this now. Perfect. So it had successfully streamed 533 records. If I insert more records, it will just keep on appending the records. Okay, so this is how stream works. I'm not going to insert it. I'm just leaving it to you guys. Whole motive of this Spark declarative pipelines is to help you understand that how you can work with SQL as well as Python and what are the functionalities which you can use, right? So I am leaving this insert check to you, but I am going to create the same Python file as well to show you the Python working as well. Okay, so let me go to here and let me go to pipeline graph and you can see that stream had ran successfully. Now I will just click on these three dots and I will create a new file. And this file is obviously Python file for the streaming. So I will just name this as stream cust order py Pi. Okay. Yes. Now again, I will just copy paste my existing code and I will change the things inside my existing code only. We'll just say Control C and I will paste my code here, Control V. First thing first, I just need to change from materialized view to streaming table decorator, streaming underscore table. So it is automatically creating a lineage for me, right? So this is the beauty. I will say silver, I will say silver, but I will just put stream in front. I will say stream underscore silver. That looks good. Then I will come down here and here I will again mention stream. Now I need to convert this into streaming tables, right? For that, I need to say read stream. Okay. And this will now start treating this orders data frame as a streaming data frame, and this raw table, it will treat as a streaming table. Cool. So yeah, I guess other things should be same. Yeah. Let me try to dry run this as well. It failed because I was mentioning streaming underscore table and there is no decorator naming streaming underscore table. I just need to mention dp dot table, and if I dry run this, hopefully this time it should pass. Yes, it had successfully dry ran all my 4 parallel files. So now it's the time that I just trigger this one. And it started running. I will just go to this performance. It started running and it is running. Perfect. It had ran successfully. This is how you can work with streaming as well. Let's see that data in the streaming table as well. We'll just go and I will just paste here. Change from Python to SQL and copy paste all the other details from here. Control V. Yes. Oh, it might fail. Just need to put modulus SQL and let's run this. And see guys, it had successfully processed my streaming table as well. And as you know, in my SQL, I am mentioning all the columns, so I am seeing all the columns. But in Python, I had mentioned couple of columns, so I am only seeing couple of columns. So this is how we work with streaming tables as well. And please do remember that streaming tables are append only. If the new data is coming, it will just keep on appending. It won't be doing any kind of upserts. Okay. Now let's create one table in silver as well, because we are just keep on creating the things inside the bronze as well as silver. We hadn't created anything in the gold layer, right? So we can see that in silver we have 2 materialized view, 2 streaming views using Python SQL, Python SQL. Let's create something in gold as well, right? It should not be looking empty. So for that, I just want to create a, let's say, a table or materialized table in the code layer. I will just copy paste this code here, and here a materialized view on top of my this streaming table. Okay, in the gold layer. For that, again, I will say at the rate dp dot, and then I need to mention the materialized view, and yes, and then I will open this bracket and I will copy paste my name and comment from here. I will just change silver to gold. Control V. I just need to maintain the indentation. Here I will say gold. Okay. Yes. So here instead of silver, this time I will change this to gold and I will click on save. Perfect. Now I just need to define the gold function as well. So I will try to copy paste wherever I can. Just copy this one and try to tweak this one only. I will say gold. And then I will say this as, let's say, gold df. And then here I need to say that dp.read. dp dot read. What do I want to read is I want to read this streaming Python. I will mention my Python here. Perfect. And obviously indentation issue. I just need to ensure that there is no indentation issue. Perfect. And then I will return. And what I will return is I will return gold underscore df dot. I will group by my product category. I will mention product underscore category. And then I will group by gender as well. Let's say I want to see gender aggregations as well. Then I will say .agg, as you already know how we work with PySpark. And then I will mention app.count of order ID. And I will just name this as, let's say, total orders. Perfect. And then in aggregation, I had mentioned first thing. Then I will again mention second column. I will just add a comma. And then second is, let's say, f dot count distinct. Count distinct. Perfect. And then I just want to count distinct product names. And I will just name this as total products, let's say. Perfect. I guess this should work. And yeah, let me try to dry run this as well. Now let's run this pipeline as well. And I guess by clicking on this run pipeline, I had triggered all the pipelines. But yeah, that's fine. But now, if you see, it is showing me the lineage from my streaming silver table to my materialized view gold table. So this is the beauty. And this was the capability of Delta Live tables, which was automatically creating the lineage for us. And we don't need to worry about the operational overheads, right? So this is automatically detecting that in my second materialized view, I am referencing the silver table. So that's where it had automatically created a lineage between gold and silver. Now, if I go here and if I just refresh it, I should be able to see my gold table as well. So maybe it might take time. Let me try to query this instead of waiting for this one. I will just go here. I will click on this code option. I will click on this SQL and then I will mention my dot gold dot my table name. My table name is gold customer Python. Let me, oops, let me run this and see, guys. It had aggregated the data based on my product category and gender, which I had mentioned. So now this is how it is showing the results in my gold layer. Cool. And it had also created a very beautiful lineage. Let's now discuss about another important construct used in Spark declarative pipelines. Those are append flow. What is append flow? So let's say this is my table, and more accurately, let's say this is my streaming table. Cool. So now what happens in streaming table? In streaming table, you just keep on appending your data, right? So it just keep on appending the data, right? So you are keep on appending the data. This individual stream table is by default known as append flow. Okay. So as the name suggests, append means adding at the end, right? So this by default is known as append flow streaming table. Make sense? Now, Jaswinder, we know that by default streaming table is appending the data. You said it is append flow. Makes sense to us. Then why Spark explicitly introduced the append flow? What is the significance behind it? Good question. So let's say you are having a multiple streaming table. Let me copy paste this one also. So let's say these are the three streaming tables. So let's say this is orders table from one country and this is the orders table from different countries. So let's say this orders table is only specific for India and this is for USA and this is for Mexico. So in this way, we are having couple of streaming tables which have all the columns same, but it represents as a different countries table. Okay, this is again hypothetical scenario. We are having couple of tables or specifically couple of streaming tables because append flow only and only works with streaming table. It does not work with materialized view. It can never work with temporary views. Okay, so now what happens? You have a final table as well. Okay, let's say this is not my final table. So now you need to append this table as well into this table. You need to append this one here as well, and you need to append this one here as well. This is where append flow can help you in getting the work done. Jaswinder, one more question. If we have a similar kind of multiple streaming tables, can't I just perform a union or union all between all these tables, and I can store the result of those union or union all select queries into my final target table? Yes, you can do that. Then why, Jaswinder, this Spark introduced the append flow? I don't see any significance. Help us understand why append flow is different. Cool. That question actually makes sense to me. So let's say you are doing union all between these three tables. Okay, let me do that. Let's say you are just considering all these three tables. Okay, and you are doing union or union all based on your requirement. Okay, let's say you are doing union all. Cool. Okay, you are doing union all. Everything is working fine. Okay, now tell me one thing. Let's say tomorrow this stream fails due to XYZ reason. Let's say due to schema evolution, stream table 2 got a new column. Or let's say there are some errors in the pipeline with the stream table 2 which made the stream table go down. Will the union all still work? No, right? It will eventually fail the complete box, isn't it? This is where append flow comes into picture, because it is not treating everything as a tightly coupled as you are doing here. You are completely coupling out the whole tables into a single query. You are doing tightly couplement. But append flow, let me remove this. But append flow is not doing any kind of tightly coupled. It is treating my table 1 as an isolated table. Similarly, it is treating my table 2 as a separate isolated table, and table 3 as a separate isolated table. In this way, if table B fails, it won't impact my final streaming table. It will still append all the data from table A as well as from table C. And it will wait till the time table B is getting fixed. Cool. This is the difference between doing a journal union all and using the append flow instead of doing the union all. Second impact is it will reduce the speed of the processing. Why and how, Jastinder? Think, guys. If you are combining all the tables, you are actually doing some calculations, right? You are actually creating first the complete data set, and then you are passing the data set to the final streaming table. So let's say stream A is having 3 GB of data, but due to XYZ reason, stream B got 100 GB of data. Will you wait for all the streams to be encapsulated first and then you will be appending it? No, right? You want that stream A, if is having 3 GB, just append it into my final stream. You want the stream B also the same thing. With stream C, you also want the same thing. But if you are doing union or union all, you are eventually slowing down the process by first combining the results of all the streams, and then you are going for appending. This will make your Spark engine process a lot of things, and it eventually results into the slower performance. These are the two reasons where append flow will come handy, because it is very loosely coupled. It don't care if the table B is having 3 GB or 10 GB, or it is failing or it is passing. The tables which are in healthy state, at least it will append those data, because it is streaming concept. In streaming, data should be available in the final layer as soon as we can. So that's where append flow differentiating my traditional union or union alls. Cool. Let's now implement the append flow. I will go back to my Databricks, and now I will create one new notebook. I will say create a new file, and the file name I am going to put is append. Now I will name this from Python to SQL, because first I want to show you SQL, as SQL is something which data analyst, data engineer, data scientist, everyone knows. So definitely, why not SQL? So yeah, let's create the append flow in SQL. But before creating the append flow, let's also write the definition of append flow. Okay, in order to, it is also important that I should give you the definition. So what is append flow? Append flow is a construct. It is a construct used to incrementally ingest or transform data by adding new records from source to target. And by add, obviously I mean append, right? And this is limited to streaming table. Limited to streaming table. You can't create append flows on the materialized or your temporary views. Okay, you can only create the append flow with the streaming tables. Cool. Now, as we are clear what is append flow, let's understand how we can implement the append flow using SQL. So for that, first, obviously, I need to create my streaming table. So I will say create or refresh my streaming table, and my streaming table name, let's say gold unified table, anything. Okay. Then obviously I will mention the comment. Comment is something which is non-negotiable for me, guys. I always prefer, let's say, consolidated table for all the data from multiple tables, multiple streams, not tables. Ensure that you are pulling data from streams. If you are pulling data from materialized views or temporary views, this will gonna fail, and you definitely will see this, and I will show you as well. Okay, so let's first try to load the data from these two stream tables, stream cust orders.py and stream cust orders.sql, because these two are the streaming tables. In order to load the data from the streaming tables, first thing we need to attach the first stream using the flows. Okay, let me give some comments as well. So first thing is declare the main target table. Okay. And it should only be declared exactly once. That is also important, right? Then second thing is attach the first streaming source flow. Okay, flow is very important here. We need to attach the streaming as a flow. Cool. So in order to do that, we just say create a flow, and my flow name, let's say append from Silver SQL. Okay. And then I will mention insert, because obviously I need to insert these things. Insert into this one by this error. Okay. I hadn't mentioned the semicolon here. Now this error is gone. So by name, this is the template. And then you will mention your query. Let's say select order underscore ID from my stream, and the stream name is, let's copy paste. I will open this one first, my Python file. Are you noticing one more thing? That I am interchangeably using the Python table as well as the SQL table, because obviously this is self-explanatory, right? That's what we can use Python, PySpark, SQL everywhere in this Databricks. So this is the first streaming source. In order to create the second streaming source, I again need to create the flow. I will just copy paste this. I will just copy paste this one down here, and I will just change the table name. Okay, in this time, I need to use my SQL table name. My SQL table name, let's copy paste from here. Control C, and then I will put Control V. Control V. Yes, that's it, guys. That's how we define the append flow when we have multiple streaming tables as the downstream tables. Let's try to dry run this, and hopefully this should work. Let's see. See. Yes. So this is the time that I should run this code. I won't click on this run pipeline. Obviously, I know that it will run all my 5 SQLs. So as you can see my beautiful lineage, I just need to run this gold unified table because this table is built on top of 2 streaming tables. And let me make it little bit big so that you can clearly see. Are you able to see? No, I guess. Yeah, now you should be able to see. Materialize view, streaming table, skimming table. So here I have an option to run this specific file. I will just click on this one and it will only run my appendflow.sql file. Let's go to the performance. It is running. And yeah, it had successfully started and it had considered both of the table to refresh into my final table. But if you had done union all, it will be only spinning one query log. And if that is failed, it will not be having any kind of data processed in your final table, right? But in this case, if you can see, it had spinned 2 query logs. So in production, hypothetically, let's say you are having 100 tables. So it will eventually spin 100 logs. So out of 100, even if 10 fails, 90 will at least will be processed successfully. This is the beauty of append flow that makes append flow different from union and union all. Cool. So now I told you that I will also show you that what will happen if I try to use the materialized view, right? Let me show you that as well. I will just copy paste this one below. And this time, instead of mentioning my streaming table, I will go to my materialized view file and I will copy paste my this materialized view table name. And now I will show you the error. This is also important so that you will never do the mistakes. Now let me dry run and let me show you the error. It failed. Why it failed? View problems. See guys. Oh, okay. This is my mistake. I cannot have a same name. So I just need to put here, let's say Matt. Now I should dry run this. No problem. We can literally rerun this. See guys. See guys. Spark runtime exception, Databricks exception, this exception, that exception. Why? Because you cannot process this materialized view. If you just remove this, or let's say if you just comment this out, everything will be in the perfect state. Let me dry run this again. See guys, everything is in the perfect state because append only never allows materialized views or temporary views to ingest the data. Okay, so you now are very clear that what is append flow. And now I am going to implement the append flow using Python. So now I will create one more file. I will name this as append flow underscore py. Append flow underscore py dot py. Now let's create Python append flow. For that, I will go to my Python notebook and I will copy paste my first 2 scripts which are importing some libraries. Then obviously first thing I need to create the unified streaming table, right? And in order to create that, all I need to do is I just need to mention dp dot create underscore streaming underscore table. That's it. That's it. Nothing more than that. Okay. dp dot create underscore streaming underscore table. Then I need to mention the table name. Let's say name of the table is gold table Python. Cool. Perfect. Then the second step, yes, append the flow for flow A. That's it. So in order to do that, I just need to mention dp. I just need to mention a new decorator, which is @dp dot append flow. That's it. It is really very easy to work with PySpark, right? I never face any hurdle. And if I do, no problem. We got our Jenny. Our Jenny bro is here to help us. So then I will mention my target table name. I will define my append flow. And obviously after name, I also need to mention the name. This is also very important, which will differentiate. I will say flow underscore A, and that's fine. And then no, sometimes it two mistakes, no problem. We can rectify this. I just need to mention my table name here. And yes, now I will just copy paste this for flow B as well. I will say this is for flow B, and here also it should be flow B. Yes, this looks okay. And now I just need to mention my table name, right? Everything looks okay to me. Just the table name I need to mention. And obviously for that, I will just I will go to my streaming one and I will copy paste my streaming table name, because as we are already know that we can only create append flow using the streaming tables. So first streaming table is done. Let's continue with the second Python streaming table. I will open this one and I will just copy paste this one as well. Yeah. Here, perfect. Yes, and I guess this should work. Let me dry run this and let's see if this is even working or not. I guess this will work because I was recently working with the append flow in my project. So there it was working. Oh, yeah. Sorry. I have to sometimes ignore the auto complete option because it had just created a disaster for me. Yes. Now I guess this should work. Let me try run this again. Yes. This worked. That's what I was thinking because I literally was using the append flow in my project and it was working fine. So yeah, that looks good to me. Now let's go one step back and go to this gold table Python, this one, and let me try to run this only end flow gold table Python. This one. Oops, I'm so fast. Yeah, this one. Let me click on this run option. It started running. Let me go to the performance tab. Yeah, it will run because if dry run is passed, there is very less probability that it might fail. So now again, it had created two locks, which is good, which is definitely good. It had ran also. Let's try to query this table quickly. I will just copy this and I will go to another tab. And here I will just mention select star from this one. Let's try to see the output. Oh, why? No. Okay, this is fine. This is fine. Okay. Oh, okay. I just need to mention my other things, which is this one. And copy paste. Control C, Control V. Hopefully this should work. Yes. Yeah, this is working. This is definitely working. And perfect. I got my outputs. This is how we can work using append flow. Got it? We had seen both SQL as well as Python. And if you ask me personally, I always prefer Python. Okay. Because you are working with Databricks and majority of the Databricks developers love Python. Okay. And we have to love Python, right? Because this is bread and butter for us, right? So yeah. But again, if you are from Snowflake background, if you are a data analyst, don't worry at all. Don't worry at all. Till the time you are already aware about Spark SQL, you know how we can implement the SQL within the data frames, everything you know. And now I am also telling you that how you can use SQL use within the Spark declarative pipelines. Where you will get this level of knowledge, guys? Nowhere, right? So that's all about append flow, guys. Cool. Now it's the very time that I will talk about CDCs in Databricks declarative pipelines. And this is an official documentation. And here they had mentioned a lot about how we can implement the CDC view within the declarative pipelines, and you can obviously read through that, and there is a lot of knowledge here. And here also you can get a lot of knowledge, and I had read that and I personally love this documentation, and so do you should love it. It's very helpful. Cool. So now it's the time to implement CDCs, right? So now we will be implementing both SCD type 1 and type 2. Okay. You will say, Jaswinder, we already implemented SCD type 1 and type 2 in our Databricks using PySpark or using SQL. But now there is a revolution which came in the declarative pipelines. Had you noticed the code which you had written for type 1, type 2? Can you give me a number that at least how many lines of code you need to write? At least maybe 100, maybe 150, right? But now what if I say that you can implement the type 1 and type 2 with just 7 or 8 lines of code, let's say. Wow. Yes, guys. This is now possible. You can implement SCD type 1 and SCD type 2 like that. Within a minute, within a 2 minutes, or let's say, you can literally do that very fast. There is a complete template provided by Databricks, and it is only of 7 to 8 lines. That's it. Isn't it this a revolutionary? This is revolutionary. And when I first seen this, I was totally shocked, because I used to write a lot of code to implement the especially type 2. And it sometimes even took me half day to implement the complete SCD type 2 for couple of tables. But now with this functionality which I am going to discuss with you, you can literally create the type 1 and type 2 within minutes, and doesn't matter it's a one table or 10 table or 100 tables. You can literally give one table at max 1.5 or 2 minutes and you are done and dusted. Wow. But before that, I am just guessing that you should know what is SCD type 1, what is CDC, and how slowly changing dimensions work. If you don't know, I don't know what you are doing then. Just go to Google, okay, and search modern data warehousing by Data2 and even you can go to my channel and you will find this very beautiful 3 hours modern data engineering tutorial covering all the required topics till date, which is there in the data warehousing. I had covered everything: data vault, data lakehouse, referential integrity, Apache Iceberg, Delta Lake, CDCs, implementing CDCs, and whatnot. You can literally watch this 3 hours tutorial and you will be someone who is ready to face the data architects in your team. If they say anything, you will be knowing the answers in advance. Okay, so please do consider watching this one, and this will be very helpful. After watching this one, if you are going to your architect and if architect is saying something, you will be very clear that what exactly he is saying. You will never be required to Google the things that I don't know what my architect is saying. I just need to circle back with some other person. Hey, what this said? Hey, what is this? You don't need to do that. Cool. Do watch this one. But if you already watched this, or you already know what are SCD type 1, type 2, how to implement them, you are sorted. Let's now jump directly into creating CDC file. And as always, I am going to start first with SQL. I will again click on this one, these 3 dots. I will click on create file and I will name this file as cdc.sql. Perfect, perfect. Now, do you remember append flow? Append flow is the younger brother of this CDC. What do you mean by younger brother, Jaswinder? Okay, you know append flow only works with streaming tables, right? CDC also works strictly with the streaming tables. This is why they are brothers. Okay, so yeah, now let's come back to the topic. First, obviously, I will also add the comment. Let's declare the streaming tables. Cool. So you already know how to declare it. create or refresh my table, and then the table name. And let's say table name is, because I am going to create this on my silver layer, so I am going to give this name as silver underscore customer underscore scd1. Okay, okay. Now again I need to mention the comment. I will say implementing SCD type 1. Then I will just copy paste below. I will put a colon. Then I will mention here SCD type 2, implementing SCD type 2. So now I had declared my streaming tables for both SCD type 1 and type 2. So obviously after declaring it, we need to apply CDC port SCD, let's say type 1 first. Okay. So what is type 1? It's absurd, right? Let's mention that. How will we do that? No, don't go with this auto recommendation. I sometimes I love it, sometimes I hate it. And this is the time when I hate it. Okay. So now in order to apply the CDCs, there is a specific template which is provided by Databricks Declarative framework. Okay. And this template is different for SQL and different for Python. Okay. So you need to learn this template, or you can even search it on Google and you will get it. What is a template? Template is apply. Then you will say changes. Then you will say into. Which table you want to apply the changes? I want to apply the changes on this SCD type 1. Cool. So what is why this is giving error? Because I hadn't put semicolon. No problem. Now, after that, from where I need to apply? From the stream, and the stream name is what? What, Jaswinder? You hadn't created any stream? No, I hadn't created any stream. Okay, no problem. But I have my scripts ready. I will go to my testing notebook. And here I am going to create a table inside my bronze layer. Okay. And then I am going to insert two entries. First entry, my name, my age, my city. And second, a dummy entry. Okay. Let me insert these two entries. Let me run this quickly. And yes, I had successfully inserted two records into my CDC raw customers table, right? Now I can use this table. Okay, I will say stream of, I will just copy paste it. Why to waste your time? Stream of this table. Okay, now I need to mention the keys. Keys means the primary key. I will say keys, and I need to mention all the keys. In this case, my primary key is customer ID. Okay, I will copy and I will paste it here. Customer ID. Okay, then I need to mention a column which is known as audit column. So what is the audit column in this case? In this case, my audit column is last updated date. And this column will help me in understanding the version of the record, right? So obviously I need this one as well. Without that, I cannot implement SCD. So I need to say sequence by, then I will mention my audit column name. And then last one is stored as SCD type 1. And this is the template of implementing SCD type 1. Make sense? Perfect. Perfect. Same thing, I will literally copy paste this complete one below, and I will just change type 1 to type 2. Instead of absurd, I will say historical. And here also I will say 2. And here I will also say 2. Oops. 2. And that it, guys. That's all. Wow, Jaswinder. Within minutes, we had implemented type 1 and type 2. Wow. Crazy, crazy, crazy things. Right? Let's try to dry run this. Dry run is running. And if you get stuck in anywhere, don't worry at all. Just call our bro Ginny. Ginny is very, very mature now. it easily answers all the question without creating much hallucinations. Okay. Anyway, our code ran. So now I will go to my pipeline graph. Okay. And now I need to run SCD type 1 and SCD type 2. I will just first increase it. And these are my SCD type 1 and type 2. Let me run this. SCD type 1 is running. Yes, it is running. And perfect. Type 1 ran successfully. Now let me run type 2 as well. So this is my type 2 and I will go to, oops. This is my type 2 and I will just click on this run option and it will start running my type 2 as well. Perfect. Perfect. So it had ran my type 2 almost. Yes. Now I can see my data because this is the initial data. Obviously, the end date will be null, right? And same way, if I just go to my testing script and I try to query my type 2, let me query it. I will say select star from type 1. Let me run this. Perfect. This is my type 1 data. And similarly, I will just query my type 2 data where I will be having end at null. Perfect. This is my initial data, so it does make sense to me. Now I will insert two new records. Earlier, my location was Amritsar. Now my location is Pune. And similarly, I am going to insert a new record. So in type 2, what should happen that my Amritsar one should have an end date, but my Pune should be having an end date as null, right? So let's insert them first. This is the existing record getting changed and this is the new record. And I had inserted both of the records. Let's try to run both SCD type 1 and type 2 again. Go to this one and I will click on this one again and it started running and let it run. So in type 1, it will change in place. Instead of Amritsar, I will immediately see Pune, right? Let's wait for this run to complete. I will stay on this data screen only to show you. See guys, the new record 103 came, but my existing record, which was having location Amritsar, now it's Pune. This means SCD type 1 is working fine. Very good. Very good. Now let's see SCD type 2. I will run this one quickly. And yeah, let me show you. As of now, my Amritsar is null. But after this run is completing, my Pune should be null and Amritsar should be having a date. Right? Let's see that. Run. Yes. Yes. See guys, now my Amritsar is having the date, which is expiry date. And now my location is Pune, so it is saying Pune and end date is null. Cool. That's how quickly we can implement SCD type 1 and SCD type 2. And I had just shown you with SQL. Now I will show you with PySpark as well. Let's create another file. I will click on create file and I will name this as Python CDC python.py. Cool. And obviously guys, I just need to rerun my insert create table scripts. I will just rerun this so that my table will only be having two records. Okay, because I need to just go into the initial phase. I am back into my initial phase. That's good. That's good. Now, first thing, as I always love to copy paste, I will copy paste. I will copy paste these things. And yes. Now I need to create the streaming tables and you already know, isn't it? Create streaming table. That's it. And then mention the table name. Name is equal to, let's say, silver customer, let's say, std1 and then py because we are using Python. Similarly, I will copy this one and I will paste below as it is. Just I will change std1 to std2. Perfect. So I had created the target streaming tables. Creating target streaming tables for CDC. Make sense? Perfect. Perfect. Now, obviously, let's implement SCD type 1. SCD type 1. Okay. So what is the syntax for that, Jaswinder? We have the inbuilt provided function by Databricks, which is known as create auto CDC flow. Wow. I will say dp dot create underscore auto underscore CDC underscore flow. That's it. That's it. Now I will mention couple of parameters like what is my target table name? What is my target table name? Obviously this one. Copy paste, copy paste, copy paste, Jaswinder. Quickly. You just told us that we can implement within a 1 minute. Show us in a minute. Cool. Now I will mention my source. What is my source? My source is my this table. Copy paste, Sundar, immediately do that. We don't have much time. Cool, cool, guys, cool. Now, obviously, next is keys. Mention your keys. What are your keys? Obviously, it's customer ID. Customer ID. Done. Done. Now, fourth, sequence by. It's same, right? You can see it's very similar to my cdc.sql. All the things are same. Last updated. Perfect. This is also done. And the last thing is, what is the last thing? Store as, right? So I will say stored. Oh my God, it is automatically recommending me. That's it, guys. Now I will copy paste it. And here my 1.5 or 2 minutes are completed. It's okay. Yeah, you can still say you failed, Jaswinder, but it's fine. I am okay. Because even though I had implemented in more than 2 minutes, I am still okay. I am 100% fine. Now let's do dry run. And if anything fails, no problem. We have our brother Ginny here. He is the lifesaver. Cool. Coming back to the topic, be professional, Jaswinder. Yeah. So it ran successfully. Okay. Let's go to performance. Not here. Let's go to my pipeline graph and let's run this Python CDCs. This, no, this is not these two. These are my Python CDCs. Let me run my SCD type 1 first and I will stay on the data. So I will see only 2 records and so do with my SCD type 2. But in SCD type 2, I should be having end date as null. Obviously, let's wait for a minute. I can see the records in type 1. Let's run type 2. Go here and just run this one. Go to my, okay, I will stay in data. I won't go to performance. Okay, it's running. Yes. Happy pass scenario. Perfect. Now let's insert the data. And before that, let me again show you here also. Oh, my table name is different. I'm so sorry. I just need to grab my table name. I will just click on this X button. And this is my table name now, Jaswinder. What you are doing? Just let me mention my actual table name so that you can see that everything is in the initial state. Perfect, Jaswinder. Now let me run this insert scripts again. Okay, it ran successfully. Now let me rerun the pipeline. I will expand this. I will go to pipeline graph and I will again run my type 1 first. So now again, my city is Amritsar. And once this will complete, my city will go from Amritsar to Pune. And there is another one new record and that will also come here. Let's see. The Swindar city is Pune now. Now it's the time to implement, not implement, to run type 2 as well. Let's run this. No problem. It's updating my data. And see, guys, Jaswinder was in Amritsar. So it had ended my Amritsar time. Now I am back to Pune. Anyway, this is how we can work with SCDs using Python and SCDs using SQL. and mention in the comment section which one you like the most. I personally loved this one, but obviously I can't just be biased with PySpark because I am also a Snowflake person. Okay, I also love Snowflake as well. I can use both and I am not biased toward PySpark. This is how we implement SCDs. Let's now discuss about the sinks. Sinks are like the reverse ETL, which can help you to process the data back into any kind of external systems, let's say Apache Kafka or any kind of external Delta instances. And these are very low latency operations. Okay, so the whole purpose of sinks is to write the data back to any kind of external destinations. Okay, so let's go with the definition now. In Databricks declarative pipelines, sinks are output destinations that let you write processed transform data to the target outside of my Databricks environment. So this is very helpful when you have to write data outside of your Databricks environment. Then you will use sinks. Either in your event hub you want to write data, either in your Kafka you want to write some data, either you have some kind of custom Python sinks, or either you want to write your data in some external delta table. So everything is possible using sinks. So if we talk about the supported sink types, obviously Delta Lake, where you can write your data within the Unity catalog as well as outside of the Unity catalog. And then it also supports Apache Kafka and Azure Event Hub, where you can stream data outside of your Databricks environment to any Kafka or any kind of events. Then we can obviously have a custom Python sinks as well, where you can store the data within your Spark Python data sources. Then there is a for each batch sink. This is the very custom level sink type where you can customize the batch by batch operations. If we talk about sink APIs, sinks are again the sibling of append flow. This means sync will only work with the streaming table and it won't work with any materialized views or temporary views, right? So in order to do hands-on on sync, Databricks declarative pipelines provide us two functions. First is create sync function, which is the most widely used function. And second is for each batch sync. This is a decorator which you can use for the custom logic. So it comes with a lot of flexibility to write all the custom logics. Let's now go back to the Databricks declarative pipelines and create the pipeline for the sinks. I am back on my Databricks environment. As sinks are something which require Databricks paid edition, then only you can write the data outside of the Databricks, but I am only having the serverless. So this means I can only write the data to the managed Unity catalog. Okay, so I will show you that only. For that, I just need to create a new file. I will click on this create file and I will name this file as, let's say, sync.py. And by the way, sinks are only supported in Python. You cannot write sinks using SQL. Okay, so this is the limitation. I had copy pasted my libraries. Now I will create a sink. In order to create a sink, we say pp.create underscore sink. You just seen it in my PPT, right? Then I will mention my sink name. First is name. And this is my target table name. You can say, I will say local, let's say silver, and then let's say order sync. And then I will mention my format, the target format. And I will say I want my target in Delta format. And then I will mention the options. What do I mean by option? By option, I mean the table name by which this sync should be getting created. So here I will mention my key, which is table name, and then I will mention the value, and my value will be the table name which I am expecting as the output. This is the name of the sync, and this is the table name which this sync will create for me as the output. So I will say SDP YouTube demo dot silver dot, let's say, sync underscore orders. So yes, this is how I had now defined the sync. So as the sync is the sibling of append flow, I need to mention append flow as well. So this is the template which we usually follow. Whenever we are defining the sync, we need to define the respective append flow as well. So what should be the target name? Target will be my same I will copy paste. This name will become my target for my append flow. Say target is equal to this name. Perfect. And then I will mention the name of this append flow. You can mention name first as well. That's fine. So let's say I will give this name as flow to delta sync. Okay. Let's say that. Yes. So this is how I had configured my append flow as well. And now I will create a function, let's say stream to local delta, because I am obviously storing the information in local. And then I will mention my stream name. Let's say I will create customer stream and I will say park dot read stream dot table, right? This is how we call. And then I will mention my table name, and for that I will go to my testing and I will copy paste this one. This is the table name which I created, row table. Let's use this one only. Yes. And then obviously I need to return. So I will say return, then I will say cust stream dot, let's say I'm looking for applying some filter, that my filter is that my customer ID should not be null. Let's say I will say f dot column and my column name is customer ID, and then what I want is not null. Cool, perfect. And then I also want to select some column. I will say select and I will mention a couple of columns. Let's say f dot column and I want column as, let's say, yeah, these only. Do I have these columns? Let me check quickly. I have customer ID, customer name, city, age. Customer ID is there. I just change this to customer name, customer name, customer name, and then I will say city. I will name this as city and then age. Age. Perfect. This looks good to me. Let me delete this one. Yes. Now I am going to dry run this first. I will click on the dry run and hopefully this should work. Yes. It had successfully ran. So now let me run this sync. I will click on this run pipeline. I will go to my pipeline graph. I will expand this a little bit and I will open my sync. And see guys, this sync had successfully worked and my whole pipeline ran successfully as expected. Now I will just go to my testing and I will try to see this sync. So how I can see this sync? I had written the sync inside this table, right? So I will just copy paste this table name, Control C. I will go to the tab and then here I will create new code. I will select SQL and here I will mention my select query, select star from this sync. Let's run this. See guys, it had successfully ran. This is not the ideal scenario where we are writing the sync within the Unity catalog itself, which is obviously self-managed by Databricks. This is just for tutorial purposes. Usually we use sync to write the data to the output destinations like Kafka or Event Hub or external data storage like S3 or anything like that. Okay, but as we are using the serverless and Databricks free community edition, so that's the limitation. I cannot go outside of my Databricks environment. So that's where I created the sync using the managed Databricks Unity catalog. Okay, but do keep in mind that this is not the general scenario for using the sync. This is just for letting you know that how you can create the syncs. Cool. Let's now discuss about another important topic which is very helpful for the data quality checks, and that is known as expectations. Okay. I will first create a file saying expectations.sql. What are expectations, Jaswinder? Expectations are just the data quality constraints which you can apply on your data sets. Okay, and this will act as a row level validation checks, and you can mention expectation as if you want to retain the row if it is violating the expectation, or you want to drop the row if it is violating the expectation, or you want to fail the complete flow. Okay, so it is very flexible. So let me write the definition first here. Expectations are how you implement the data quality constraints. Make sense? Within your data pipelines. This is known as expectations, mentioning the data quality constraints. So there are three type of expectations. First is if you want to retain by just giving some warning. Okay. And second type is if you want to drop the record which is not meeting the expectation, and third you can fail the complete pipeline if the expectations are not met. Make sense? This is all about expectations. Okay. So now let's obviously go and do the hands-on, and expectation are supported both with SQL as well as in Python. So definitely I will love to first create in SQL. So first, in order to create, I will create a streaming table. I will say create or refresh my streaming table, and I will give the table name, let's say silver orders, and let's say validated. And then here I will mention the constraints. It's very similar to mentioning the constraint in your DDLs. And then first constraint I want if my order ID is valid order ID or not. I will say valid order ID. This is my constraint name. And then I will mention a keyword which is expect. If I just mention expect, then if I mention the order ID, which is the column from my orders table, is not null. Okay. If I just mention this one, this is nothing, just the retain. It will just give me a warning in my output that order ID is null, but it won't drop or throw any error. Okay, so this is the retain behavior. Cool. Now I will just copy paste this one. I had validated my order ID. Let's also see if the sales is positive or not. So I will say positive sales. Cool. And here I just need to mention my column which will go as let's say sales amount. I don't know this column exists or not, but if this does not exist, I will create the column. Okay. So if the sales amount is greater than 0, till this time, this is again the retain behavior, right? Now, I don't want the retain behavior. I want the second type of behavior. In order to implement that, all I need to do is I just need to mention on violation. Then I will say drop the row. This is my second behavior. So what is this behavior? Drop behavior. Make sense? Perfect. Now I will again copy paste this one, and I will define my final behavior, which is fail behavior. So all I need to do is after violation, I just need to delete the drop row, and I just need to add fail, and I want fail to be updated in my logs. So I will say fail update, and that it guys, that's it. Now after mentioning the constraints, obviously I just need to mention the table. So I will just say as, and then I will start doing my select thing. I will say select, and I will pull my order ID column, order ID, and I will just name this as order underscore ID because I am using here order underscore ID. So I should be doing the same. Why don't I also do here order ID? Because I don't want the same things. Let's do here as well. Order ID greater than 0. That's the positive scale. Cool. So now order ID is there. What's next? Next is I need to get the sales, right? So do I have sales column? First, let me check. Let me do select star on this table and to see if I am having the sales column or not. Select star from, I will just move from Python to SQL, and let's see if I am having any sales column here. If I don't having, I will just change it to some other column. No problem at all. But I guess I have. But let's check it. Uh, 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 Sales. I have sales column. Perfect. Perfect. So this should work. So I will say I just want to, what is the data type? Data type is 1, 2. No problem. I will just say, let's cast it. That's a good practice, right? Because sometimes in future you might get other things. So I will say cast my sales as double. Cool. And then I will mention this as my sales amount. Perfect, perfect. And I need to mention my table. And obviously, this is also something which only work with stream. And then I will mention my table and I will say stream of this table. P and paste it here. And yes, this should work. Yeah, I just need to mention a comment that this is my fail behavior. Okay, perfect. Yes, I guess this is fine. This looks good to me. Let me dry run this. Oh, I am defining both as the positive sales. Oh no, I can't have two constraints with the same name. Obviously, it's a typo mistake. So let's fix this. No problem. I will say critical. Let's say ID check. So now this should work. Let me do try run again. And yes, this worked. As of now, I don't think I am having order ID as null and sales amount less than 0. I don't think so. So if I run this, it will run as expected, right? But I won't run this now. I will run both my expectation.sql and expectation.python.sql together. I had dry ran it. This means there is a high probability that there won't be any issues. So I will create a second py and I will name this as py expectations dot py. Cool. So now obviously I will just open any random Python file and copy paste both my libraries. Well, now remove this and then I will paste these here. And now here in SQL, I am having the expect keyword and same in PySpark, I am having expect. How to call it, Jaswinder? I just need to say @dp dot expect underscore all. And this is the default one. Which is the default one here? Default one was retain behavior. So this is my retain behavior. Cool. So now I will mention my names and my conditions, right? Because here also I had mentioned two things, the constraint name and my condition, right? So why don't I just copy paste this one only? So this is my name. This is the name. And then what I want in as the expectation, I want expectation as order ID is not null. Again, I will copy and paste this here. Cool. This looks good to me. Now let's take one more step and let's define the reasonable sales as well. Okay. Reasonable sales. And I will put the value as sales underscore amount should be less than, let's say, 10,000. Cool. This looks good. But why this error is coming? Oh, I hadn't defined the table, right? So I need to define the table as well, right? Here also I had defined the table. So same thing, I need to define the table here in Python as well, right? But just when you are doing, no problem. I will define the table. I will say df table and then I will define the name of the table. And let's say the name of the table will go like silver orders validated underscore Python and the comment which is important. Comment will go Python validation. Let's say now this looks good. And yes, again error. Oh, one more thing. This should be coming as a dictionary. Now this looks good. Now definitely this looks good. Expectation I am passing as dictionary in my PySpark. Second is I will say expect all or drop. So I need to mention @dp dot expect all or drop. Thanks for recommending Databricks. And then I will mention another dictionary. And let's say I'm looking for positive sales, positive underscore sales. And the value I am looking here is if my sales amount is greater than 0. Perfect. Yes. And then I will mention the third expectation @dp dot. Third expectation is of failure, right? So it will go expect or fail. Yeah. Expect or fail. Perfect. So now I will mention here again creating a dictionary. And then I will mention here, let's say critical ID check only, which I was doing. I will say critical ID check. And then I will mention my order ID is greater than 0. Perfect. Perfect. and this looks good to me. Now I will define my function. So I will say define silver orders validation pi. Let's say this only. And then I will say return. I will remove this and I will read this table. I will say spark dot read stream dot table, and I will copy my table name from my testing notebook. I will say Control C and I will paste it here. Perfect. And then I need to select couple of columns, right? So I will say dot select, and let's say I'm selecting f dot call, and first column I will be selecting, let's say, is order ID. Order ID. Perfect. And then I will mentioning the alias, and let's say I'm naming this as order underscore ID. Perfect. Similarly, I will pull my product name as well. And the final column I want to pull is, let's say, sales. F dot column sales. And then I will say dot alias sales amount. Yeah, and this looks good to me. Let me dry run this as well. And hopefully this should not be failing. Oh, it failed. That is also important. Failures are important part. Here, I guess I don't need to put colon. Instead of colon, I guess I need to put comma. And then also, this is not the dictionary. So I just need to remove this curly braces, and I guess this should work. Let me run this now. Hopefully this time I should not be getting the error. Yeah, this is working. Now I will run this. Initially, it won't fail both of my expectations. Reason? Because I'm not having any sales amount which is negative. I'm not having any order ID which is null or less than 0. And I'm not having any order ID which is null. And I am even not having any kind of other dependency. So hopefully these two should pass. So what I will do is I will just click on this run pipeline. And I will go to my pipeline graph lineage and I will open my expectations. The name of the expectations are Silver's order validated pi. I guess this one and then this one. Yes. Silver orders validated pi and silver order validated. These two are my expectations. Let me rename this something else. We'll name this as EXP, and then this one also I will name this as EXP. Because I'm not able to differentiate. Now I will rerun this. Now I can clearly differentiate that EXP means expectations. So both of my expectations had ran successfully because there are no constraint violations. Now let's create the constraint violation. So first violation I am going to create is order ID having null value. Okay, I will go to my testing, and I have this insert script from yesterday. So what I am going to do is I will just mention couple of nulls here. I will just enter and I will comment this one because I might need them. No problem. So yeah, let me run this one and let me insert some entries. In this case, I had inserted 3 entries. Cool. So now I need to again run this. One expectation is unmet. So maybe I should comment this in order to show you no problem at all. And here also, if I had mentioned this one, I will comment that this one expect or fail. Let me comment this. So now it should not be failing, or maybe let's go step by step. What I will do is I will comment this one also. I will only run my first retain behavior expectation. And here also I will comment my expect all or drop. Yes. Now let me try to rerun this. And this time I should not be getting the error, I should be getting the warnings. Hey guys, this time my expectations had not failed. This time it is giving me warnings. that I am having 3 values as null. See, it is showing me the fail percentage. It is showing me the expectations that 3 records are not having the valid order ID. So this is how you can work with expectation, having the default behavior where it is retaining the record but throwing the warning. Okay, now let me comment this one and uncomment my second one. Do I have anything where sales amount is 0? I don't think I have. But let's do that. No problem at all. I will just comment this one and I will uncomment this one. And let's try to run this now. I guess sales amount is null also. So maybe that is also a violation. Let's see that. No problem. We can literally see that. Let me go to my performance tab. Okay, it's running. That's fine. This had ran successfully. This means if the sales amount is having any nulls, it had dropped those columns. As of now, I'm not seeing any drop because there are no sales amount which is less than 0 because they are null. They are not less than 0. But let's do that. Let's add a sales amount as negative. That is also something which is important. So I will say other column as sales. I guess sales. Perfect, sales. So inside the sales, the value will be minus 200.7045. And let me enter and let me comment them as well. Yes, let me do this entry now. Now my sales amount is negative. So it should drop one record. Let me run this. Now it is saying one expectation is unmet. Why? Because I had inserted a record with negative value and it is violating my expectation, right? So let me open this and you can see that there is one record which is violating the positive sales. This is how we can work with expectations, guys. It's really cool thing, right? So this is from SQL. You can also see the same in my Python as well. I will show you the Python as well. We should not be skipping the Python part because I know you are Python people. See, here also one is unmet. Cool. Dot underscore Python file. And earlier I was showing you expectation silver orders validated file. So here also same thing happened. One is unmet. Cool. Perfect. The third one and the final one. It's nothing like you need to implement this one by one and comment it out. You can implement all together because I had put the wrong conditions. That's why I need to do this way. Yeah. Now let me comment this one and let me uncomment this one. Now again, I need to insert the order ID with negative value. No problem. We can happily do that. I will say minus of 20. Order ID is minus of 20. Cool. Let me run this again. I had inserted one record. Yes. And now let me run this. And this time, both of my expectations should fail. Right? Let me see the performance directly. And here only I can see and log the failures. See guys, both of them failed. If I open my SQL one, the failure is saying one unmet and thus it is throwing the action as failure. And if I open my Python one, let me go back and open my Python's same error I will be getting here. One unmet and it is failing because critical ID check code failed. And number of records which was detected is 1 because I had only inserted one negative order ID. This is all about expectation and this is how we work with expectations. Cool. Now as we are done with expectations and syncs and everything, the last part of the Spark declarative pipelines is to schedule the pipelines, right? And the best part is that you can schedule the Spark declarative pipelines with your SQL as well as your Python notebooks. So let me show you how we can schedule the Spark declarative pipelines with our traditional notebooks. Okay. So now you know that these are my all the files, including Python as well as SQL files. So if I just go here and if I show you pipeline graph, and this is how this complete lineage looks like. And now what I am going to do is I am going to click on the jobs and pipelines, and I can see my ETL pipeline here. This is not the job. This is ETL pipeline. Okay. So I just need to click on this create option and I need to click on jobs. And you can see they had given the details that what is job. Job is to orchestrate notebooks, pipelines, queries, and more. And what is ETL pipeline? ETL pipeline is to build ETL pipelines using SQL as well as Python. And then we have ingestion pipelines. This is for ingesting data from popular applications and databases and any kind of popular file sources. Cool. As part of Spark declarative pipelines, we had built the ETL pipelines. But in order to schedule the pipeline, I need to click on the job. I will click here and then a very beautiful interface will open in front of me. And first thing first, I will name this as ETL schedule, let's say. Cool. Yes. And now I get an option called add another task. So I will click on this option. And what I need to add first, I want to add ETL pipeline first. So I will click here and I will name this pipeline as SDP pipeline, or let's say SDP demo YouTube. Cool. So this is a pipeline. I will say save and continue. And then I need to mention the pipeline. And this is my pipeline. I will just select my pipeline. Perfect. And then do I need to make any retries? I don't want any retries. I just want to run this only once. And any duration threshold if I want. No, I don't want anything. I am okay. Any notifications if I want, maybe I can add some notification. I can select email address and then I can mention my email on which I want to receive the notifications. Okay. And then I can have the success notification, failure notification, any other start notification as well. Then I can click on save. Okay. If you want, obviously that's project to project, but you should know that. Cool. So I don't need any duration threshold, so that's fine. So all I will do is I will just click on this save task. And I had successfully created my first ETL task. Now, after this task, I want to schedule this testing notebook as well so that it can automatically run and it can show me the results. Okay. Then I will again click on this add task and this time I want to schedule my notebook. I will click on notebook and I will name this as, let's say, testing. And then I need to select my path. I will go to users. Then I will go to my email. And then here I will go to SDP pipelines and SDP pipelines and testing. Cool. Then I will click on confirm. Perfect. So I had selected my notebook and it is depending on my SDP demo YouTube. That's fine. That's what I want. And do I have any parameters? No, it don't require any parameters at all. Then I will click on this create task. And I had successfully created my pipeline. Now I need to schedule this pipeline. So here in the side option, if I close again and if I open again this button, I have an option called schedules and triggers. Okay. So I will click here on add trigger and how I want to schedule. Do I want to have a scheduled? Do I want to trigger this when the file is arriving, any table update or any other operation? I want to schedule this. So I will click on schedule. Then it is asking me the interval or it is asking me the schedule, anything I can select. Then I need to select the frequency. Is it every day or every minute? Let's say I want every 1 minute. Okay, and then I will click on this save. And this had successfully updated my schedule as well. Now I will go to this runs and I will wait for a minute to see if this had scheduled and it had ran as expected or not. And see guys, it had started running and you can see that it is launched by the scheduler. It is not launched manually. Okay, I will show you manually as well. but you can clearly see that it is now running state. And if I just click on this one, I will be seeing the running job as well. This is how we can work with scheduling the ETL pipelines as well as the notebooks within the Databricks interface. Make sense? That's all about Spark declarative pipelines, guys. And see, guys, once the schedule one is running, because I had scheduled for every 1 minute, it immediately queued my next schedule. And once the first pipe will complete the run, it will immediately trigger my second schedule. Okay, see, the third schedule is also triggered. This is how scheduling works. Let me stop the scheduling. I will just go and I will say edit trigger, and I will click on trigger status post, and then I will say save. Okay, so in this way, I had posed my schedules and I will let this run. It's fine for me. And yeah, that's all about scheduling. So maybe I will kill this. I will cancel this run as well. I will cancel this run as well. And I will show you that what if I manually run it. If I just click on this run now, it will be saying launched by manually. Okay. So this is how scheduling works. Cool. Now again, I will cancel this. And I can see in the logs that it is showing the status of run, cancelled, and everything out. And I guess it even will give me the email because I had configured the email. Let me open my Gmail. And you can see, guys, it is throwing the error that did by Databricks that your run has been terminated and your pipeline has failed. Because I had mentioned that if my pipeline is failing, please send me the email as well. Make sense? Perfect. Perfect. That's all about Spark declarative pipelines, guys. Please do revise these topics. These are very, very important and these are very future proof topics. Cool. With that said, we had literally covered the complete Apache Spark tutorial, and I really want to congratulate each and every one of you who had reached till this point. I really want to know who had 100% completed this tutorial. Do comment your experience in the comment section. I will love to see those comments. Thank you so much for watching, and let me know what next you want on this channel, and I will love to create that. Thank you. Thank you so much. Do consider subscribing. Have a really nice day. Bye bye.